is, the less current you get, the more thrust you get per watt. And that's also been verified in some scholarly papers, but they didn't do as many experiments as I did. So, you know, I you know, searched down that path quite a bit. So also other ways to get, so I'll rewind again here, back to, I had gone with the flyback power supplies like people are tending to do nowadays. And then I found that you could run with lower current. So I looked into ignition coils for other sources of high voltage. And I went, you know, obviously automotive ignition coils, the old fashioned ones, were big and heavy. So I switched over to motorcycle ignition coils, which are, you know, epoxy insulated. And then I found some that were, it actually had a core that was, you know, ferrite core that ran at a higher frequency, and those were smaller. So I just assembled them and started making my own and grinding my own cores out of ferrite. And then I looked into power supplies, like in the old laptop computers before they had LED lit screens. They had little high voltage transformers, a little strip. I don't know if you guys are, who all have seen those, but any electronics person would know about that. And those little high voltage transformers are very small and light, high frequency. And when they're connected to a voltage multiplier, you get real high voltage DC at low current, which is what we need. You know? So, so I went to that step, and I was disassembling those and making my own versions of those. So, you know, it went from a huge, heavy power supply down to smaller and smaller, higher frequency systems. And then I found a way to make a voltage multiplier that's just a single line of capacitors. It's really not all that different than a standard voltage multiplier. But so how am I doing so far? Is this educational? Good? Okay, good. This novel, semi-novel voltage multiplier, you put all the capacitors in a row, right? But electrically, it's pretty much the same as not the same, but it's similar to a Cockcroft-Walton half-wave voltage multiplier. Now, a full-wave Cockcroft-Walton voltage multiplier has many more parts, right? And each part's losing electricity. And it's better for if you want higher currents, but it's not better if you want the most, you know, a high voltage source that's extremely lightweight and efficient at low current. So what I found is that if you want to make a ion-propelled vehicle fly, it's going to work better. It works better, a VTOL version especially, works better with a half-wave multiplier. And furthermore, if your multiplier is reverse polarity, so you put all the diodes so they're facing towards the base of the multiplier, then you end up with your inverter being charged at a positive polarity, right? And here's the way I think of electricity too, is that electricity is the flow of electrons and energy, right? Through and around a wire. I don't think anybody would argue with that. But, well, most people wouldn't argue with it, hopefully. So if you put the reason that coronas are created, another thing, people call a corona wire because it tends to produce a glowing, you know, if you turn the lights out, you can see it glowing in the dark. But whenever you build an ion-propelled vehicle, if you see anything glowing in the dark, it's really, generally speaking, it's a power loss. So what you want to do is insulate anything that's glowing. You put the emitter wires up real high, and you use emitter wires that are only microns in diameter. And then you can get rid of most of the corona, because corona is caused by the de-excitation of oxygen molecules, mostly. Depending on, at higher currents, you have some nitrogen things going on, but that's at very high currents. So at normal power levels, you have you know, when a oxygen molecules oxygen likes to grab extra electrons because it's electronegative, and naturally, so it grabs up electrons in the outer orbitals of the molecules, and and when it grabs electrons, it kind of swells up with extra electron, and it doesn't give off any photons. But when it loses an electron, it gives off a photon, and that's why you see that glowing, that corona, is because it's oxygen molecules de-exciting, losing electricity. So it's possible to make a vehicle that flies with by just adding electrons to that oxygen. You don't have to reach the ionization potential that you would, like with a xenon thruster, for instance. You can get super efficient ion propulsion by just adding electrons to oxygen molecules. So anyway, so I've gone from history of it, and I started going into the physics of it, right? More on the theoretical end, but it's not really theoretical. I've double checked all this stuff. So with some serious people, so it's correct and it makes sense. And so what you want for an efficient vehicle, to go fully into talking about how the thing's made, how to get more efficiency, thrust per watt, and so on, more power for the amount of energy you put in. People usually speak in thrust in terms of newtons. You're supposed to do that, but I like to speak in terms of grams because I use all gram scales to measure everything, right? And why bother to convert it, just an extra step. So, what you want is the basic specifications of mine are, after many iterations, like a ridiculous number of experiments, I found that the most lift you can get from a collector surface is with a collector that's teardrop shaped from a cross section, and that's 4 millimeters wide and about 12 millimeters tall, right? If you have a taller collector, you get a little bit more thrust, but it weighs twice as much, So most of the thrust comes from the front curvature of that collector. So I had good luck with 4 millimeter by 12 millimeter. When I went to different dimensions, the results weren't quite as good on a thrust to weight basis. So, and then the emitter wires, I kept getting them thinner and thinner. And I found out tungsten is the only wire you can make really thin that you can work with. So I use tungsten emitter wires, and I use a horizontal support for those. They're actually glued, the tungsten emitter wires, to a special support, horizontal support. They're not freestanding emitter wires like on a lifter, right? On a regular lifter, right? You just take regular magnet wire and you strip at least the bottom of it off, maybe all of it, and you run it between the posts. But on this thing, you have a special filament, no stretch, high temperature filament, and I glue the emitter wire to that filament. The emitter wire is crazy thin, it's like a cobweb almost, but made out of tungsten. So with that setup, you can get a lot more voltage pressure with a lot less, with very low currents. And the collector on mine is very lightweight per foot, per meter, however you want to look at it. So the basic vehicle, the one that flew vertically, lifted its power supply for almost 2 minutes, has about 59 feet, or almost roughly 20 meters of collector, concentric rings for the collector. If you took them all out and straightened them out, they'd be 59 feet, something like 20 meters long. And that only weighs just a few grams for the actual collector part. And then the frame that holds those collectors up is made of boron filaments, which is it's like a rigid wire, but it has hardly any weight at all. And so I have these like spoke-like wires that support the collectors, and they're non-conductive, at least on the outside, and they're held by filaments, support filaments. So that gives a very lightweight collector, and then emitter wires, these that are 15.2 millimeters tall, which is about, it's like 6.5 inches tall. Well, actually 6 inches tall. A lifter has like 2 centimeter. It depends on the version, but much lower. Standard lifter has low emitter wires. People would buy a power supply and they, with some good current to it, and then they hook it up and they start putting emitter wires lower and lower because it gets more and more lift, right? But the thing is that it takes more current more wattage per gram of lift that you do get. Is everybody still there? The pictures are changing around. Okay. So it's more efficient to have the emitter wires higher, even though there's less overall lift per foot per length, unit of length. You're getting, you need to get it needs to produce a lot of grams of lift per watt in order to be able to not overwhelm the lithium polymer batteries, because that's kind of like the weak link, right? Is those batteries. So you got your batteries, and you got a little transmitter, or I have a buck converter, batteries, buck converter, which is a step down regulator, and then you have your a receiver, and then that drives a throttling MOSFET and a MOSFET driver, and that goes to your little transformer. The transformers I use are described in the patent. I found that if you have a transformer that's very low profile, drum shaped, like a shirt button, like a little bigger than these shirt buttons, right? Between 7 and 14 millimeters in diameter and about 3 millimeters tall, you can wind your transformer like that and get very, very high efficiency levels and very high voltages for low current, applications like this. A lot of thrust per weight and a lot of power per weight. So I run that into a 20-stage voltage multiplier. Like I said, it's got all the capacitors in a row, spaced at intervals, and that, if you have a shorter voltage multiplier, if you look at it with a Corona camera, I don't know if everybody here is familiar with the Corona camera. Everybody's familiar with the IR camera, probably, right? Like IR camera, you see, heat, infrared, and those are very useful for telling where you have power losses in the circuit. But there's a Corona camera, which is usually used for looking up at power lines and seeing where there's a part that's starting to give off Corona. And you can see, if you look at a ion-propelled vehicle or a lifter with it, you can see any spot where it's giving off Corona. It's much more sensitive than just looking at your vehicle in a dark room. So I found out that a voltage multiplier that is short and stubby builds up a big ball of Corona on one end and on the other end, right? Especially on the negative end. And so what happens is, if you make a longer voltage multiplier, the electrons aren't going to be migrating, because from one side of the voltage multiplier to the other. Also, you could have a long, thick, well-insulated, output wire, but it doesn't work as well because you want to save every bit of electricity you can, right? Every electron you can to make these things work. So, are you still with me, Tim? I can't hear anybody. Okay. Well, you hear me, you guys? Okay, good. Okay. So I've gone into some pretty heavy details here. I'm trying to be, absolutely clear about how everything works. You got this long, thin voltage multiplier, and you run it between the emitter and collector surfaces, right, which are 6 inches apart, emitter and collector. And you don't want any of that high voltage circuit to be shorter than 6 inches, because all the power is going to go to that point. All that high voltage will look for the path of least resistance. So you make sure that your voltage multiplier runs from all the way from the emitter to the collector surfaces, and then and then I have my inverter on top of the vehicle, because I found that a reverse voltage multiplier is more efficient than a forward biased one, a positive voltage multiplier. So those are the technical details and some of the history of it. It's 23 years of stuff in like 10 minutes. So it'd be nice if if anybody has any questions. Otherwise, I can keep going about this, but so let's see. Oh, I see somebody gave me a nice comment. That's nice. From Tom Gazillo to everyone question. From Rick to everyone. Oh, do I have diagrams? I have in the 2 patents on my Ethan Krauss YouTube channel. There's about 40 flight videos of different versions of these things. One of them shows the transformer close-up being bench tested, and there's under all the videos there's the patents, and they have diagrams of everything. So so anyway, oh, thank you for putting that out. I appreciate that. So, oh, good. I have the questions up on the side now. So, okay. So I'm trying to make everything as clear as I can. This is a mainstream thing that I have. It's not a unproven or something. This has been flown in front of many people. Many very serious people that can't be doubted too easily. And somebody mentioned about space. I have a big vacuum chamber in one of my shops, and it's pretty big. It's bigger than a coffee table, around those outdoor coffee tables. And I put a vehicle in it to test it, and the vehicle is almost as big as the chamber. And so I had to turn the vehicle on its side and get up in the chamber with it to plug the battery in, which, with all that voltage and the weight of the chamber and everything, it was, quite a bit. Oh, okay. Somebody mentioned, do I use balsa wood and aluminum? And no, I don't. Aluminum foil is quite heavy. When if those wings, if you stretch them all out, there'd be 59 feet on the smallest version that carries its power supply, and 59 feet of foil comes out to be quite a bit of weight, 20 meters of foil. So what I use is different thicknesses of aluminized I used aluminized polypropylene. Distance to collector, between collector and emitter, I mentioned before, is 15.2 centimeters, which is about 6 inches. Photos are, I don't have it set up right now to show a presentation along with my speech, but Ethan Krauss YouTube channel, will show everything you want to know. And plus there's a website, Electron LLC.org, that has some more details. But somebody wants some hard numbers for voltages and thrusts. The current voltage multiplier, the current high voltage systems, when they're bench tested, they output 42 kilovolts, which is it makes a 14 millimeter spark. And they draw about the ones that create enough lift to lift themselves draw about 1.5 amps. But that's on 100% throttle. So the vehicles take off on about 40% throttle. Somebody said they uploaded the patents. Good. I don't mind if inventors make this thing. I'm not trying to stop anybody from experimenting with ion propulsion. I would love to see some people replicate what I've done. You know, it's just if somebody else does it and then they said, look, I'm the first one ever, and take my stuff, and then they make, you know, $50 million, and they don't share it with me. That's not very nice, you know. So somebody asked if I was exploring different waveform shapes and frequencies. Yes, you want to get the best frequency for a given transformer, you know, and generally the higher the frequency, the smaller the transformer that you can use, and smaller capacitors. But the thing is that you know, ferrites have a limit as to how high of a frequency they will, you know, they have an ideal frequency they work at. So you know, you can only go so high with the frequency. So the last transformer I measured, it was running at 380 kilohertz. But if you, like I said, you got to adjust it until you get the most throughput, you know. So and you do that by changing capacitors around and inductors, but mainly capacitors. So oh yeah, somebody asked if I got some thrust in the vacuum chamber. I left you guys hanging on that. So I got the thing in the vacuum chamber, and I didn't expect it to produce thrust in the vacuum chamber without a propellant, so I added a propellant when it was in the chamber. And I had a little tube going in from an oxygen cylinder. First, I tried it with SF6 and outside of the chamber, and it actually got less lift. It didn't, you know, which was somewhat expected, you know. So I switched back to oxygen as a propellant, and it got a little bit better lift with pure oxygen, you know, being distributed over the top of the vehicle. So then I put it in the chamber with repellent tube running in through the bottom of the chamber, but I tried it without even pumping the chamber down, and all the lift went away, because the chamber blocks the sides of the vehicle, right? The vehicle fits right in the chamber. The sides are all blocked. A lot of the air on this thing comes into the sides. A lot of, you know, so when the sides are blocked, and the top of the chamber is you know, covers the top of it too. So there just wasn't enough flow for it to fly in the chamber, even when it wasn't pumped down. So I'm going to have to try the vacuum tests with a smaller vehicle. So boron, tungsten, oh, thanks. Somebody said they're loving the talk. Thank you too. What are you planning to do with this? Somebody said. Yes, I'm going to commercialize it. I started off with making aluminized the collector surfaces out of aluminized polypropylene. The inner rings are thinner polypropylenes, and the outer rings are a little bit thicker because they have to be stronger. And it varied from about 4 to 8 microns in wall thickness, which is very thin. You know, it saves a lot of weight. But the problem with the aluminum is after a couple of weeks, there's too much aluminum oxide, and the craft wouldn't fly anymore, because the aluminum builds an oxide when you put it out in the air. So then a few years later, I ordered some polypropylenes covered with silver, metallized with silver, because the silver doesn't oxidize. But even pure silver will tarnish after a while, which is a reaction with hydrogen sulfide in the air. So I tried to make containers for them to protect them, but they still are tarnishing. So the next step is to put a few 100 milligrams of gold on the collectors, and that's going to be the next vehicle will have absolutely reliable collector surfaces. And somebody wants to know the details on the power supplies. I just went over in the first part of the speech in pretty good detail. It's a push. I use push pull. I don't like flybacks. It's okay to get a flyback transformer if you modify it, for like off-board power supplies. But how much of the power dynamics do you describe the geometry? Let's see here. I'm reading a question. Most of this isn't my power supply. A lot of people assume At first, they assume that ion propulsion requires a lot of power. There's not so much true anymore. You can do it with lower power. Just have to use high voltage at low current. And then the geometry of the structure is the main thing. You want those incredibly thin emitter wires at a very high distance, and you need a lot of collector surface to get lift from a small power supply.
Oh, and Ethan, sorry to jump in. I'm wondering, would you want me to do kind of a moderated Q&A session? Do you want me to call on people, have them raise their hands, or?
Well, I'm just kind of reading what people's questions are on the right. I see them
Okay.
By the screen. It's kind of, I didn't have that before.
Oh yeah, and no, that's totally cool. Whatever you're comfortable with,
Please interject whatever you want. If you think the conversation could go in a different direction somewhat, please.
Oh no, this is your time. I'm just trying to be helpful.
I'm just winging it. I'm just telling you how it works.
No, it's wonderful. It's wonderful to share that. Yeah, whatever helps you. And again, if you do decide you want to do screen share, we can do screen share. Or if you want to answer questions from chat like you have been, that's totally fine. Yeah, let me apologize for interrupting.
I'm just answering chat questions, I guess, unless something comes to mind that it seems to be of great importance. The main thing to know is that this device really works, and I've shown it to all kinds of officials, and it follows physics very closely. This is not a physics, a device that breaks physics in any way. It's,
Yeah, well, and if I could offer a thought, I've read that Ionocraft have a very high ISP also, right? So I think that was one of the things, and I think you'd put that in your patents. That
I wanted to mention, about that is that it's recently been proven. Somebody made a space thruster with high voltage instead of like 3,000 volts, which to me is not really high voltage. It is, but instead of 3,000 volts, they made a space thruster with 30,000 volts. And it's much more efficient, so much better ISP. So the speed of those particles is proportional to the voltage. So this has a lot of possibility for wonderful ISP in space. But to make it work in a vacuum, a person has to either add propellant for that in that case, or they have to have millions of volts. So. What would be the expected ISP in a vacuum? The worst it could possibly be 10 times better, but we have to get enough thrust too. These are other issues. Those things aren't proven yet. I still have to do vacuum tests. How high voltage do I use? 42 kilovolts is typically, but I'm working and experimenting with far higher voltages. Let me see here. My wife was pointing out some questions to me. Avalanche energy uses similar voltage in the current. Let's see here. 12 electrodes because they only produce a small amount of energy. I don't really know what that. I don't understand the question there. Anyway, but so what is the thrust to weight? Somebody asked me. It's greater than 1 to 1. It's about 1.2 to 1. It depends on the vehicle. See, in order to fly with a steering system, I had to put a huge extra outer ring, and which is segmented, right? And with 4 quadrants. And I alternately energize, I de-energize one of those outer quadrants, and it will lean in that direction of the de-energized quadrant, right? But the outer ring weighs more, and and it takes more power to run the switches. There's 2 little switches that are used for steering, onboard switches. So by the time you factor all that in, then it's like the lift is then like 1 point, just over 1 to 1, 1.1 maybe to 1. But without the steering system, it's more like, 1.2 or 3 to 1. Well, maybe not 1.3, but can lift a little. I've carried 2 little propellant tanks before on board. They're very small, but I didn't understand the question about the internal combustion engines and the 12 spark plugs, but just a comment. Okay, that's cool. So yeah, I am available to work with universities. The next steps with a business plan, Charles asked. I'm, the patent is available for licensing, and basically I'm looking for, investors and people that will donate to, I got to buy that gold coated, polypropylene, and pay some people to help me, because it's all me, sitting there doing the fine work, and I can only do work so fast, and so I would like, it'd be nice to have a team working on it with me.
Well, now, Ethan, if I could jump in, and it's probably not fair because I'm moderating, but have you ever considered using, because you have functional ion propulsion, have you ever considered using an offset of some kind of, like, basically helium balloon, right? And creating some kind of a dirigible, and then you could, in essence, you could create kind of a drone where all you would have to worry about is the propulsion, and then you could have just neutral buoyancy from the helium.
Right. Well, I have done that, and the first guy to do that that I know of was in 1977, all the way back then, when I never heard of this stuff before. And he made something for the military that flew around in a hangar, but it was quite slow, But I mean, that's pretty amazing. All the way back then, he was doing it. I mean, you can lift anything with a balloon, with a blimp, but it's not as cool as. It doesn't have as far-reaching, as a heavier than air thing potential, as excuse the pun, is a heavier than air vehicle. So back in 2003, I think it was, I made a balloon that's sort of flattened shaped, helium balloon, sort of flattened shaped rocket looking thing. I made it with clear balloon plastic, and I hung a power supply under it and a big lifter device, and I could connect up the power wires, and it would float up to the ceiling with the power supply on board. And then I would disconnect the wires, and it would come back down again. But, it wasn't very fast. And I decided then, I thought, I'm going to make one with onboard power. I kept trying to do it, and it wasn't clear whether it was possible at first, and eventually I got that to work. So it will be much more efficient very soon, because right now about half of the power is used up in the transformer, because I have to really crank it up a bit, to get it to work well, especially at the end of the flight. And the transformer is running kind of hot. It's on the beginning of the saturation curve for the ferrite. So, that's once I get rid of that, make a little better transformer, change a few things. It should fly more like 4 or 5 minutes instead of 2 minutes. Somebody said, well, on flight, does the prototype react to wind resistance in ordinary and unexpected aeronautic ways? It did accelerate a little faster than I expected into the wind. Well, yeah, into the wind somewhat, but it's very sensitive to wind, and so I had to wait for a day when it's not windy to fly it outside. But I'm looking forward. I expect it to be improved soon. So, and I do see the potential for much stronger thrust as well. Somebody asked if I'm open to visits. Yes, I am. Anytime, just give me a call and set something up, and people can come see what I got. Now, this month, my vehicle that I have is all beat up. So it's it's not going to do any shows this month. It'll be like next month, right? And I'm waiting on a quote from the guy with the gold coating machine, but I will then be showing it to everybody, So again, yeah. Somebody says he's not sure it'll work in a vacuum, since it is using ions, not electrons, to generate thrust. They probably didn't hear I mentioned that in a vacuum, on the vacuum model, I add propellant to it. So it's the same as the ion propulsion, as a NASA ion thruster, but it uses much higher voltages and optimized geometry and low weight. So is the voltage on the emitter constant 0 hertz, or is it pulse? It's pretty constant. It has a slight a ripple, but it's pretty much constant DC. super high voltage, very low current DC. It's kind of like, you know, when you rub your feet on the carpet and you get a spark and you touch a doorknob, it's very low current. It's not really terribly dangerous, but it's, you know, it's DC. And somebody asked if there's a benefit to using pulse voltage. Like a few weeks ago, I would have said no, because I used to make 555 little clock circuits years ago, and I used pulses, and it didn't show any more efficiency with them. But the actual answer is yes. It gives a little bit more efficiency to pulse the current, because when I take off on the vehicles, you know, when the vehicles used to take off about, you know, several months ago at 40% throttle, that comes out to be, you know, take off on 40% throttle, but when the batteries that charge up to 8.4 volts got down to 6 volts, the craft wouldn't fly anymore, right? So this indicates to me that using pulse width modulation gives you a little bit more efficiency. Nothing spectacular, but it's notable. You know, basically a throttle. You know, just use a throttle and turn it down a little, you know, from a standard receiver. Sublimation provides a small number of ions under vacuum with high voltages. Yes. Yeah, there are things going on in a vacuum. For one thing, when you you know, when people measure the currents in these things, some of it's missing. It doesn't all just go to the collector and then neutralize and that's it. A lot of it leaks away. And when I was flying a vehicle in the early 2000s, almost a 6-foot one in a garage, my pant legs would charge up with static electricity. And I thought, you know, there's charged particles coming out of this thing for sure. You know, they're not all neutralizing on the collector. So, you know, and then recent measurements, somebody found that 10% of the current was missing from it. So, you know, I like my original experiment where my pants charged up. That's pretty conclusive to me, you know, that some of the electrons are getting away below the vehicle. So maybe even in a vacuum, you know, any kind of electron beam action there is going to create some bits of lift. But any real lift, you know, it would need to have either millions of volts for a real electron beam, you know, intense electron beams, or it would need to have a propellant added for that in that case, small amounts of propellant. Do I communicate with John Louis Nauden? I have sent him a letter once, and he responded. And he has an awesome website, and I think he does really cool stuff, and it's inspiring. He's a great person. So, but other than that, I don't know what to say about that. Who do I get? Did you communicate with Nauden or other ion scientists? Yeah, I've tried to send letters to most people, you know, and I'm always happy to hear from anybody. And I get inspired from everybody that works on the subject, you know. And Tim's very inspiring with his monster flying machines. So, you know. Did I say it? Yes? I did say theoretically a craft with millions of volts will work in a vacuum. Theoretically, it'll produce tens of grams of lift, but it hasn't been tested yet. So, you know, until the proof's in the pudding, you know. Since the thrust rate ratio is over 1, how possible would it be to use it for delivery of a CubeSat to orbit? Well, you know, vacuum tests have to be done, and I don't really know the ISP 100% until it's done in a vacuum. I don't know if I can get enough lift for it to keep going, you know, out of the, you know, when the air gets too thin, because you got to start adding propellant at that point. So those things are just not known yet, you know, and I can estimate and I can calculate what it should happen. I'm not familiar with John Paul, no. Airship to orbit. I am familiar with that. Yes, as a matter of fact, actually. I think it's great. Absolutely great. But I don't know much about it. I specialize in, just on Ionocraft experiment, ion propulsion experiments. Yeah, and experiments designed to make my device carry its power supply, be more reliable and efficient, and work on the steering of it and so on. So night vision intensifier tubes. That's interesting. I've never disassembled one before. I have one, but I kind of hate to take it apart. It costs several $100s. But anyway, it's a good idea. It's interesting. I should maybe look at the schematics online. But I don't think, it's hard to get something lighter than what I made. I made my power supply specifically for this, to shave off every milligram I could. So, and to make it as efficient as I could. So, considering live stream on YouTube, I have done another thing. Well, it's not live. I haven't considered that. I don't consider myself much of a talker. I'm more of a guy that deals with, a few equations and a soldering iron. I keep busy with that. So, but there is another program, a short one. Well, not short. There's another one with Bradley Wistance, where he asked me a bunch of questions, but this one's more in depth, I think. So even that one. So looked into dielectrics between it can be a good thing to put a insulator between the emitter and collector, but you're adding weight, and so not really, so far the best results have been from following the paths that I've been following so far. Somebody asked, how's the steering work and how do you control charge? Charles asked, how do you control charge on different segments? Okay, I in the old Seversky patents, which many of you may have seen, Seversky was the first guy to make a device with a huge external power supply take off straight up into the air, and he had a steering system that would de-energize or energize different quadrants. Right, his vehicle was cut up into 4 pieces, and he would cut off the power to one side, and it would turn to that side, and so on. But if you do that with this vehicle, there's too much power loss because it creates a bunch of extra corners. So what I had to do was, go back to the original model that works, and then put a extra ring around the outside of it. I'm skipping over a bunch of iterations, different designs, but by putting an extra ring around the outside of it and segmenting that, the vehicle was able to lift that extra ring, and then I keep the extra ring energized as well, and then I just cut off power to one segment at a time. And I have a little tiny circuit with two little switches, and I call them, and springs on it. I call them whisker springs. They look like little whiskers of guitar string, right? Very thin stuff, and it makes the the little it's got 2 little there's servos and there's actuators. I switched over to actuators because they're lighter, 2 tiny actuators, and they keep all the quadrants connected. They're 2 3-way switches, and all the quadrants are normally connected, and then when you want to turn in a certain direction, you shut off one of those quadrants just on the outer ring. And the way that high voltage is switched is with a tiny switch that has springs that normally they're all on, and then when it starts to move one direction, it disconnects one of the quadrants. So, and that's connected through the tiny receiver I have.
Wonderful, and I think we've got just about 4 minutes left. So I'm not sure. I'm not sure if you want to wrap things up, or if you had more. Or
well, it's been a long odyssey for me. A lot of hours doing this, and just by doing it a lot persistently, I got lucky, I guess, in several different ways with it. But I'm still working on it now, trying to make it better. And I just want to thank you guys very much for having me on for a visit. And it's great to see Tim in real life. It's like a celebrity, and is a celebrity. And it's great people that are interested in this subject. I know you guys have been doing this a long time yourselves, or some of you, anytime anybody wants to talk about it, would like to chat about the subject, I would love to, to get it, to talk about it. So,
well, on that note, then, Ethan, let me do this. Let me put this on gallery view, and I want everyone to give you an enormous applause, for Mr. Ethan Krauss. Ethan, you've done something. I never did this. You're the only person I know of who has been able to make an onboard power supply work. I mean, that's a tremendous achievement that pushes everything forward in that area. So, again, I mean, it's an honor to have you on to talk about this. So thank you again, sir.
Thank you. Same to you.
Okay, well, so next we're just about at the top of the hour, and again, everyone, thank you so much for all the support. Thank you to Ethan for presenting. So next we have Mr. Dave Rossi, and let me find my speaking notes here. Sorry, and there we go. Okay, so Dave Rossi is going to share insights gathered from his research into metric manipulation and via mass, understanding time, vacuum extractability, interferometry, and much more. Dave is the founder of SAALT LLC, a company focused on providing solutions to various elements of consciousness, ZPE, propulsion, potentially medical benefits, and much more. So let me see. Let me go to Mr. Dave Rossi, or Dave Zed, as he is known. He has a podcast. He is much more famous than I am. I'm not famous.
Well, first off, let me just say thank you so much, Tim, for everything that you've been doing. I've been very silently over the last probably 7-8 months, just jumping in. I'd like to give a shout out to Jeremy Riss as well. He's the reason that I was even able to jump into all this from the beginning. Ethan, sir, thank you so very much for your work, and to everyone here. Honestly, I'm just very passionate about the pursuit of whether theoretically or in the laboratory that everyone has here. So what I'm about to show you guys, I'm going to share my screen and show you guys a video which is about just over 30 minutes. The reason it's a video is because truthfully I've presented a varied version of what you're about to see to multiple departments of the DoD, so I needed to get it approved, and this is the most that I could showcase publicly. I'm doing my absolute best to not just speak theoretically but also practically as well. And I agree with Tim on Ethan's work. Ethan, I really like that example, sir, of the rubbing your feet on the carpet and touching the doorknob and getting a spark. I really appreciate that, sir. So I'm going to mute myself now, and I will share my screen with my sound and begin the presentation.
Am I still on video?
Right, good morning, good afternoon, or good evening, everyone. My name is David Rossi. Some of you may in fact know me by Dave Zed. I host and run the YouTube channel Generation Z, where we focus on a multitude of different aspects pertaining to the sciences, physics, all of that, you name it. But I'm also the founder and CEO of SAALT LLC, which stands for Strategic Analysis and Assessment of Longitudinal Technologies. I'm extremely grateful, humbled, and delighted to be here, and I would like to state that before we move forward with this presentation, I would like to thank all of you for being understanding of this being a pre-recording, simply because I did in fact need approval for this presentation to be publicly presented. So the reason I call today's presentation A New Perspective on Old Physics is because I would dare to postulate that what we call classical mechanics or classical physics, whether theoretically the models on paper or in the laboratory, are by definition being put on notice by quantum mechanics, particularly in the different areas in which SED, stochastic electrodynamics, has found a way over the decades to merge a semi-classical concept of physics with a quantum unification, which has then ultimately led to the discussion of, stochastic electrodynamics being on its last leg, and that merging itself into the overall quantum unification of such. Hence why I call today's presentation A New Perspective on Old Physics, specifically focusing on mass, time, vacuum extractability, and quantum unification. Now, before starting this presentation, to give an overarching concept of more so the philosophical motivation behind this, is that according to Dr. Niels Bohr, there are trivial truths and then there are great truths. The opposite of a trivial truth is plainly false, but the opposite of a great truth is also true. What's interesting about this is that I find there to be a unique correlation between this particular quote, obviously the rest of the presentation that I'll be giving today, in addition to a claim that we could all potentially agree on here as people that are interested in the sciences in a multitude of areas, which is that a New York Times article from May 4th, 1935, over 100 years ago, discusses how Einstein attacks quantum theory because he finds it is not complete even though it is correct, which speaks again to what I just brought up a minute or two ago, this sort of mergence between a semi-classical model and a quantum unification, if there could be one, if at all. I'm claiming in today's presentation there in fact is, and there are a multitude of avenues to pursue in order to obtain a unification of such, or a sort of, I guess we could call theory of everything or unified field theory, whether in the laboratory or theoretically, both numbers and practicality. So, let's start very simply with basic Newtonian physics and, of course, the Lorentz force. We see here on our screen that all of you are familiar with the Lorentz force equation, in addition to the concept of being able to spark a charge proportional to acceleration in order to get an object to move in general. Hence why Newton correctly stated force equals mass times acceleration, because when you apply a force or a charge proportional to acceleration, that object will in fact be able to move. Now, when that object is moved, however it is moved in the laboratory or in general or anything of the sort, right? What ends up happening is, according to a lot of people, whether it's Dr. Sarfati, Dr. Paez, Dr. Puthoff, with the concepts of the vacuum and the super force and the 0-point energy, we see that there may in fact be vacuum fluctuations after this object is being moved. Vacuum fluctuations literally in what we would call empty space, which would denote the possibility of an ether. It is very similar to the energetic equivalent of putting a microphone to a speaker and getting a non-stop squeal. The particles generate the fields then, I guess we could say, collect the particle fluctuations and then quote-unquote spit out new or fresh particles, if you will. So it is one giant cosmological feedback system overall. As a matter of fact, I will say, without getting too ahead of myself, when looking, whether in the laboratory, but I will focus on the theoretical modeling and calculations, if one accounts for, even including a semi-classical model, whether it's Hamiltonian or Lagrangian functions, one can find that if one treats the vacuum or the 0-point fluctuation background as a real phenomena, if you will, the numbers begin to fall into place a lot more easier. With that said, I noticed some very peculiar similarities over the decades, as a matter of fact, even over the millennia. We see on the far left-hand side the infinity symbol, in which we are all familiar with. We see in the center part of our screen here, we see the Ouroboros, which seems to be quite reminiscent of the infinity symbol. And then on the far right-hand side, I would like to point your folks' attention to a presentation by Dr. Puthoff, in which was conducted, I believe, I could be wrong here, but in Stockholm in the 1990s, where we see that even Dr. Puthoff himself had claimed that the particles generate the fields allow the particles to fluctuate, and it's a constant giant cosmological feedback system, very similar to that of a toroid field. With that said, I would like to point out that I found a very peculiar historical pattern, particularly pertaining to the far left-hand side, which is one of Dr. Salvatore Paez's patents, in addition to the middle picture of on the screen here, which is from, I believe, the 1400s when the Knights Templars were in ancient Egypt, approximately. And at the very bottom, we see here what I have not coined personally, but would call pine cones kissing, if you will, from ancient Samaria and Mesopotamia. Now, when we take these three images and we cross-reference them with the quantum viewpoint of the hydrogen wave function on the right-hand side, we find some very interesting similarities with respects to the visual geometries of such. Now, this then brings us to a postulation in which I am postulating that Newton's third law is wrong. In other words, for every action there is not a reaction so much as there is an anti-action. Anti, specifically meaning the ability to perturb and manipulate a consequence of an initial and or inertial action from the gauge symmetry point of view within the local metric of whatever one is effectuating or attempting to effectuate. Now the question then becomes, if so, what would these anti-actions be based on? I would like to point everyone very strongly to Dr. Pudov's paper, Electromagnetic Potentials Basis for Energy Density and Power Flux, particularly where he says here in his background discussion, quote, "Though little discussed, there exists a rich literature on alternative definitions of electromagnetic energy density and power flux, the general purpose of which has been to attempt to bring clarity to some of the ambiguities associated with the standard definitions," end quote. Again, what we're seeing here is that the potentials themselves, the electromagnetic potentials, are the foundation for this new type of energetic phenomenon, dare I say, allowing for COP, coefficient of performance over 1, to occur, not just in a power sense of being able to power the home, but perhaps even in a propulsion sense, and in many other areas as well, but we'll stick with propulsion and inertia for today's presentation, generally speaking. So one doesn't have to believe me or have to, again, listen precisely to what I'm saying or adequately, so much as one would need to even look at Richard Feynman's quotes, and we see here that the source of such quotations and lectures are cited accurately down below, and I quote, "In the general theory of quantum electrodynamics, one takes the vector and scalar potentials as the fundamental quantities in a set of equations that replace the Maxwell equations. The E and B fields, the electric and magnetic fields, are slowly disappearing from the modern expression of physical laws, and they are being replaced by A and phi, or again, the magnetic vector potential and the magnetic flux itself. As a matter of fact, fun little side note or side story, this is just a general approximation of the story, but when Richard Feynman and John Wheeler had found that the A field could in fact be separated from the B field, particularly within that of utilizing the Del-Cross operator, it was thought, because of the amount of power extraction from the potentials, of which we see here Dr. Pudov is arguing, that it was initially thought that the power, because of how, I guess you could say, extravagant it was, the output compared to the input, was vastly outdoing the input. And so it was thought initially that this was just an artifact of the mathematics. People thought, my gosh, it can't be possible, but it turns out that there's enough energy in the room that you are sitting in, theoretically, to evaporate all of the world's oceans, if you could get it all up in the room. But this is in fact feasible and has been calculated. Now, I would like to focus particularly on the Lamb shift. Willis Lamb was awarded the Nobel Prize for showcasing that the vacuum's alteration, and to be specific, when I say the vacuum, I say the ether, I'm speaking of what we'd call empty space. The vacuum's alteration of the energy level of an electron resides within the hydrogen atom, which is interesting because the difference in energy frequency units, or the bandwidth, if you will, is a very particular number in the megahertz range, which is something I would like everyone to very kindly keep in mind. And the energy density of such exceeds that of the sun's surface, which speaks to the idea that if it could be extracted, if this power could be extracted via mechanisms like the Lamb shift or Casimir effect or van der Waals forces or anything like this, the numbers seem to substantiate the ability to, again, attain such vast amounts of power. Now, the question then becomes, could this be used practically? Could it be extracted for practical use? Such may imply, when I mean such, I'm speaking to the Lamb shift concept, that when the vectors are summed to zero, both theoretically and in the laboratory, the potentials become more quote-unquote real than the fields themselves, due to making something real, quote-unquote, from nothing, or from empty space, which ideally would speak to the concept of as above, so below philosophically. It would speak to this idea of, again, order from chaos, something from nothing, generally speaking, merging physics with metaphysics, and I will be more specific, I assure you. And I also would like to state that I agree very avidly and strongly with Dr. Sal Paez when he says that science without philosophy is like a seed without water. Now, when the vectors are summed to zero, such may allow for thermodynamic manipulation, perturbation, and extraction from the vacuum for practical use purposes. This then suggests, as I had previously mentioned, that the A field, the magnetic vector potential field, can be separated from the B field, theoretically using that of the del Krauss operator, which allows for integral-relativistic implementations of the Dirac equation in 3D without runaways. I would like to very kindly point to the work of people like Dr. Rueda, Dr. Bernache, forgive me the names off the top of my head, Dr. Pudov, Dr. Sarfati, Dr. Davis, many others, I will say. Forgive me if I have not mentioned all the names in which I feel I am obligated to give credit to. Now, to my knowledge, this is where things get interesting. No Western university has calculated the magnitude of a potential, which is interesting. The question becomes, why? I think it's because if one goes to read the original papers, circa mid to late 1800s, not what someone wrote about the papers, but the actual original sources, Gibbs, Heaviside, Maxwell, Lorentz, Poynting, we will find that even the standard Poynting theorem, of which is generally all of our engineering models are based off of today, in practicality as well, the standard Poynting theorem denotes that a potential is infinite and reaches out far way past the wire. So for example, if electricity does not run through the copper wire, it hugs the wire. And then the magnitude of the potential is literally infinite. It stretches out way past the wire. So, at best, maybe I'm incorrect here, but at best, I could only find within the Western universities that potential intensity is accounted for, which is interesting because that is very different than the magnitude of a potential. Again, potential intensity seems to be calculated in the textbooks that I have read upon researching for this presentation today, based off of an intensity of a potential that is just based off of an arbitrary unipoint charge, randomly stuck in empty space, as they call it. But even in that regard, the standard Poynting theorem speaks to this concept of the potential being infinite, going way past the wire. So, we can see some of this substantiated in regards to a theoretical modeling, which is of course Dr. Pudov's polarizable vacuum theory, particularly the second paragraph where, quote, we see that accompanying the usual Lorentz force is an additional dielectric force proportional to the gradient of the vacuum dielectric constant, which would speak to this idea of curvature in loop quantum gravity, right? Particularly the work of Dr. Carlo Rovelli and the tracing within loop quantum gravity, as well as the concept that this curvature of space-time may speak to a larger state of unification. Not only that, but we see, and I quote, the usual Lorentz force is an additional dielectric force proportional to the gradient of the vacuum dielectric constant. This proportionality seems to be substantiating that, or at least being able to ascertain the veracity of a unified field theory with respects to what we had looked at earlier about the particles generate the fields allow the particles to fluctuate, so on and so forth. Now, you may say, Dave, this is all fine and dandy talk, But do we have any evidence for this? Well, I was able to obtain a 1999 Popular Mechanics article called Taming Gravity. I'm sure many of you here are familiar with Dr. Ning Li specifically. And of course, we all, there's been a lot of rumors and speculation as to, I believe she has since passed away, may she rest in peace. But as to what her work was doing ever since the late 90s, up until her passing. What's interesting, however, is that, again, I am quoting the Popular Mechanics article, speaking to the manipulation of mass, and I quote, basically, you are adding a couple of vectors to zero it out or enhance it, to zero gravity out or enhance it, end quote. These are not my words, these are the words of Dr. Larry Smalley, the former chairman of the University of Alabama at Huntsville Physics Department. The question then becomes, after the vectors are summed to zero, as we've seen in our previous slides and images that seem to be reminiscent of a lot of ancient, we could say, cave drawings, scriptures, descriptions, you name it, what does this say about mass in general? Manipulating mass seems to be able to show that this allows for a negation or attraction of particle distribution fluctuations, very similar to waves within a body of water, or I will give a more practical example, when you are changing the bed sheets of your bed, literally, as you're planning to wash them. As you pull the blankets off the bed, there's sort of that wave propagation, exact same movement. This allows for the manipulation of the relative perception of local time, local space, and the local objects within that space-time metric. Of course, in correspondence with other metric variabilities, but just to keep it simple for the sake of this presentation. Manipulating mass also denotes a correlation between the speed of light, angular acceleration, angular momentum, angular velocity, and how such is perceived across time, which speaks to this concept of, again, superdeterminism and many other things. How is this done theoretically? It is done by manipulating epsilon and mu, the vacuum permittivity and the vacuum permeability, or the electric permittivity and magnetic permeability. Very simple in that particular regard. Now, you may say, Dave, that's all fine and dandy, but do we have a practical example? Absolutely. So, say we have a laboratory, right? And the laboratory is split into two rooms with a wall dividing it down the center. One side of the laboratory is in fact a glass prism, where laser beams outside of the prism are shooting into the glass prism. The other half of the laboratory is just simply an observational room to observe and obtain the data and all of this. So once laser beams are shot into the prism, particularly multiple different beams, what happens is the laser beam begins to curve within the gradients of the prism via that of the kinetic, photonic, and phononic oscillations. Now what happens is the curvature inside of that glass prism, if there were to be someone or something inside that prism in the laboratory, in the first half of the room, you would see sort of a rainbow-like effect in addition to a potential Davies-Unruh thermal bath effect, if you will, right? Now, the laboratory observer not in the prism is only going to see the flat curvature of that energetic phenomenon relative to the other side of the laboratory. He is not going to see that phenomenon in 3D, let alone 4D, 5D, all the way up to 12 space. He is not going to see or experience that phenomenon in curved space-time. He or she is only going to see the flat curvature and intersection of that phenomenon. Now, this then makes us ask, okay, what does this say about empty space and our earlier discussed potentials? It says that they have the ability, as I just mentioned, to become an active local quote-unquote engine. Literally anywhere where there's what we'd call empty space has the ability to become a local engine via oscillatory concepts and approaches, one of them being ER equals EPR, the Einstein-Rosenberg model. Such can in fact be traced in loop quantum gravity. Again, particularly Dr. Carlo Rovelli and his team's work on, I believe, quantum split sources. For anyone willing to discuss that, you're more than welcome to reach out to me directly, and I love talking about those concepts within loop quantum gravity. Such can be traced via delta T variables in optics, which is interesting. It brings us back to that correlation between mass, speed of light. We see something happening here. Now, what's interesting is that on the left-hand side, we have an ATIP DIA file, which shows, particularly the second half of the paragraph, an inter-universe wormhole image at the top and an intra-universe wormhole at the bottom. But I would like to quote that Hochberg and Visser proved that it is only the behavior near the wormhole throat that is critical to understanding the physics, and that a generic throat can be defined without having to make all of the symmetry assumptions and without assuming the existence of an asymptotically flat spacetime in which to embed the wormhole, end quote. Which is very, very peculiar, because it speaks to this idea of, again, the pine cones kissing. If one can understand the tip of such pine cones kissing, as we looked at some of the images prior, whether modern or ancient, we will find that there seems to be an understanding of just knowing what the tip's geometrical values and functions are, and limits, and symmetries. We can then integrate it exponentially to the rest of that wormhole in a Lorentz propagative sense, excuse me. What I mean by this essentially is that if we were to look at a paper by Dr. Ibison and Dr. Pudov on the Lorentz 3D Dirac, we could say, integral relativistic 3D Lorentz Dirac equation without runaways. I'm paraphrasing that paper, forgive me, but we will find that you can in fact implement the Dirac equation without it having runaways in an integrated relativistic form, which is very, very peculiar, particularly when we notice that over here on the right hand side of our Wikipedia page, again, noticing here when we're looking at physical optics, there are, and I quote, there are different forms of the pointing vector. The most common are in terms of the E, B, or E and H fields. Now, what's interesting is if you look at the far right-hand side, and end quote, you will see that delta T in the dimensions section is dealt with quite avidly, so you don't have to believe me again in this particular regard. Now, with that said, we will also find that the pointing vector seems to be the most standard common usage, but even as I said earlier, the pointing vector shows that the energy propagation expands way past the wire in which the energy is occurring on. The magnitude is infinite. Same thing with the field, by the way. Now, the question then becomes, if we're following Hochberg and Visser's approach here with respects to Dr. Pudov and many, many others, the wormhole throat behavior may in fact propagate what we call time. This inertial frame of time is propelled from the zero or starting point of the vector summations. So we see on the left-hand side image that the 0 point, literally the coordinate where it says 0, the very bottom right of the left-hand side image, is the beginning of a gradient's curvature, as Dr. Pudov's polarizable vacuum paper showed, that is, again, proportional to the propagation of this vacuum dielectric constant, of which the speed of light also seems to be proportional to as well. Now, those within the field of this energetic phenomenon would experience wormhole throat behavior very differently than that of those external to the field, very similar to the prism example we had given earlier. Now, you may say again, Dave, this is all fine and dandy talk, but what are some ways of practicality and using such vacuum energy to be extracted in the laboratory? Well, one way is a charged plate collapse. Now, for propulsion or inertial uses, it's not practical. As a matter of fact, I believe this was a proposition brought forward many decades ago by Dr. Robert Forward, I believe at Hughes Laboratory, under the Air Force Research Laboratory. I could be incorrect about AFRL there, but his whole hypothesis was, well, if I bring a bunch of stacked plates together, aluminum plates, and I charge them electrically, because of the Casimir and van der Waals forces and effect, the energy could be extracted from in between the plates, and then we can store that energy for use. Now, for propulsion and inertia, it's not practical. But it does lead to many other things, like what we now know to be flat panel displays and many other things of the sort. The reason it's not practical is because it takes far more energy to induce an effect on the plates being charged compared to what you would extract from the effect in between the plates. A second variation, of which seems to be far more feasible, is a plasma punch or pulse. Basically, guys, a very high-tech version of rubbing your feet on the carpet and touching a doorknob to get a jolt or a shock. right? You can also pulse certain mechanisms with respects to these plasma oscillations and resonances and what have you. But another way for those interested in work with liquids and water is a sonoluminescence angle. Again, light and liquid, where very fast turbulent fluids with bubbles in the fluid collapse the bubbles due to, again, the zero vector pressure force. The vectors are being summed to zero. Every time one bubble collapses, and that wave collapses, if you will, you get 100,000 photons in 50 picoseconds from one tiny little light burst. So this is a very, very, very big effect. This is not some small stuff. Now, various other practical forms are indeed feasible as well, in which do not, in my opinion, both based on theoretical modeling and experiments in the laboratory, in which would not require superconductors or metamaterials. I have nothing against them. I just want to show in this particular presentation that superconductors or metamaterials are not necessarily always needed, in my humble opinion. But again, that's just me. Now, the current issues or concerns, because again, we can talk about how this is all great, but how can we address it, and then how can we help resolve or solve it? The current issues or concerns are that anything utilizing the U1 models, whether it's in classical electrodynamics, whether it's in chemistry, whether it's in optics, you name it, the U1 models across academia will not work because they assume a flat space-time. So numerically they will fall apart. This also speaks to the laboratory observer with the prism example. The scientist who is not in the glass prism is only seeing the flat curvature of that energetic phenomenon, which the U1 model will show, but that's the limit. That's it. So the U1 model assumes a flat spacetime, which disallows and prevents seamless lattice ion angular integration into the spacetime metric, of which could be calculated again with Ricci tensors, Hermitian operators, and many, many other tensors as well, just to give some idea for those that are on the theoretical side of things. Now, again, we addressed the problems and concerns. Let's take a look at some of the solutions. Some of the solutions I would propose would be SU2 group symmetry, particularly Dr. Miguel Javier, I believe out of MIT, but I could be wrong as to that particular university. In addition to E.T. Whittaker's 1903 and 1904 infolding paper as well. I would very strongly advise people to look at that. Of course, Richard Feynman's scattering operators. And very specifically, these last 2 points, I'd like to give an example for the chemists, or for those interested in more so in chemistry, to pursue a concept of stabilized disequilibrium, both in propulsion, but I'm going to use a chemist example here. So when people say for example, there's an energetic phenomenon, and they see some type of sulfuric acid, they think, or some type of what's been called, sort of gooey spider web, it's been called sometimes, angel hair, if you will. A lot of people say, oh, that's just sulfuric acid. I would beg to differ. Why do I beg to differ? Well, say in the laboratory, practically, we have an acid and we have a hydroxide, and we neutralize the two. It is normally known, particularly within the U1 models, as it's been taught to all of us, that during the neutralization of these two chemicals, the acid and the hydroxide, there is supposed to be a heat coming from that neutralization. In other words, there is supposed to be an exothermic reaction. But in this particular case, there isn't. So that tells us there are some peculiar properties within this particular acid and particular hydroxide that allows for disequilibrium to become stabilized in conditions where it normally would not be stable. So that's why when people say, oh, look, that's just sulfuric acid, I don't think so. There are some peculiar properties that are creating a situation where, again, disequilibrium could be stabilized. Now, SU2 group symmetry as well allows for the space-time peak across the local metric to occur. So the left-hand side image, we have a space-time metric, generally speaking, for those that are more visual. And on the right-hand side, for our visual friends again, we have a sort of, I guess you could say, peak in which would occur from the metric once certain conditions are met. Now, there may in fact be a potential longitudinal lock-in with these transverse waves. So again, if we were to focus on the glass prism example in the laboratory, the experiencer inside of the glass prism, or this energetic phenomenon, would experience something of what we're looking at right over here. In addition to, again, a possible Davies-Unruh thermal bath effect, but this would be the visual. Now, the external observer, of which I believe to be the case in which much of the literature today in quantum field theory, loop quantum gravity, SU2 group symmetry, is showcasing the viewpoint of the external observer. The external observer will see something like this. Not necessarily the entire template here, but I'm speaking more to just, again, a flat intersection curvature where the blue shift, red shift begins to, create more of a propagative effect that Dr. Puthoff and many others with respects to space-time metric engineering have discussed, where, again, sort of like if we took a bed sheet on one's bed and just kind of whipped it up, would be the same way in which when the space-time metric is voided, after the vectors are summed to zero, what then happens is there's a sudden blue shift in energy in the thermal spectrum. Because, sort of like when you are unzipping, for example, the jean pocket pants or something of this type, the jean material itself moves aside for that, we could say phenomenon to then occur. And in this particular example, the jean material, like clothing, would represent the space-time metric. So, some thoughts would be that would light propagation and time have direct correlations? Does the manipulation of local objects' masses perturb or effectuate such phenomenology within that of the local metric? And does time exist within photonic and phononic resonance and propagation? These are some thoughts that I think should be or could be avidly explored. Now, I would like to thank, truth be told, people from the APEC community, folks from that I've spoken to privately, whether from DoD or otherwise, or from even around the world, for providing a tremendous insight into angular geodesic acceleration, which would allow for such energetic phenomenon to occur. And when I say energetic phenomenon, I'm speaking to a multitude of different potentialities, not just for propulsion. Now, we have the four known forces, as we know. We have the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. The question becomes, is there in fact a missing key, particularly within general relativity? If we were to follow along Einstein's concept and, given the Schwarzschild metric and all of this metric solution, is there a fifth force that unifies the other four? Maybe there's more than a fifth force, maybe there's multiple forces or multiple integrative approaches. And not only that, but are there multiple ways of tapping and or accessing this fifth force? That becomes another very avid question I think could be pursued based on the previous slides I have presented and or of course interpretations from folks in the audience and your own thoughts as well. Now, I would dare to say, this is my humble opinion, multiple avenues towards the same undergird or underlying source would be Dr. Puthoff's zero-point energy, of course, and his papers, Dr. Salvatore Paez's superforce, Dr. Sarfati's EVOs, exotic vacuum objects, and of course Existics from our great friend and APEC community member, Gavin. I would like to thank our friend Gavin for coming forward in the way that he did, particularly in the APEC WhatsApp group chat for helping others in the community understand and explain his concept of existics and how it could be unified both with classical models and in many other ways as well. I do not mean to speak for Mr. Gavin, but I'd like to thank you, Gavin, for coming forward with your existics. It's a fantastic model in my opinion. Now, again, we are speaking to the different avenues of which this source could be tapped. Now, there are in fact in the laboratory multiple avenues of extraction, energetic selection of frequencies, etc., which would be high frequencies, low frequencies, and potentially unknown frequencies and bandwidths both above and below the current electromagnetic spectrum and the thermal artifact, particularly dealing with the thermal artifact more so on the lower levels of the thermal artifact, in addition to acoustic ranges and auditory phenomena, if we'd like to call it such. A practical example of a theoretical concept or situation where, again, I'm trying to push the limits here a little bit deliberately, in the sense of, we see that out of the Institute of Electron Physics, the Ukraine National Academy of Sciences, some tremendous people put out a paper on the essence of SGME, which stands for Slightly Generalized Maxwellian Equations. What's interesting is that after the paper was released, the paper had talked about dismissing the Dirac equation for a moment. There seemed to be to allow for more of a unified model with respects to Mr. Krivsky and Simokic's work. But the paper was immediately attacked. This is where it gets interesting, because the paper and the authors were attacked, but the equations themselves were not debunked nor calculated to show any other derivation that would suggest an incorrect or incomplete unification of the slightly generalized Maxwell equations. So it gets interesting, right? We see, for example, that, you know, people will attack papers, but not necessarily say, okay, here's the math to show why it can't work, right? Now, one thing I'd like to also bring up before ending off this presentation is some of my own work, some papers that I've written myself as well. I do need approval for release on these papers, so if anyone is interested in obtaining them, you're more than welcome to reach out to me directly at genzpodcast@gmail.com, but I still am waiting for approval. So if you email me now, I will have to tell you that you'll have to wait a little bit, but these are just some papers that I've put together for various groups and individuals, and also, truth be told, other papers that of which I cannot showcase for certain world governments and other departments of DoD and so forth. So, with that said, I'd like to thank you all so very much for watching and listening to today's presentation. I hope this provided a little bit more of an insight into really going back to the basics of Lagrangian and Newtonian physics, and then trying to, I guess we could say, understand such from there, whether theoretically, and then of course bringing it into the laboratory, and then being scaled for commercial and consumer use.
Hey, sorry guys watching this live. I'm calling Tim right now to try to get see where he's at. He's the of course the moderator, so we're trying to get him back on so that he can unmute people so that we can do a round of applause and talk. So we're all waiting on you, Tim. Try calling his regular phone.
Hey, Dave, are you all done?
There you are.
Oh, sorry.
There we go. Thank you. Yeah, all done. Thanks, guys. Thank you, everyone.
Yeah, sorry about that. I thought you were still going. Well,
No,
let me do this. Let me take it. You know what? So very first thing here, let me put this thing in gallery mode. Everybody give Mr. Dave Rossi an enormous hand. Wonderful presentation, very in depth, man. This is why I love recording this, because you ran through a ton of stuff. Folks asked if the slide deck is available. If you want, you can. I mean, if you feel comfortable, if you want to upload that, you can put that into chat. Otherwise, folks can go through again, all the slides you presented, these are going to be on our YouTube channel. They'll be on our website at altpropulsion.com. And you know, again, just to let everybody know, what we're doing is, I mean, we have, especially for new folks here, we have a massive archive. I mean, we've got, this is 47 conference sessions. They average 8 hours each. You know, each one has like 2 to 3, sometimes 4 or 5 presentations. And then the open discussion in chat, there's just brilliance all through that, you know, and that's just APEC, right? And like then Jeremy Reese, who live streams these, if you haven't seen Jeremy's Alien Scientist channel, I mean, he has been doing this for like 15 years, you know, he's got thousands and thousands of videos on all sorts of different topics. So let me do this. Go to Q&A, 'cause I'm here. So I think Mark had, sorry, my chat's getting in the way there. I'll let participants unmute themselves now. So questions for Mr. Dave Rossi. Let me go to Mark.
Okay, thank you.
First. Mark?
Hey, did you say that the Department of Defense has had to approve your speaking here today? Did I get that?
That particular file, the video we watched, yes, sir.
Why would that have to be?
What I can say is that tapping this type of energy is a lot simpler than people may think, and they wanted to make sure I didn't let things slip. I've let stuff slip in the past in other presentations.
Well, how did you get involved with the Department of Defense?
Basically, long story short, about a year and change ago, so I had started my YouTube channel about 2.5 years ago, just pursuing, you know, life sciences, all that kind of stuff, and then started looking into 0-point energy. And I just said to myself about a year ago, why not try it out myself? And I can tell you guys that with a couple $1,000 saved up, a few Amazon orders, some trips to the hardware store and what have you, I created something that enacted this effect. After this effect occurred, it basically because of the way, it does not break any laws of physics, but because of how strong this, had I Faraday cage this particular, I call it generator, then they would not have picked it up. But basically I was messing with you know, old microwaves and lasers and things like this, but even that wasn't needed. But basically it set off detectors, and then I started getting emails from people, DARPA, Naval War College, what have you, and then I word got around to certain people, presented to very high level people, and then from there I started a company, SAALT, and then was yeah, basically just took it from there, just exploring. I went to a few different laboratories to provide proof of concept demonstration, and yeah.
What was the concept you were proving exactly?
Specifically what we would call electrogravitics, direct correlation between mass and inertia.
So you're claiming you created an anti-gravity machine?
I don't really like to call it anti-gravity so much as negating. It's not anything unique to what I've tapped. I'm sure I guarantee people have done it far before me. I don't claim anything unique. It was more so just the way that I unified it, both when I presented and then when I did showed proof of concept in the lab.
It's a shame you didn't get into the details of that.
Unfortunately, the reason, guys, and I want to tell all of you right now, is because it's actually a lot simpler than many may think. Now, there are many different ways of doing it, which is why I'm not saying I've cracked the way. I've just cracked a set of ways, but it's a lot simpler than people may think, than many may think, with respects to mass and inertia having direct correlations. At first I thought it was like wind, you know, I was experimenting outside, then I brought it inside, and then, you know, all that kind of stuff. And then once it was done in the lab, it was like, okay. So, and then I could tell, even I had presented to certain departments before even doing proof of concept, and even during the presentation, certain individuals, their faces, I could tell they were like, oh shit. So that's,
do you think they will ever give you permission to talk about this?
Truth be told, it's I hope within the next couple of years, honestly. If not, yeah.
All right.
because it's considered national security. It's the same thing that same concept that Dr. Paez said to Kurjai Mungal when he said he had to stop at a certain point for national security issues. It's the same concept, same angle.
Okay. Well, Mark, thank you, sir. Let me see. Oh, he just burped from my screen. Oh, because his hand went down. Let me go to Mr. William Alec next.
Yeah, Tim, can you hear me?
Yeah. You know what? I need to put hands down after you guys start. In Zoom, you disappear when I put the hand down in the. Okay. Yeah, go for it, Bill.
Okay, your guest, his name is Dave.
Yes, sir.
Zed, is
Yes,
that
sir.
correct?
Well,
Rossi. Zed was
Rossi?
the channel
Dave?
name. Yes, sir.
Yeah. Okay.
Thank you, sir.
His work from about, I don't know, 20 years ago.
Mm.
And he brought up, some of the same papers you brought up. And, today, we're working with a simplified version of the Maxwell equations.
Right.
And the issue with that, is the simplification. And it goes back to the original the original Maxwell equations, which were done in this quaternion math solution.
Right. Yeah.
And according to Tom's work, and of course, I was fortunate to be there, at his lectures 20 years ago, and spoke with him personally on this subject. And he spoke quite frequently of what are called scalar waves. Okay, and it's scalar electromagnetics, and that, according to Tom, that's really the key to gravity and anti-gravity control, working with scalar electromagnetics, is the key to this thing. And what it is, it's not fusion. Fusion is like an extreme version of working with these scalar functions, where you take two particles and you just crash them, combine them together. And you don't have to do that. The objective here is to create the scalar function just by oscillating or resonating two particles together. Okay. And Tom referred to it as a Q cross Q function. And the output of this Q cross Q function, when you resonate these two particles together, the output of that is a sine squared function. And you actually see that on scope traces, okay, the sine squared function. And that sine squared embodies your scalar function, okay? And that's what gets you to scalar electromagnetics. And Tom, he was really into the, gravity and anti-gravity control. And so this function just relates to this oscillating function, which I don't know, I've been able to replicate it quite easily using the technology that I have here. And so, really it was coming down to Tom Bearden's lectures, that I saw a parallel, with what you were speaking about. Okay. So, I just wanted to mention that a key to this thing is not achieving fusion, but kind of like the halfway in between point of where you take these two particles and you force them together and you oscillate them, creating a scalar function. Okay. And that's what gets you to this over unity and this type of electromagnetics, which taps into these potentials that you were talking about or speaking about here. So I just wanted to mention that.
I want to thank you so much, sir, for bringing up Mr. Bearden. I've read his work. I've watched his videos, his lectures, his presentations. I would have loved to meet him myself, and I think that there's definitely respectfully to everybody here, I have to just watch my words a little bit, but there might be something there. That's what I could say. If I may also very quickly address the I believe our friend Mark from previously, one of the reasons, guys, that I want to be able to say to demonstrate how I did it in a practical sense, but unfortunately cannot, is because basically let's just say I call it the generator. I call it when it's in its vertical position, it immediately gives immediate inertia right away. However, with a few adjustments, maybe 20-30 minutes worth of adjustments, and then just tilting it horizontally, it becomes weaponizable, and it becomes a rail gun, or EMP. It puts firearms out of business, which is why, again, if anyone can tap that in that particular regard, it becomes I get put in a lot of trouble in a legal regard. So I just want to be a little bit more clear in that sense. But with respects to Mr. Bearden's work, sir, William, I think that there's a lot of potential with vector scalar potentials and the oscillations and the resonances of that. And then that's what I was trying to say by summing the vectors to zero. So I would,
yeah, exactly.
Right.
Yeah, because Tom mentioned that there's an engine, a vacuum engine that forms, when you have this zero vector that has all this internal structure to it, and it doesn't show up in any of the conventional Maxwell equations.
I agree.
You have to use an extreme form of this, which is the quaternion math, and then the scalar vectors begin to emerge from all that.
Right. I would agree. If I could also politely, even I don't consider myself a lecturer or anything like this, although I appreciate the compliment. I find, guys, the more that I experiment in the laboratory, the more I realize I don't know anything, to tell you the truth. But I would recommend very respectfully to look at not what someone, as I said in the presentation, has written about the original Heaviside, Lorentz, Gibbs, Maxwell papers, even the Poynting papers, but to do your best to try and find the original source papers. There's a very significant difference, because the many of the academics today, not to take any jabs at them, but they don't really go back to bother to read the original papers, because they think that perfect job was done when it really arguably wasn't. So that's kind of then we get into the whole, for those that are more into the conspiring of JP Morgan and Tesla and all that kind of stuff. But yeah.
Well, Tesla did that as well. Okay, and his magnifying transformer, he set up these opposing forces, and virtually no physicist knows anything about that.
This is what I was trying to convey with the vectors to zero.
Yeah, exactly. Yeah, that's the key to it.
I would agree. This is simply one way that I would approach in probably about 5-6 different ways that I found to be the case, whether it's with just electricity and certain types of magnets, things like this, or even with liquids, like with ferromagnetic fluids and things like that. But yes, either way, there is a vector summing to zero, pine cones kissing.
Exactly.
And I found it's interesting
because the whole key to this thing.
I mean, maybe I'm going nuts here, but I found an interesting pattern over the ages of what our ancestors seem to have been trying to say with that same vector summing to zero. Now, maybe I could be dead wrong, but yeah.
Yeah, well, there's a number of researchers that that spoke about this. This zero vectoring concept.
Right. Absolutely. The pine cone, Toby, sir, sorry, Tim, I'll let you moderate the questions, but the pine cone just meaning basically like the vectors, where there's like a pyramid type, starts with a broad base and then narrows its way up. You'll find that even in bio-nanoelectronics and even papers written by people like Charles Lieber from even a decade ago, they speak about that as well, a sort of resonant electrical occurrence that goes within the sort of, it starts to oscillate at the bottom. And the reason it needs to be sort of a pine cone or, triangle in shape is because the resonance needs to eventually squeeze right through the top. And it can't be done if it's got a broad base, essentially. But it needs that broad base to build up its resonance. So,
yeah. Well, let me go to, if it's okay, we got about 5 minutes until the top of the hour. Let me go to Jared real quick. And Bill, thank you, sir.
Dave, outstanding lecture. Outstanding.
Thank you, sir. Thank you.
I have a couple of questions. Clarification question first. When you were talking about the Lamb shift of the hydrogen, and that's one of the areas where you might be able to tap into something.
Yeah.
Are you referring to like conversion of the virtual particles into real particles through like significantly high energy densities? Is that what you're getting at?
Yes, when I had said that the potentials may be more quote unquote real than the fields themselves. Yeah. And then separating the magnetic vector potential, the A field from the B field. Yes, precisely.
Gotcha. And then just two other questions regarding the stuff that you can't talk about. So whatever light you could shed on it.
Sure.
For your successful experiments, were solitons or standing waves, the buildup of energy in a location, is that playing any part in your experiment?
Potentially,
okay. Also, the quality factor of it, right? How many cycles you're getting for your thing, which goes hand in hand. Did that need to be significantly high, or you say you can get it all with
it didn't have to be. I can tell you that one of the first experiments I had done, I had placed an object over the generator, and it went about 3 kilometers vertically up, like immediate inertia.
When you say immediately up, like, can you give any estimate as to the amount of acceleration it had, like how fast it went off?
I honestly, man, I'm gonna have to get back to you. If you want, I can put my email in. I have to be I have to be vigilant with specifics. Forgive me, guys. I'm not trying to say it. I can't comment on things or whatever. I just have to be careful. I really wish I could blurt it all out, but I'll put my email here for anyone that's interested.
Excellent. I already messaged your Instagram to try to get some papers from you.
Awesome.
We might be able to correspond through there. And final aspect of it, plasmonics, is that playing any role in it?
Oh, plasmas or plasma? I've said
plasmonics.
Not initially, but you can introduce that. The more creativity you have, the more you can play around with it.
Okay.
So, okay, wonderful. Let me go to Jared. Thank you, sir. Let me go to Taylor Cisco. We got about a minute and a half left. Taylor, go for it, sir.
Oh, he's muted.
Yeah, and actually, that's okay. Oh, Taylor, let me ask you. There we go.
There we go. I'm very impressed with the your comprehensive survey of metrics and such.
Thank you.
Out of curiosity, did you read the works or review the works done by either Burkhard Heim or by Boyko Ivanov?
Yes.
Both?
Yes.
Okay.
Yeah.
The way you're smiling, I assume Boyko Ivanov might have been interesting.
There, like I've said, I'm not the first one to have tapped this.
Oh, what a dance. Another question. When you activate your device or when you activate whatever, after you do your charging or activation, do you need to continue activating to generate a force? Can you just get a force without continued activation or energizing?
An occasional pulsation is needed.
But after that, it's kind of in a state of generating a force.
That's it. It pulls from what we call empty space. If you want to just have something levitate or negate the local field, the metric, it'll pull it from empty space. But if you're talking for movement, an occasional pulsation is needed.
All right, and one more question if I can squeeze it in. Does some of the phenomena seem to be compatible with a preferred reference frame?
Absolutely.
Uh-oh. That's interesting.
Absolutely. It's truly, this is where I say I agree with Dr. Paez when he says it's merging the world of the very large with the world of the very small, in the sense that it truly depends on the individual that is observing. That's why I tried to give that prism example with one lab observer not in the prism and then one in.
Well, I mean, what I'm getting at too is that the kind of physics you guys are playing with you in the Department of Defense, if you're looking at stuff that's compatible with a preferred reference frame, I would assume, are looking at some interesting phenomena, even some of it that might even border on being like tachyons or whatever.
It becomes, I will say, this is just my opinion, but with some of the things I've seen in the laboratory, it's truly the energies are beautiful. It becomes indiscernible from what one could call, I say this very carefully, but quote unquote magic. It's a very beautiful thing. So that's why I speak so much on the philosophical side as well.
Awesome. So, very good.
Okay.
I won't ask any more questions. I think I have an idea what you guys are excited about.
Well, and Taylor, thank you so much.
Thank you, sir.
Yeah, and so what I guess let me do this before anything else. Again, I want to put this thing back on gallery view. Everyone, Dave Zed.
Thank you, guys.
Mr. Dave Rossi. Thank you, sir, for your presentation. Dave, if you're able to maybe drop your email, or if you have some contact info, if you could drop that into chat, and then people if you have more questions. Because I did see, I mean, there was a lot of interest there. Go to Mr. Jeremy Reese, who is, let me see, I will ask him to unmute. And so I just want to say Jeremy's the reason why I was even able to come here and all that. So Jeremy, thank you very much, sir. Yeah.
Thank you so much for that, Dave, too. And that was I'm so glad you came on today, man. That was an epic presentation. And I think I think we're on the right track here. And I think there's going to be a lot going on. I'm going to connect a lot of stuff from the first two presentations here.
Well, and Jeremy, if it's okay, let me introduce this first, because I think everybody here knows Jeremy Reese, right? He's been with this conference since the very beginning, and I mean, he deserves so much credit. He's live streamed things, he has participated, he's done presentations. He did earlier in the, I believe it was earlier in the year or last year, he did a major UAP phenomena overview, right? And again, one of the things that Jeremy is known for throughout the internet is being able to condense and synthesize massive amounts of data into something that makes a lot of sense. So he did a presentation on that, and I have been pestering him for 6 months now to represent this because he's updated it. So I want to hand things over to Jeremy Reese. And sir, thank you so much for presenting this for us again.
Thanks for giving me the shot here. Let me share this with you again. Okay, so that was let me fix this, and I'm going to, all right, yep, I'm on there. All right, cool. Just give me a second to I gotta find Zoom now. All right, there's Zoom. Share screen. Sorry, I'm running the live stream as well as this. So
but Jeremy, I probably should mention for everybody also. So this may run over. I set technically when I was setting things out, I was like, okay, we'll say an hour. But I think last time you did this, it took 2 hours, right? So this would be like a classic, big scale APEC presentation. So go for it, sir.
All right, and if Mark, if you're there, I'm sharing your screen for this because of the audio through StreamYard. So if you can get that gallery out of the way from my slides. That would be awesome. So I can, because that might block some of the things on the live stream. So, all right. So I just start with this slide because there's lots of bad predictions that have been made in science. This is a technical briefing on UAP, which I prepared for scientists, engineers, and innovators, and the APEC Alternative Propulsion Engineering Conference. It starts, this is kind of like they opened up this whole thing with the government doing a reinvestigation into UAP and stuff, and their investigation goes back to 1945. So that's where I started my whole presentation with one of the biggest intelligence gains that took place in the history of United States after World War II, where we literally, our troops went through and captured all these scientists. The Russians had their own operation to capture a number of scientists to try to, basically scrap the intellectual property of the leftover Nazi Germany at the end of World War II. So yeah, this is a picture of President Kennedy with some of the Operation Paperclip scientists who would go on to create NASA and a number of other important milestones. But there are a number of other interesting Nazis that did get away, and others that either died in the war or were captured by Russian intelligence. And this whole controversy over the Glock, we've heard of this Nazi Bell experiment allegedly, and also but we have here is that a few key paperclip scientists may have been involved with the Roswell incident 2 years later as well. I know that the Aeromed lab at Wright-Patterson got a lot of intelligence from Dachau concentration camp prisoners who were used in human experimentation in these altitude chambers, and Hubertus Strughold was later revealed to be have been involved with that. It was covered up for years, and he was kept as a scientist and intelligence asset and protected by the intelligence agencies, which is interesting. I wonder if there's any more cases like that. I haven't really looked deeper, but Ernest Steinhardt, colleague of von Braun, he said that a select group of paperclip scientists were taken by federal authorities to the New Mexico desert for a purpose left unstated in July 1947. They were escorted to an area with strange wreckage from an aerial object and then asked to study the crash site. The Americans wanted assurance that it wasn't of Soviet or other foreign country origin, and Steinhoff said it was not. They were instructed to not remove any material from the crash site, and he said that he heard some of the material was taken to underground facilities at Wright Airfield. He requested of Blisius, the interviewer, that he never say anything about this until he passed away. Ernst died in 1987, and this was published. Again, maybe it's nothing, it's circumstantial, but it's certainly interesting evidence in the chain of whether the government should be looking and its reinvestigation of these things. There are a number of other scientists as well that we'll talk about. Of course, there's the Horton brothers who were working on the Twining memo. There's a bad version of the Twining memo which makes it look like it was related to much more. There's two versions. There's a fake version and the real one. So, but anyways, they had just recovered this object and they were looking into it. And one of the questions that Twining, one of the top intelligence, head of Pentagon intelligence during Roswell, thought is that it could have been a Horton brothers craft. And the Horton brothers actually were working on this is a picture of the Horton parabola, and very similar in description to Kenneth Arnold's sighting in 1947, which he said they were skipping across the air like flying saucers, and they took that phrase "flying saucers" and that went out as these were flying saucers, and it started the whole flying saucers wave. But what Kenneth Arnold actually cited looked closer to this Horton parabola craft, surprisingly and interestingly, that the head of the Pentagon intelligence would also ask about the Horton brothers and their whereabouts. In relation to that, of course, after 1947, we have the National Security Act, the creation of the CIA, creation of the U.S. Air Force, and a number of other interesting things. So we had an aircraft as well that were these wing shaped. These were the predecessors of the modern B-2 Spirit plane, and we also had a number of craft that in the history that they're documented that looked like flying saucers or flying wings or other type of craft. Of course, the United States Air Force maintains that it was Project Mogul weather balloon train. Even though high-ranking members of the Army R&D Foreign Technologies desk, like Philip Corso, wrote books saying that, no, this was alien technology and that we developed a whole series of these technologies from that. That's kind of old news, 1997. So I did my research into this. found a lot of background theory on the transistor and how it was developed at Bell Labs, and the whole the ideas that these guys were experimenting with P and N doped silicon, and how they actually put together this transistor. So a lot of this mathematics and crystallography and metallurgy and stuff like in mineralogy were known, and it could have led, I see a background progression where these things didn't just appear out of nowhere. They were working on this for 30 years. 10 or 15 years prior to the invention of the transistor, which I do not believe came from alien technology, but doesn't mean that we'll get into some what I think might be can constitute alien technology. I'll try to get through all this stuff. The history of fiber optics. I mean, the Romans knew that light would travel through a flowing outlet of water, and so it's no mystery with that. Roy Plunkett, of course, invented Teflon, and there's a whole boring history of tetrafluoroethylene polymers that you can research on that. It's all interesting that, we create things a lot of times that have amazing uses and they're hailed as wonder inventions, only later to discover that, they've wreaked horrible catastrophes on humanity. So PFAS is a type of Teflon that was used in pans. So if you have any old pans, you might want to throw them away and make sure that you're not using old Teflon pans, because they could have PFAS in them. You could be poisoning your body and organs with this toxic chemical. So a lot of people don't even know about it. It's also in fire retardant foams. They actually put out a house fire in my parents' town, and it poisoned half the well water in the town with PFAS. Nitinol wire. These shape retention alloys are super interesting, and there might be reason to believe that aliens might, build their craft out of these things. Of course, the interesting thing about Roswell is the number of witnesses that talked about this memory foil, and I've brought this up a number of times. They said it was a fabric-like metal, or a metal-like fabric that was indestructible. That was Captain Robert McLaughlin of the U.S. Navy, who apparently took a piece of this to White Sands Proving Ground, the facility there, and tried to have one of their top machinists drill a hole through it, to which they burned out several titanium bits and were not able to puncture a hole through the material. So interesting story, but is there any kind of basis for this in reality? I mean, can we make nitinol mesh wire fabric and do this? Does it act like this? So what was that material then, if it wasn't this material that these people describe that couldn't be burnt or bent or cut with a knife and stuff? Interesting. I talk about the ability of this nitinol wire, and I have this slide to show zero tolerance machining, where they can actually machine parts that fit together like seamlessly with zero tolerance. So if you can imagine these things being made as part of your craft, with a door made out with a nitinol hinge in it, the nitinol could be heated up. It could be bent out of position and then heated up. As soon as you heat it up, it will return back to position. So you could make these sort of seamless openings that some of these UFO witnesses have described in experiencer accounts, where you can have metal doors that appear out of just the metal of the wall and then close back up with no seams. Really interesting stuff. And BOPET or Mylar was not invented until here's the patent issue. It was filed in 1948, May 13th, 1950. So yeah, this wasn't invented until after. Maybe they were working with it. Maybe they didn't file the patent for it and they had it and they were making it and experimenting with it. Maybe it was a secret space program that had this Mylar, but Mylar wasn't invented until the year after Roswell, or the mid 1950s is when the BOPET films were developed by DuPont Imperial Chemical Industries. So it's unlikely that this was Mylar. Of course, it sounds even more like the remarkable properties of this material sound almost like a metallic glass alloy. talked about glass and metallic glass, but those weren't developed until the 1960s. So metallic glass alloys, as you know, have incredible performance capabilities. That you make a tuning fork out of this metallic glass, it will literally ring for 10 times longer than a stainless steel or titanium tuning fork. And the elastic limit and strength of glass alloys are off the charts in comparison to titanium alloys, steels, and polymers. So really interesting super materials. Definitely the type of material I would use to build the hull of my spacecraft. But again, I'm not sure if this is what that memory foil was, or if there's anything to that story, but I just find it super fascinating to look at real science and try to, merge it with lore or imagination or whatever you call it. So when it turns out you get these metallic glasses, it's this random orientation of this. It's a more dense structure than an ordinary crystal. So an ordinary crystal is like the least dense. It's of the three anyways. And then you have this other packing, which is called the quasi-crystal packing. And that's when you have certain symmetries, which are not localized, but they're global. Like if you zoom in on the crystal, these points are not symmetric. It starts to look the same. And the further you get out in this quasi-crystal, the more crazy it will start looking from this central flower. With the matching rules that are required for the quasi-crystal Penrose tilings. You think of a quasi-crystal as a Penrose tiling in 3D, and the quasi-crystals were theorized, by certain people. They're actually first created. We didn't even know we created them, but we first created these in the atomic bomb blasts in the 1940s at the Trinity test site. Because research, if you take trinitite, you'll find quasi-crystals in it that were generated at atomic blasts. And you can actually look at quasi-crystals from atomic blasts and be able to tell detailed information from the formation of those quasi-crystals. You'd be able to scientifically determine, the megaton release and the technical information about the warhead that was used to create them through these quasi-crystals. So lots has come out of this in the years past that we didn't know about. We just, rediscovered sometimes decades later. And it took this one, it was discovered, it's interesting. Daniel Schechtman did his NRC fellowship at Aerospace Research Labs at Wright-Patterson Air Force Base in Ohio in 1974. So the Air Force was apparently looking into this kind of stuff as far back as the mid 1970s. And this quasi-crystals thing, they were big on it. Apparently they knew about these things or something, but I don't know why he was the first one to discover it. And while he was there, I'd really like to interview him and learn more about that and the history of how this discovery happened. But the fact is, when this discovery happened, the mainstream scientific community, like Linus Pauling and other, established chemists, prevented the science from evolving for decades. Said there's no such thing as quasi-crystals, only quasi-scientists. So eventually Daniel Schechtman would go on to, I think, the 2011 or 14 Nobel Prize. He actually won the Nobel Prize later, but it took 4 decades because he had to wait for the old crowd to die out, the resistance, so to speak, to die out. So that's unfortunately what some of us are facing. Not all old people are as stubborn and unrelenting as others, but it's a sad fact in the scientific community that revolution, the nature of scientific revolutions such as this. Quasi-crystals can also be used to warp incoming signal, so that you can actually reflect an incoming signal at 90 degrees and without losing any signal quality with a quasi-crystal junction. And this was discovered in Princeton, New Jersey, and among other remarkable optical properties, which are just beginning to be discovered. But quasi-crystals are interesting because I learned about these through a guy named Edgar Fouché. Edgar Fouché was a former Area 51 employee, and he talked about quasicrystals at his disclosure in 1998. I think he actually didn't mention the quasicrystals until 99. I went back to the 98 one and I couldn't find anything about them in that, but I found it in the 99 one. So maybe he came back in 99 and between 98 and 99 learned about the quasicrystals, because he was on about these quasicrystals in that one, saying that quasicrystals, if you want to know how UFOs reach other dimensions, then reach the far reaches of space-time, he said quasicrystals is the answer. So you think about quasicrystals, if you wanted to access higher dimensions in physics, well, a quasicrystal is like a three-dimensional projection of a four-dimensional object or a five-dimensional object. So you can possibly access higher dimensions through quasicrystals due to this intergroup theory dimensionality of the way that they're connected. It's peculiar, but and I don't say I fully understand it, but it's certainly something worth considering and looking into, especially considering. I don't know. It also, I would say considering the source, but Ed, I'm still not sure about some of the things that Ed talked about, because he had this whole TR-3B flying triangle craft that he said was this, Tom DeLonge showed this on Joe Rogan, a fake video of this thing he called the TR-3B, and he wrote about this in Secret Machines. But I've never found any hard evidence for a craft. And he said this thing was massive and that they built, they were building these things for a secret space program and that they ran on anti-gravity. He said that it used a mercury plasma accelerator ring called the magnetic field disruptor, rotated to 60,000 RPMs, which is incredibly fast, at 250,000 atmospheres, which is a massive amount of pressure. And he said the gravity is only reduced by 89%, but I don't know how much of that I believe, because I've never found any evidence for it in the last 10, 15 years. And recently, after I took part in a documentary film about the TR-3B and shared what I knew and my experiences and everything, I found this a whole bunch of secret craft that were developed by Teledyne Ryan. And we'd always thought that Teledyne Ryan was responsible for if there was a TR-3B contractor, but, because they did do the TR-3A, but then you find out so much stuff about these flying triangles that they were developing in the 1970s. And you find out it's all part of this stealth program, that these things were ultra quiet and ultra small. And that, that makes me question the TR-3B story. This came out in 1998. So this is like 2 decades after this. So it doesn't seem like it would be a cover story for, this operation, because this is already old news at that point. We were having, this is when Teledyne Ryan started introducing the Global Hawks and some of these other UAVs and sold out to Northrop Grumman, I believe. I think they sold out. The whole company sold out in 1998. And actually, when they did, they gave all their archival footage to the San Diego Air and Space Museum. And they actually posted this footage 10 years ago. And it's been up on the internet with 78 views. And just no one ever knew about it until Stephen Greenstreet found it somehow, which was awesome, man. Special thanks to Stephen Greenstreet for finding that and putting that out. The B-2 Spirit Bomber was, of course, these craft were a lot of the test craft for the B-2 Spirit Bomber, which came out of this. B-2 Spirit Bomber is an interesting case. It was built at a place called Site 4 at Plant 42, Palmdale. And even though they had a budget and they paid for a production run of 133 B-2 Spirit Bombers, in the end, only 21 were produced. So that leaves a big gaping question. And, you're a factor of almost, 15% off of your production. You're 15% of I didn't do the math on it. I just kind of did it quick in my head, but you're a very small fraction of what you're paid for and what you're getting. So Is there money being funneled into other programs? That's a whole nother question. There's, the F-35 is a great example of, how we pump so much money into these new planes, but we end up, only getting very little out of the billions that we spend. And there's questions, is there a secret space program developing UFOs out there where this money is really going? It should be looked into. It's something that should be taken seriously. There's another Site 4 at Tonopah Test Range, actually which is Area 52. That's actually an enemy radar replication and test facility. So they build mock radar setups of enemy radar and then test electronic countermeasures against countermeasures against those. So haven't found any evidence for the Bob Lazar's Site 4. Of course, Bob said there was 9 alien vehicles at this Papoose Lake facility. A couple months before that, John Lear was on George Knapp saying that there were 11 in this hangar out there. And just so happens that his friend Bob got a job out there and was able to see all that. It's amazing story. Element 115, still can't completely rule it out. As much as I've debunked a lot of the stuff, I think that element 115, if you look at the science and the physics of it, there is an island of stability here. And when you look at things like hafnium isolation and other laser induced, where you can take gamma rays and basically trap these, if you pump the same energy into these radioactively unstable isotopes, you can actually get them to remain stable. So there might be a way that we could stabilize this using, high-powered gammas pumped into it. But again, this is super dangerous to be working with, and not sure. Ricardo Storti is the expert on this. If you want to look up him, that was APEC from 312. If people are interested in seeing a more scientific, in-depth analysis on the whole Bob Lazar thing. I got way too much other stuff to cover in this to really get into it. Other than the fact that his story of the 2 scientists dying sounds a lot like the Lewis Slotin accident, the Demon Core criticality test that killed 2 scientists out in Los Alamos. That the Demon Core did anyway. John von Neumann, another interesting high level security clearance, Manhattan Project physicist. Allegedly, lots of questions on whether he was brought out to the Roswell crash site. Some of these scientists from Los Alamos who worked on the atomic bomb would have had the right physics qualifications and security clearances to be brought out and introduced to something of that nature. So I certainly question why he would devise von Neumann probes in 1947, just months after Roswell. Wrote a whole paper on self-replicating automata, machines that can build copies of themselves and go out and explore planets. Interesting concept. Another interesting scientist, physicist who directly testified or reported to in an interview with Wilbur B. Smith in 1950 that he was privy to reverse engineering of this alien technology. And he was a scientist who worked on hyper and ultra high tech frequency engineering, which is it's curious. And I wonder if there's more when you really start digging into these people's career, because I found a number of scientists that I started digging in more. I'm like, oh wow, they were involved in this too and that too. So this whole question of the MJ12 group, very curious. There's a lot of suspicious deaths involved, like James Forrestal, the alleged leader of this MJ12, who was the first Secretary of Defense in 1947 after Roswell. And then others like Frank Olson in 1953. He was an American bacteriologist and biological warfare scientist who worked for MK Ultra program and was found in a very suspicious murder. Never solved. Roscoe Hillenkoetter, he was the acting director of Central Intelligence during July 1947. And he told the New York Times, behind the scenes, high-ranking Air Force officers are soberly concerned about UFOs, but through official secrecy and ridicule, many citizens are led to believe the unknown flying objects are just nonsense. And that's how it's been ever since, apparently. Project Grudge, 1947 to 1949, was, they chose a bunch of people to pay them to, it was a joke. Jerry Cummings came in and revealed that the entire project was a joke, reported to Cabell, and Cabell Furious Institute's Edward J. Ruppelt is the new project director and starts Project Blue Book. And also Project Sign, December 1947 to 1951, where it almost ran simultaneously. It was kind of, it's kind of interesting that the Grudge and Sign were run both at the same time, but Sign took the a little bit more seriously until. So there's this whole issue that they have a real UFO study and then a fake public UFO study that they show to the public. And that whole issue was brought up with Project Blue Book when the Pinnacle Memorandum came out of J. Allen Hynek's notes. J. Allen Hynek was the head scientist on Project Blue Book for the U.S. Air Force. And in his notes, Jack Fillet found this Pinnacle Memorandum. There's also a Wilbur Smith memo that links more of Sarbocher to some stuff there. I meant to move that slide up to the Sarbocher part, but it got lost here somewhere. So sorry for that jump around. The Pinnacle Memorandum was in J. Allen Hynek's files, and it was CC'd to B.D. Thomas, Howard C. Krauss, A.D. Westerman, L.R. Jackson, W.T. Reed, P.J. Rapol, Papa Radol. That's who I believe it was. That I don't know who Repol was. I've never found this guy. And Elsay and Lund. So this is interesting. Start looking into some of these scientists a little deeper. I'll get back to that after we go into some of the other scientists that have come forward. So that none of these scientists have ever come forward. I'm not sure we've been able to track down who these was, but Howard Krauss was actually the director of Battelle Memorial Institute. So when you look into Battelle and Battelle Memorial Institute, you'll find out that they did a research and development contract on titanium alloys for Wright-Patterson Air Force Base in October in 1949. It started September to October. So they did a progress report on, what happened between those 2 months. And just those 2 months in 1949, metallurgists Eastwood, Craighead, and Fawn had gone through and created phase diagram charts for a whole series of different, binary titanium alloys and also tertiary alloys of titanium. But the one that they focused on most specifically in this 1949 metallurgy report for Wright-Patterson was nickel titanium alloys, which nitinol is a nickel titanium alloy. So this whole question of nitinol and nickel titanium and their titanium alloys, very interesting that they had actually developed in another report around the same time. I think this is in the same report, and it's a separate thing for their report to Wright-Patterson. And for Wright-Patterson, Elroy John Center and Eckert developed a way to analyze samples of titanium by dissolving them in chlorine carbon tetrachloride and then measuring the off gases. So this is very, very interesting because Elroy Center later said that he was given materials while working at Battelle that he believed were not made on this earth. He said this stuff was crazy and way too advanced. And even, I'm not sure he talked about the memory foil in specifics, but if you had this memory foil and you couldn't burn or break it, you want to figure out what it's made of. Well, why did they develop methods for doing that in 1949 for Wright-Patterson? Very curious. So UFO metals don't just start there. There's a number of evidence we have in the history for UFO metals. There's reported crash sites, a number of lists of reported UFO crash sites where craft and bodies were recovered. And there are people that run archaeological expeditions to go out to these sites and try to dig up materials for analysis and testing. And we have some of those materials for analysis, or some of the scientists we're connected with do. And we're trying to come up with better ways to analyze and try to understand those materials as well. This is the Bob White object. It's very similar to an object that was dropped from a Denmark UFO in the 1940s, which is documented in this CIC document. You can find that on Black Vault, and I'll post a copy of this presentation as well. All the links will be in the notes of all my slides. So if you want to look these documents up for yourselves and find the originals that I took these from, you can. But it was reported in the paperwork, the whole chain of custody of where it went to, and the witnesses and everything else. And it says flying saucer debris, you know. Anyways, interesting people that claim to have seen the Roswell craft or this flying, you know, been on these crash recoveries, talk about these UFOs as being you can see through from the inside. They're silvery gray from the outside looking in, but when you get inside of them, you can actually see through the walls and see to the outside. And that's amazing. If we could have airplanes that do that, you wouldn't have any blind spots. If we have cars, you wouldn't have a blind spot in your car if you could develop technology that could do that. And we have that technology. We're developing some of it. They have these this InvisiShield technology, very similar to how this might work, where you could literally have, you know, translucent walls where things could be, you know, light could just go through the walls. Interesting, you know, decades ahead of its time, but, you know, we're talking about UFO technology. Star Trek technology is now real, where you can make glass metals that are actually clear and stuff. So this is transparent aluminum. Yeah, Battelle could hold key information. There's certainly some, you know, one of these contractors that's a quasi-governmental organization. It's very interesting. They own and manage all of the national laboratories in the United States for the Department of Energy. Brookhaven National Labs, Idaho National Labs, Lawrence Livermore, Los Alamos, Oak Ridge. I don't see Sandia on here, but they manage all those national labs. That's a lot of control that they have over the science inside the United States. Apparently, the British also have a similar thing with Marconi Industries. I didn't get the chance to put that in here, but Marconi, the Marconi Corporation, has been a number of scientists who were shown things and came up with inventions that they couldn't talk about to their wives, and they were all happy and convinced. And then a month later, they travel to some weird place on a weird day and then end up committing suicide. And there's a number of these scientists that did that, who worked for Marconi, that I'm just starting to learn about and investigate, but there might be some connections there to some stuff, because they talk about some of these people that get exposed to this for the first time, and their wives' reactions to it, because they can't talk, and they spend hours just staring at the wall, and like weird stuff happens to people who get exposed to, or shown. Imagine if the government just, like, your job one day brought you and showed you an alien spacecraft, how you'd react. Anyways, there's this rumor that these, you know, in addition to managing the national labs, they manage all these national labs. They have what are called patent holding companies, and these patent holding companies were designed, you know, for national security purposes. So if, you know, a scientist working at one of these labs invents a new type of torpedo technology, that there's a patent holding company that snatches that up. So it doesn't go directly to the US Patent Office, and you can't look that patent up on Google Patent, so that the Russians or Chinese or whoever, other foreign intelligence services can't get a hold of those patents or that technical information. So this is the concept behind this, but a lot of people have complained that this also, that these companies or this organization of that the national security establishment has set up to withhold patents for national security reasons is a form of patent trolling, and that like they've suppressed free energy and alternative energy and anti-gravity and other such inventions using this method, because what they do is they have all the patents on it. And if you make a patent on it, they classify it and they steal it and they say you can't make money off this or work on it. You won't make any money on this if you work on it. So what's the point? And nothing gets done unless there's money involved. Let's be honest. I'm not a contractor. I'm not going to go and do anything for someone who I don't think has the money to pay for it or isn't going to, actually pay me for it. So nothing's going to get done unless you can make money off it. And this is a core method for suppressing advancing science and information and technology, and also, suppressing that kind of stuff. So I included that in to point it out. I also wanted to point out some of the other related agencies, like the Alien Property Custodian. It was created under the Trading of the Enemy Act in 1917, and this was a real governmental office called the Office of Alien Property, or the Alien Property Custodian. And what they would do is, if you had property, like say you had a bank that was funding the Nazi Luftwaffe, they could go in and take your bank from you because you're funding the enemy or you're trading with the enemy act. Or say that you had an invention and it might get out. They could take that invention and take it as property of this office. And there's a number of modern day laws that are in effect to prevent distribution and prevent sharing of that information. And I'm sure that our last speaker, if he was indeed approached by DoD, then he was briefed on the international traffic and arms regulations, and that is the reason why he will not answer certain questions and go deeply into science, certain classified things. Same thing with Salvatore Pace. So this is all under the Invention Secrecy Act. No, sorry. The Invention Secrecy Act is something else. This was a body of United States federal law designed to prevent disclosures of new inventions and technologies that federal agencies deemed could pose a possible threat to national security. So yeah, these things are installed and built into our patent and trademark office. One such example, I don't know necessarily that this was held classified, because a lot of things happened, right? So 1946, we jumped around a lot. I'm going back to 1946 now, a year before Roswell. A scientist named Edward Purcell and Felix Bloch discovered nuclear magnetic resonance, that atoms had a spin or a resonance to them, that you could talk to them through this and get information from them via these spin resonances. And this started a whole new field of science that was classified for a number of years until it really came out in NMR machines and stuff, where MRI machines, they took the NMRI out. They used to be an NMRI machine, but people were afraid they wouldn't get in a machine that said nuclear on it. So they just called them magnetic resonance imaging machines. And they talk to your protons through by tuning to the wavelength of your protons. And there's a big magnet that you go through, a big giant coil magnet. Magnet spin aligns all your protons. And then a secondary coil gives you a jolt in the opposite direction to set all your protons back off, and then they reset themselves. Well, this can cause some problems in the human body. Interestingly, that certain functions may rely on these spin quantum processes for, such as ion channel uptakes and other, protein conformation and other complicated chemical processes in the body. Worth mentioning, John Archibald Wheeler, of course, was involved in a lot of top secret research along with Edward Mills Purcell. Edward Mills Purcell ended up being recruited by the CIA to run Project Rainbow, which was their whole invisibility stealth program. And John Archibald Wheeler may have been involved in some of that as well. There was these questions about the Philadelphia experiment. I think that there was disinformation put out about, time travel and the soldiers being, warped into the ship and certain things. I don't believe those events ever actually transpired. At least I couldn't find any evidence in my investigation that those events actually transpired, and they seem to be more like disinformation that was put out to disrupt rumors about electronic warfare testing that they were doing on the USS Eldridge with these transmitter and receiver coils that, they called Tesla coils. Of course, if you just know a Tesla coil, then you won't know the difference between, a transmitter and receiver coils or other types of coils. So I think that they were doing degaussing or deviation and degaussing of the ship. They were trying to make it radar invisible by using, different types of receiver and transmitter coils. But again, until documentation comes out on that, this whole thing is going to be a big mystery and something we're going to continue to talk about until someone digs in and really breaks that case. We'll get on to other types of antennas. So when you get into Edward Mills Purcell and his research that went on with Project Rainbow, that actually led to the discovery of, metamaterials. And the Russian woodpecker was kind of like a metamaterial antenna array, for this over the horizon radar. They had set up this giant grid and look at the beautiful geometry of that. Same thing with HARP. And that geometry lends to the electromagnetic response and projection capabilities of these types of antenna arrays. So we've known about this since I think it started in 1958. So they hired Purcell for that. The CIA Project Rainbow actually started in 1958. So there's about a decade of gap. So right around the same time NASA was being discovered. And this developed the wallpaper, this anti-Soviet radar coating that they designed for the U-2 spy plane. It used a grid-like pattern to absorb and deflect incoming radar spectra. So we know that the electromagnetic spectrum is divided up according to these FCC frequency allocation tables and charts. There are a number of frequencies which are, banned or owned by the Department of Defense and military and other such that people, regular citizens are forbidden from using. And it's interesting interesting place to look and go study too. I just figured it worth mentioning for really quickly that this was developed during Project Rainbow. They mapped the whole EMF spectrum and figured out which frequencies were good for what, which ones were bad, which ones caused, harmful interference or problems with the human body. And, the 60s, they discovered the microwave auditory effect and, a number of things so that they were able to find those frequencies that were bad for the human body and then block them off on the allocation tables so that, it's no longer legal for people to be broadcasting on frequencies that could, harm you. And that's one of the big things that I brought up during all that whole controversy over, 5G and all the conspiracy theories that were going on around that, and just trying to straighten out the science on that with the energetics and the interaction and resonances of what frequencies and will resonate with the human body and other things. There's a deep science to it. Barium titanate and the Fred Dunham story is, of course, interesting. Barium titanate comes up in the late 1950s on the blackboard in the Bonson Labs study that was done by that was done at Bonson Labs with Byfeld Brown. And Byfeld Brown were working there. They had written this barium titanate up on the board and noted that it was this ferromagnetic property. But Project Rainbow developed this barium titanate and other methods into these paint for our stealth program. So our stealth aircraft were painted with a barium titanate paint, which would actually be radar absorbent or reflective. It would help with the radar absorbance or reflection of the actual surface of the material. And there's more advanced, of course, Fred Dunham. Okay, the Fred Dunham story. Fred Dunham was a security guard at Area 51 who got really sick after he was these burn pits. They were taking all this old barium titanate and barium and strontium and all these other things that they had built out at Area 51 for these secret programs, and they put them in these giant burn pits and burned it all. And black smoke for miles. He got very sick, ended up suing the government. He died recently. Yeah, real sad story about the real history of Area 51 and some of the things that they've done out they did out there just in pursuit of this technology and the pursuit of getting rid of it or trying to cover it up, which backfired on them. We probably wouldn't have heard all about that if it weren't for Fred Dunham. So a lot of people wouldn't have heard of it. Metamaterials, creating the first invisibility cloaks. So they these invisibility cloaks. So this was the first human ever cloaked with an invisibility cloak. This was this first one was made by a guy named Dr. Nathan Cohen, who runs a company called Fractal Antenna Systems, which are super interesting fractal pattern antennas. So he builds these metamaterials out of printed fractal patterns on these objects. If you zoom up close to that, you'll see that it's printed fractals. Yeah, they cloaked him at microwave, and the way that works is that your signal goes into this material and then goes around it. So very interesting stuff. So crude metamaterials can be built with these types of split ring resonators. There's a number of different types. I think the S rings work the best. Apparently, these S ring resonators. There was a study that I saw recently on that paper I read. These acoustic metamaterials can also be built that do the same thing with sound waves that regular metamaterials do with light waves. And there's a whole study that was done into U.S. Navy did on this into sonar invisibility for submarines. This is real stuff, real cool acoustic metamaterials. This is Echo Noise Control Technologies in Ontario, Canada, the world's quietest room. For ultra sensitive microphones and other testing of science equipment that requires zero sound or no noise. Can be conducted in that facility if you're looking for something like that. There's also acoustic metamaterials that are chiral metamaterials. So one of them is an example is the cochlea in your inner ear, which is responsible for you being able to hear me right now. It separates all the frequencies and maps them out so that your brain can attenuate the lower frequencies, which get absorbed by the hairs on the inside of this cochlea right at the opening, and that filters out those frequencies as you go further into the seashell. And the higher frequencies are at the inner part of your inner ear. So, and the neurons on all these different hairs go to your brain, and those correspond to all the different frequencies that your brain then breaks down and interprets as the frequencies that you're hearing and the sound that you hear. So chiral metamaterials can also be used to sinusoidally or chirally polarize light. Not sure why you'd want to do that, but there might be a reason or a time where you want to do that and need to know about these things. John Pendry actually was the one to coin the term metamaterials. They were predicted by a guy named Victor Veselago in the 70s, late 70s, but weren't actually created or discovered until around the mid 80s, I believe. The late 80s is when they really started publishing and getting public on them. these C-shaped split ring resonators, and this is the Swiss roll. These the 2 C-ring resonators with another. These seem to work really good as well. A lot of experimentation we're done with those types of resonator systems, but the fractal antennas seem, I think, are some of the most curious. It's just crazy how that works, just the geometry of it. You add that fractal pattern to it, and the more iterations that you add, it's orders of magnitude that your fidelity goes up. So it's just really really cool stuff when it comes to the geometry of our universe and how nature loves geometry. And geometry can also be used inside of these materials, which are mapping materials. These materials direct the flow of light to change the direction of the flow of light. So they're able to really, all this thing really does is it spreads out in a thin line horizontally all the light that comes from behind it. So it smears it out and just tries to take, so the most amount of light that's coming through will overshadow and blur out the least amount, so right here, there's not enough for his head, and it sort of moves his head over to here. You can sort of see his head in the shield on the right-hand side of it, that it's moved it laterally about 12 inches over, just from, and this is all due to the structure of the atoms in this clear translucent material. That, and if you could do this perfectly with every frequency with no losses, you'd have a Harry Potter invisibility cloak, and not one that you can make with the green screen, but in any case, there's other ways of bending light. You can use this mirage effect that they developed, this mirage effect to hide objects with this series of carbon nanotubes. They run a little bit of voltage through the carbon nanotubes. It reaches thousands of degrees in just a couple nanoseconds right at that surface. And that really high temperature gradient causes a temperature inversion or a mirage effect, which actually causes the wires to disappear from view at this angle. Similar mirage effects, the Flying Dutchman effect, also called Fata Morgana, is a temperature inversion mirage effect where you can bend light just using temperature, cold air on top of hot air, a cold surface on top of a really hot surface. And these can be created and maintained using, topological insulators. So lots more sources here I have on invisibility theory, documenting it, as far as it goes back to everything we can find in the academic literature, a deep overview of sources on invisibility. And if I'm missing any that are earlier than this for the initial development of this, I would like to incorporate those or get more information on those, because I know there are probably a lot of classified stuff that may not have been included on here that may have come out or is still coming out. Recently came out about these BAE has developing this adaptive camouflage protection using these chromatic hexagon shaped cells, which can heat up or cool down. They even have ones that can change color. With these hexagons, so the hexagons can change color, and they can also change their thermal imprint, so they can make the thing look like a SUV from far away. This is a thermal infrared thermal imaging camera. All those drones that we're finding the tanks in Ukraine using thermal imaging. Well, the tanks have this technology. You're not able to see them. There's also counter invisibility technology. China's developed a number of quantum radar systems using pairs of entangled photons, and they can detect things using entanglement, quantum entanglement. So even if you're using a cloaking device or something, you're still breaking quantum entanglement, because even the photons warping around you, it's interacting with the metamaterial in your invisibility cloak. So they can detect you using quantum entanglement. Really interesting. The history of, now we're going to get into propulsion technologies and the history of U.S. Air Force anti-gravity research. Again, thank you all for tuning in. And sorry this is gone. I've already been an hour, right? I'm like halfway through. Oh God, I'm gonna have to try to go a little quicker because there's a lot of material.
You know what, Jeremy, if I could jump in real quick, Mark just called me and said, keep him going for another hour. So that's perfect, man.
All right, cool. So Nikola Tesla has a UFO patent from 1928. Not sure anyone's ever built this successfully or that it worked, but there's people working on this stuff at least. Thomas Townsend Brown the same year discovered the Biefeld-Brown effect with a Crookes tube, and had a lot of ideas using this and got a lot of funding from a number of different people during the 1950s to build and work and to test this stuff out. The 40s, it was harder for him to do that, but I think after the saucer craze in 47, he was able to get funding and actually get interest in research and development into actual technologies. And that was useful because these things we'll talk about later were actually highly, a lot of good technologies came from that, even though they didn't produce anti-gravity. Lots of useful technologies did come from that. So there was a 1957 quantum gravity meeting in Copenhagen with this was Oscar Klein, not to be confused with Felix Klein of the Klein bottle fame. Charles Meissner was there, discoverer of the Meissner effect, and a number of other scientists, famous scientists of the time. There's a lot of other interesting contributors to the 1950s GR literature. I include in here with some background of it wasn't a very popular subject until it seems like the 1950s or 60s. It took off a little more. But earlier in 1957, before this quantum gravity meeting that they held in Copenhagen, there was a more interesting quantum gravity meeting that was held at the secret college in University of North Carolina, Chapel Hill. And this secret gravity conference I learned about from Eric Weinstein, and apparently Mr. Smith was one of the attendees, was actually Richard Feynman of the Manhattan Project, one of the PhD, a Nobel Prize winning physicists, one of the most smartest men who ever lived, and he was there attending this secret gravity conference in 57 under a fake name. Very curious. 1955, we have the Bonson Company and a letter from Andrew Bonson to Bryce and Cecil Dewitt, thanking them for their contribution and also helping and coming by the lab, and that the Air Force has now shown some interest in our work, thanks to some of his comments and stuff. So the Air Force, 1955, getting interested in the Bonson Company. The Air Force also working with Bryce and Cecil Dewitt as their head physicist for this secret college to sort of investigate these things for them as a cutout or what have you. So they're not, interesting. This gravity conference is a lot of interesting stuff in those papers from the gravity conference, including discussions of wormholes and torsion physics, lots of different ideas for a role of gravitation. Lewis Witten was also part of this, and it's curious whether there's an argument that Eric Weinstein had, I think, with Brian Greene, which was great, where they argued back and forth on whether Witten sent modern physics on a wild goose chase with the whole string theory, and that string theory was just invented to disrupt and throw people off of all this better physics that was being developed with this at the time. I don't know. It's certainly curious, but Richard Feynman, he goes to the secret gravity conference and tells this argument to Herman Bondi, and Herman Bondi writes down this sticky bead argument. I thought was super interesting. The sticky bead argument was the basis behind Weber bars, these early gravitational wave detectors, because Feynman's gravitational wave detector, he said it's simply two beads sliding freely, but with a small amount of friction on a rigid rod. As the wave passes over the rod, atomic forces hold the length of the rod fixed, but the proper distance between the two beads oscillates. Thus, the beads rub up against the rod, dissipating heat. And apparently he never published or talked about this until this secret gravity conference. And then Herman Bondi took the idea and published on it. And then, we have Joseph Weber. He was a U.S. Naval Academy gravitational physicist who built the first Weber bars, the first gravitational wave detectors. And a lot of the LIGO interferometer stuff is based on research that Joseph Weber pioneered. And Weber also worked on U.S. Navy laser technology. So in addition to that, he spent a lot of decades during the 1960s helping to develop lasers and laser technology. The history of laser technology from when they built the first working laser in 1960 up until some of the more advanced lasers. Laser physics, I'm not going to get into all of it. It's not, we don't have enough time to get into it. This is just the real core stuff that's focused on anything related to the U.S. Air Force or government interest in UFOs. All right, so here we have propulsion concepts of advanced propulsion concepts, Project Outgrowth of U.S. Air Force Rocket Propulsion Laboratory at Edwards Air Force Base, published in June 1972. And this is when they were starting a lot of laser research and laser physics research, as well as, unmanned aerial vehicles, and that kind of stuff. But they realized in this report, and you can see something happened in the late 1960s at the close of, 1968, they closed Project Blue Book, of course. And the Air Force then goes and publishes this 4 years later, saying that, this Project Outgrowth, saying that, we really need to outgrow our old ways and our old technology and find out how we can grow into the new ways and develop the new material science and some of the other things that we need. So I think at that point, they might have looked at some of all the nanotechnology and all the advanced physics and really thought it was beyond them to really get a hold of that and understand that stuff. And that's apparent when you read this report and look into it. There was, of course, back to the lasers, the slide's out of order. Q division still classified the powerful lasers that they were doing out there. I'd really like to see an experiment done with a really powerful laser using it with the Cavendish experiment to see if we can alter gravity using really high energy light. And we'll get more into that later. Nonlinear optics, interesting branch that gets in, when you start pumping these lasers to these really high energies, the electric field, the polarization of the vacuum, can't handle all that energy going through it. So you actually have nonlinear effects that pop up in optics when you get up past that Schwinger limit. The vacuum itself becomes nonlinear, and the superposition principle no longer holds. A lot of UFO reports, there's the classic sound that a UFO makes. Everyone knows, what does a UFO sound like? That pulsating. Well, that's caused by a beat frequency in physics. So when you have two frequencies that are going over one another, two or more, you get more than that, you get this four-wave mixing effect, and you can get some interesting nonlinear optics and intermodulation phenomenon. It's also alleged that you can use this for pumping states of atoms and pumping materials because the four waves of this leftover energy. But there could be mixing of waves in this, and that's why it's important to look into the physics of this kinds of stuff. Of course, the four-wave mixing that I got from Paul Laviolette, who is sad. I'm saddened to say Paul Laviolette recently passed away. he was on, you can go look up he was also on a guest here before in the past on the conference, but his book talked about this, one of the first to really talk about this and reveal this microwave phase conjugation and these phase conjugate mirrors, which are, really interesting mirrors that reflect and the incident angle. It doesn't reflect off it at the same angle, it reflects back no matter what angle you shine at it. And there's weird effects and weird things that you can get from these phase conjugate mirrors. And I encourage people to go look into those materials a little more, because apparently you can use these phase conjugate mirrors and this microwave phase conjugation with this 4-wave mixing to pump these materials and actually get propulsion and lift out of it. And it may have been developed off of this, but this technology really goes back to Lake Marabou and Project Skyvault and the Lightcraft whole stuff, which started, with John Lewis and Mirabeau at Rensselaer Polytech in the 1980s, and went on, was talked about briefly in a couple, Future Fantastic was a mainstream thing that talked about these laser light craft of the future and how everything was going to be these light propelled spacecraft, and that disappeared. And a lot of this stuff went classified, and a lot of this research continued, but just under deep secrecy. So it just wasn't allowed to literally get out. It was being used for a lot of other stuff. NASA technical papers, 1986, laser powered magnetohydrodynamic generators and stuff. There's patents on all this stuff going back. This whole thing with the Kantrowitz limit, yeah, they threw out the idea of ramjet engines. They realized that you can't get this supersonic critical flow through these engines the right way. I mean, you're only going to reach this limit, and that if we want to pass that limit with our aircraft, then we need to warp the air around the craft instead of trying to send it through turbines and jet propel it out the other end. And so this is a patent by Kevin Kremeyer, I think is the name, and it blasts a laser induced air ignition. So they blast a laser a distance L out in front of the nose cone of the vehicle. And actually interesting that NACA did this in 1947 with a nose cone. So they had this nose cone, this airspeed head, right? It said it was an airspeed head for pilot instruments, right? That's what it says in the inside Chuck Yeager's XS #1. Well, that's the public version that they give you. All right. The classified version, which they don't tell you, is that this nose cone was electrostatically charged to a very high voltage. And that voltage created an air spike that would basically reduce the bow shock in front of the craft. This X1 would never have been able to break the sound barrier if it didn't have that electrified nose cone, which is a classified component of the technology. And this, of course, they got rid of the nose cone, and now they use this laser where they can blast the air, and it's much more powerful. They literally heat it. They supercavitate the air out in front of the craft so that they can remove all the air resistance. And apparently it works in water as well for these hypersonic supercavitating torpedoes. Also found this other interesting patent on laser-based flow modification to control vehicle flight paths by the same inventor, that they can shine lasers on the wing of an aircraft and create these same effects to create flow modifications, so they could turn your plane or control your plane or make your plane crash using these lasers, which would leave no physical trace of, on the aircraft itself. It would only warp the air that's going around the craft and cause the plane to malfunction. Curious. 1958, 1960 Bonson Labs experiments by Thomas Townsend Brown in North Carolina. I talked about this before. I talked about the barium titanate, how you can see it up on the board and one of the on the blackboard in the background of one of the film that you can get thanks to Stan Dio. having posted the whole thing. The Bonson Labs were an air conditioning manufacturer who had a bunch of money because air conditioning was big, and they were one of the few companies back in the 50s that did it. And so they made a lot of money with air conditioning. And, you know, like a good CAO and businessman who has lots of money, they tried to give back and actually do something useful for the science and humanity with that money. And they chose to fund anti-gravity research. So good on them, because this wouldn't have taken place and we wouldn't have this awesome historical archive of knowing all this. And it brought a number of scientists together too. Bryce and Cecil Dewitt visited the lab. You can see John Lear's father invented the Learjet, go to the lab at one point. There's a number of interesting personnel and scientists who show up to the lab and go check it out. And some of these really interesting ideas that came out of these, you know, experiments and these ideas, the plasma vortexes, that magnetohydrodynamics, that they could charge the air and then, you know, move the air around, and lots of stuff was thought up and experimented with at Bonson Labs from 56 to 59. Really cool stuff. Again, I don't know all these people here, but I'm sure you can go through and figure out who they are. We did a lot of Mark in particular has done a number of replications and experiments into this, and I know that Tim's built a number of these tons of these lifters. I mean, this is how I got into this 20 years ago with American Anti-Gravity, and I know MIT built an electric plane that runs on, you know, Biefeld-Brown effect, and it's pretty cool and efficient and good. But again, is it anti-gravity? There's a whole debate over this, and you know, the ESA Martin Tajmir, it says, you know, no, it's ion wind. And, you know, there's a debate going back and forth on it. But one thing is for sure, that these materials have some unique properties based on these hysteresis curves. And there's classes of materials you get shown in this chart here: piezoelectric materials, pyroelectric materials, and ferroelectric materials. And here's their you know, electromagnetic response charts. And this curve is called the hysteresis curve. And this is important for charging and discharging dielectrics, which comes up later in some of this research. So 1950s, there was a lot of interest in gravity research. You had techno scammers like Otis Carr build this UFO flying saucer and take people's money to invest in his company to develop anti-gravity. And, you know, brought this whole idea forth of this gyroscopic propulsion, which was later revived by Eric Lathwaite in the 1980s, and a number of popularized by the Sandy Kidd invention, the Sandy Kidd, you know, invention, which it's just climbing a central pole. It's literally, there's a central pole in the middle, and it's using that as support and climbing up it. It's not a real anti-gravity device, and I challenge anyone out there to use gyroscopes to make gravity. We did see some interesting anomalies in some of these machines that we built, though, and this really, the research and the expert on this is Mike Gamble, and Mike Gamble is he's on APEC of February 13th, 2021. Was a good one to go back and look up, and he built these huge gyroscopes for Boeing research, and did a ton of research on gyroscopic propulsion and stuff for Boeing. So really the expert to go to on that whole thing. There's this whole idea that, you know, gravity might work the same as electromagnetism, that there might be a gravitomagnetic analog of gravity. This is called GEM theory. GEM theory was tested with NASA's Gravity Probe B, and they found that, yes, there is a frame dragging effect around the Earth. And there is something to be said about GEM theory, though, that there's some, you know, problems in the math when you really get into the the specifics of it. And for that, I would go to Nathan Innan's presentation for SSI APW 2020 and check out what Nathan Innan laid out in about gem theory in his presentation, because he really does a phenomenal job of just destroying it and showing, you know, how it might some other approaches that would work a little bit better to this. So these are things that have been tried in the past, and there's funding that went into these. And in 1959, you had Frederick Alzaphan, you know, publish his first paper in Advances in Astronomical Sciences. These are all ideas that have been thought up and tried before. And so Alzaphan thought up this idea that, hey, you know, you get these nuclear magnetic spin resonances. What happens if you get them all aligned? It could maybe gravity be like a random or a stochastic effect that's you know, affecting all these molecules because of their random interaction, and that if you line them all up, that you could get, you know, gravity to shut off. And so this was early on, and again, you know, 1940s is when this was discovered. 1950s is when it was really being developed, and 1960s is maybe it's still being developed today with, you know, spintronics technology, topological insulators, you know, spin transistors, spin orbit torque, chiral magnetics, a number of, you know, newer technologies, but it's all based on these spin magnetic resonances of atoms and stuff. And lots of experiments were done trying to negate gravity, but we discovered a lot of other cool stuff in the process. Didn't discover anti-gravity through aligning these spins and stuff, but we discovered, you know, how superfluidity works. Superfluidity was first discovered in 1937 by Allen and Meissner, and kind of have a better understanding of how it works now, thanks to these you know, spin alignments and these vortices that form to produce really interesting quantum liquids. Now, a lot of spin gravity stuff has been tried. I mentioned this, you know, Nazi Bell experiment and how similar that was to this Kecksburg acorn that crashed in 1965 out in Kecksburg, PA, UFO crash. Rumors that it's using rotating liquid mercury. Of course, mercury becomes a superconductor at really cold temperatures. No one really knows why. And also it's magnetic and will spin around if you apply magnetic fields to it and stuff. So apparently General Electric did a lot of research into this in the 70s with a guy named Henry William Wallace in Valley Forge, Pennsylvania. You can go and look up and find some interesting history and stuff on that. But a lot of it's either classified or just lost to the history. We do find some in the academic literature as well. 1966, DeWitt published Superconductors and Gravitational Drag. You can look this paper up in Physics Review Letters. And really interesting that, you know, he was predicting that spinning superconductors could produce this gravitational drag. And it seems to be related. Of course, you know, we all know about Project GRASP and Boeing and Podkletnov, Ning Li, and NASA on their research with spinning superconductors and how that might produce gravitational effects or anomalies. Now, why might that be? And in some of the deeper physics, you get into this whole idea that everything's waves. It's all spatial geometries and wavelengths. It's the fields that create the matter, and then the matter that creates the fields in this sort of background feed loop cycle that kind of produces everything in our universe. And these interpretations of physics, I think that the pilot wave theory or Bohmian mechanics is the proper approach. I don't believe in determinism and the Copenhagen interpretation and some of these other ideas. I think that a lot of it lies in just the connections of space time. Maybe it's all space and time. It's just the way that it's connected. And the other theory is that space and time might just be emergent of quantum entanglement and something else that's going on the smaller level. Certainly interesting that the universe seems, well, first off, there's quantum spins and some of that other stuff that's can be resolved through geometry and really the math that you have to dive into to really get a grip on that. The UFO materials, I'm back to this now. Apparently, I didn't move that around, and this is a big presentation, but these things might be supercavitations, might be, you know, terahertz waveguides or waveguides that are used to pump a light into. Jack Valet used Dr. Gary Nolan's lab, and I think there's 2 R's in Gary Nolan right here, to analyze some of these UFO samples that he had. He goes to crash sites and documents all these. He's been doing it since the 70s. He's got all these pieces of metal, and they analyzed them and found all these, you know, strange isotope ratios and stuff, and the building blocks of what they're working with. A lot of those ingots that get dropped out of UFOs look like they have supercavitation done to the surface, and they could be fusion fuel. There's a theory that they're, you know, cold fusion or some type of supercavitation fusion fuel that's being used to power the craft. I did a whole coverage of the series of lectures and also colloquium presentations of all these top scientists at cold fusion. This was in 2014, which is almost 10 years ago now. So, and half the guys in this room are dead now. And I got all that on film and recorded it from back in 2014 and preserved that for future generations. This is like tons of cold fusion research that's blacklisted by the mainstream, being conducted by very intelligent, very serious, very real scientists. And I encourage anyone who's interested in learning more to go check that out from back in 2014 when I covered that at MIT. Yeah, lots of stuff on these models and how cold fusion might work. There's also mechanical metamaterials and these ideas that, you know, parts of these ships or alien ships might be engineered or designed using mechanical metamaterials, as well as photonic and other types of metamaterials. There's this whole talk about the terahertz gap, is this gap in the electromagnetic spectrum where stuff doesn't really work or doesn't break down, and it's associated with the 0 point energy of the atom itself. That gap in the spectrum, apparently it's related to the fields that produce matter or mass, and it's right smack in the middle of the spectrum. So you have everything that's on this side and then everything on that side, and this is right smack in the middle. And apparently it's this where the 0 point field coincides with the structure of the atom, which gives rise to the Higgs field. And there may be something to that where you can warp gravity using strong enough terahertz waves. Of course, you get down to this, this is imaging and tweezing. So you have to correspond your wavelengths to the size of whatever you want to interact with. And this is like scanning electron microscopes, tomography, you know, deeper, and then X-ray diffraction, NMR. Again, these materials, why are they layered? What could possibly be going on here? Well, this kind of look like Bragg mirrors or dielectric mirrors. They could be creating the acoustic pyramid, or the pyramid of Chichen Itza. It was proven in a paper here by Nico F. Deklerek and Joris Degriek that it's a real world example of an acoustic Bragg reflector, where it takes an incoming clap or single pulse and returns a series of sharpened, very rapid return pulses, which actually they clap and it sounds like a bird when it reflects off the pyramid. They say, oh, it's a Quetzalcoatl, and I don't know how it does that. Well, it does it because of Bragg reflection. Could have something to do with these photonic crystals in the structure of these surfaces, where you're pumping, you know, pulses into this of light into this, and it's breaking it down or reflecting it in localized coherent structures, which that coherence is maybe important for producing and setting up entanglement and coherence. And of course, terahertz comes up in Isaac Kemp's PhD. I was searching for top secret, research at Wright Patterson. I found this university student who was working for the ultra-fast photonics lab at Wright State, who'd been arrested for bringing documents home from his work at Wright State University. Apparently, Wright State's ultra-fast photonics lab is involved in some classified research for the United States Air Force, which is right nearby, coincidentally. Isaac Kemp wrote his PhD thesis on terahertz imaging for aerospace applications and a number of terahertz technologies. So gives us some insights into, real government research into terahertz and, some of the applications, at least. I wonder what he would think of this whole idea of this Hal Puthoffs and this metamaterial that we blast terahertz at it and it can float. I'd really be curious to see what he thinks of that kind of stuff. And if this is the public stuff that he's publishing on, and it's, ways to look at old aircraft's hulls through the paint and determine if there's damage, that can't be all that they're doing with this. It can't be that serious if there's got to be more to it. Anyways, there is more to it. We know that these security applications use these millimeter waves at the airport to scan, when you go through security checkpoints at the airport. But these terahertz waves would be able to see through buildings and walls in a manner similar to like that movie Eraser, where they had those guns that could see through the walls and stuff. So it's like the millimeter waves that they use at the airport, but like way another level. Anyways, it's based on this antenna theory, and this is important for understanding the effects of how UFOs work, because there's near field and far field. There's this radiative and non-radiative, non-radiative and then radiative. So stuff you can check electronics, and they have to, they have FCC compliance testing to make sure that like your electronics aren't radiating any electromagnetic radiation that's unwanted or could cause interference and stuff. And Fresnel zones are interesting because they occur inside the range of between buildings and stuff. This is why walkie-talkies won't work outside of the certain ranges, because they operate within that Fresnel zone. And if you step outside of that, it doesn't work inside that range envelope. So yeah, you can take the Helmholtz equation and apply it to anything, including your apartment, and figure out where's the best place to put your Wi-Fi router to get the best signal everywhere in your apartment, just by solving for the Helmholtz equation for the geometry of your building. And that was done by a PhD student named Jason Cole. It's a really cool thing, but he did figure out where to put his Wi-Fi router. So resonators and trapping things inside of Helmholtz bottles, for example, or a Helmholtz resonator cavity. This has been known about for over 100 years, and I think it could provide some futuristic solutions to some of the problems that we're currently facing in modern quantum computer engineering with regards to the photonics and how to build better photonics and systems. We also have waveguides and mirrors, and with some of these advanced materials that we can build photonic circuits, which use spintronics and photonics instead of electronics. So you're not pushing electrons around, you're actually just pushing light or energy around in a much more energy efficient, and also the size of these things compared to the limit of what you can build with conventional electronics is off the charts of what we're going to be able to do in the future with photonics. So I think that if we were looking at alien technology back in the 40s or 50s, and it was something like this, we would have obviously felt pretty overwhelmed, even in the late 60s, 70s, kind of see where they were going with Project Outgrowth and some of the conclusions there after they closed Blue Book officially. 5D data storage. Again, you can store data in these 5D crystals. They're called the Superman memory crystal. This is real technology. It's a nanostructured glass for permanent recording digital data. It said it has it can store 360 terabytes of data for billions of years. It's super stable. It's first demonstrated in 2013. So 10 years ago. This is 10-year-old technology. And Hitachi and Microsoft have been working on developing this ever since. There's also spin glasses, like you can imprint, so similar to how you imprint these things on these memory crystals, you can imprint magnetic fields on these spin glasses, either for memory or for other purposes. If you wanted to create a type of spin, one where the spins would go a certain way. So paramagnets, for example, to show what happens in paramagnetism versus ferromagnetism or diamagnetism, and how these spin glasses can lock in or trap these spins. And some of the interesting things that you get with this. So this is condensed matter physics of these spin glasses, and when you get coherent states as well, you get strange metals and also and then Fermi liquids when there's complete decoherence. So there's a whole new class of materials in here with some really interesting properties and applications that could be useful for engineering, quantum systems like quantum computers or UFOs. And again, the classical critical order, and you get this ordered state in the spin glass where everything's ordered and stuck in those aligned spin states. And then you get this quantum critical state where you get strange metals, and then a disordered state where you just get this Fermi liquid. Now, strange metals, as Leonard Susskind pointed out in his interview, his presentation, I think this was, I have a link to it in the description of the notes of this slide presentation, but strange metals are topologically equivalent to extremal black holes. So you want to create a black hole for that half of your wormhole. These strange metals might be a way to do it. And the behavior of these systems, these charge carriers are bosons, which has never been seen before. It's really weird physics that we're tapping into, and we're able to build these materials now that exploit quantum physics for different uses. And I think that if UFOs are beating gravity, then they're exploiting these innate understandings of quantum physics for sure. So does gravity come from that random 0 point friction or 0 point frequencies in those green arrows? So basically you have this many particle system of this quantum liquid and all these interactions that are random interactions that add up. And this is a theory called stochastic quantum gravity. But it basically says that if you can order all those interactions and figure out those interactions and figure out what's going on to and at the quantum physics of mass and those interactions that produce mass, then you might be able to warp the fabric of space-time. Well, how can we do that? And is anyone working on this? Well, Lockheed Martin hired a physicist named Bernard Hayes, and he wrote a number of papers on this idea of generating inertial reaction forces through the vacuum and gravity in the quantum vacuum hypothesis. Very interesting stuff. Skunkworks advisor, from 1996 to 2000, who knows? Hal Puthoff wrote some papers with him, and the interesting approach to general relativity using polarizable vacuum, where you can locally alter your permittivity and permeability of free space, thereby, changing the way that gravitons are that speed of gravitational interaction with the craft. Very interesting stuff, but how do you actually produce it and create it? Well, that gets into a number of things. We already talked about Sal Pays and his US Navy patents, and some of those ideas he's had with the Schwinger limit and the superforce unification, polarizing the vacuum that, you know, you pump enough energy and you can create these positive and negative energy states. There's an idea that, you know, muons might produce anti-gravity, but they, you know, there's an idea that antimatter might produce anti-gravity, but that was disproven recently. So we're back to square one with this idea of this dynamic Casimir effect or moving mirrors. This was mentioned in DoD, the DR Defense Intelligence Reference documents by Eric Davis. And this optical cavities where you can pump one side of the optical cavity, thereby producing these interesting effects. So this ties into some of the stuff I'm going to get into in a second. But again, quantized inertia, DARPA has contracts with this guy, Mike McCulloch, on this maritime Casimir effect, and they're working on developing this quantized inertia similar to the M drive almost. And people are like, well, how can you kick off nothing? How can you push off of nothing? Well, you're not pushing off of nothing. You're pushing off of Rindler horizons or information horizons. And in Rindler space-time and your local light cone, there's basically this wall that if you break the speed, if you push something faster than the speed of light, you can't reach what's beyond it because the information horizon. And so you basically have found a quantum kickboard. A quantum kickboard where you can push off literally nothing, the fabric of the Rindler horizon in space-time. And the way you do this is with incredibly high rise times. And this was discovered in, you know, Byfeld-Brown's work in the 50s, and others have pointed out these. You need these sharp sawtooth waveforms with this, and it's all about the rise time and getting that punch for the rise time. We would do this through spark gaps and a number of other methods that our engineers have used to do this in the lab as well. So there's a good example right here of a spark gap. Roger Scheuer has also presented on here about his M drive, and it's the same kind of idea. You have this cavity with microwaves being pumped in, and you're pushing off of this quantum kickboard, creating a larger force out one side. And this is based on battle-tested physics. You have this Heisenberg uncertainty relationship. So as you have that really short time, the energy goes. If you make that time go to zero in the time version of the Heisenberg uncertainty principle, your energy will go really high, astronomically high, and could go nonlinear. So that's how you could break that sort of Schwinger limit for a split second using this Heisenberg uncertainty principle. And the other idea is by using, you know, squeezed light or squeezed coherent states that you're squeezing that X factor of the position, so your momentum can go to infinity, or go incredibly, not infinity, but your momentum can go can jump. So you can create momentum potentially by using Heisenberg uncertainty principle. Again, this might be better if you use polariton lasers and these other types of systems. We'll get into that a little more. There's this idea by Nick Vamanakis on generating negative energy using cavity exciton polaritons. This is also talked about in some of the DoD Defense Intelligence Reference documents by Eric Davis, where he talks about methods of generating negative energies. He mentions squeeze states, and I believe he mentions polaritons, exciton polaritons. So these are quasi particles. Yeah, they looked into antimatter, anti-gravity, and found out it didn't work. So that's been debunked. They have the same gravity. Protons and antiprotons fall the same. But these surface plasma and polariton condensates, and what we can do with squeezed vacuum state in these states, there might be some interesting physics going on here. Also called liquid light, room temperature superfluidity was observed in a polariton condensate. So you get these polariton condensates inside of these liquid light, trapped in slowed liquid light. You can get room temperature superfluidity and superconductivity, which is amazing. This is just mind-blowing. This has been battle tested by a number of different labs. So this is 100% real. Len Howe won the Nobel Prize, I believe, for they slowed, stopped, and restarted light using these, the photonic crystals in these materials in their lab. Really impressive stuff. But we're unlocking a lot about how light and the electromagnetic forces hold the universe together, communicate all the information with the world to itself, and understanding how it does this with different materials inside of different materials with near and far field effects. Spintronics, a whole nother, it was mentioned in one of the 38 study areas under OSAP course. Big stuff going into this as far as the future of electronics, and also quantum physics, photonic circuits, photonic information systems, quantum information systems. And this is all predicted by Richard Feynman in his 1959 lecture, There's Plenty of Room at the Bottom. Again, get into the Hal Puthoff stuff with the dielectric filling between two metal mirrors, and this wave propagation, and this in these what could be the physics behind these bismuth magnesium samples, the bismuth magnesium samples that he alleges were part of the Roswell wreckage or Roswell craft. And we'll talk about this whole idea a little bit. I have some new ideas on this that I want to get out, and it's the last slide. Metamaterials, of course, yeah, you can pump metamaterials, and the energies are high enough, then nothing will get in, because your energy of this will be higher than whatever it is you could block. So yeah, you could create some pretty crazy force fields and shields, even using these types of technologies in the future potentially. Jack Sarfati and his low power warp drive theory on how the tic-tac works, the stress energy tensor and how we manipulate that. It's good theoretical physics, but I'm trying to focus on the experimental side of this and how we can actually, just break it down for the engineers to actually try to build this stuff in the future, and what physics need to be looked into for that. I think that these, so this diagram here shows the phase state, displaced vacuum coherent state, squeezed coherent state, squeezed vacuum state, and just regular vacuum state, and what that means in terms of the Q quadrature and P quadrature. And these Glauber states are interesting, along with this Frank Condon principle. This comes up in some of Wheeler's later work in the 1980s. Well, they were, which I thought was super interesting. There's this whole idea of vibronic coupling that happens inside of atoms too. So, and molecules rather, not just atoms. So they have to be atoms that are stuck in a molecule can have these 6 different modes of vibronic coupling that can occur in types of materials. So these are other vibrational interactions that can influence materials and how they interact. Again, these first 8 bound eigenstates in the wavelengths of a particle in a well, potential well. Spatiotemporal optical vortices are super interesting that came up. And basically, you can create pulses which could potentially transfer information, accelerate particles, or perform spectroscopy by using these metamaterials in the circular concentric rings and pulsing them. This was theorized in, I think, 2016. I think last year, or 2021 maybe, they did it. They actually pulled this off in the laboratory, but you can create basically donut pulses or toroidally polarized light. And this might be what UFOs are creating around their craft to fly or accelerate, particles, for example. There's this mass energy equivalence, which very simply stated by Einstein, E equals mc squared. But if you solve for mass, it just says that mass is energy divided by the square of the speed of light. So therefore, we should be able to create mass if we have enough energy in the right form. In the right form, it has to be traveling in a circle, though, because the c squared is the speed of light squared. And that means it's looping around it itself. So you have to have energy that's trapped or spinning in a circle. And this came up recently. This phonon-nauraton. This came up actually this morning. I was researching stuff. If you combine a photon, a phonon, and an exciton, you get this other crazy particle, quasi particles that they're inventing and now creating, and created colorful names for these. But I had this idea that if you took trapped light in a structure similar to a cymbal and then vibrated it with the symbol's frequency, that you could create a phononaton, because it's elusive. It's theorized, but no one's ever actually created one of these phonoritons. And I thought that this might be a way you could actually do it. It'd be interesting to test the gravitational properties of this. And also test the gravitational properties of what happens if we trap light in a circle and get tons of it spinning, and what effect that will have on gravity. I'd like to, Mark and me are going to work on setting up a very hypersensitive balance so that we can do Cavendish experiment. And then once we get Cavendish experiment working, we're going to start, experimenting with, high powered light and see if that has any effect on gravity itself. And that's where I'm currently at with how I think we should go with how UFOs fly and how they actually work. I think that, space-time is emergent and it's woven through the fabric of quantum entanglement. And that, all the laws of relativity are emergent from this deeper physics of quantum entanglement, that everything's really connected everywhere all at once in this weird way. And that if you can create enough light, this ER equals EPR thing might be able to pump enough light into another part of the universe, or somehow get these two states to be entangled. Therefore, you could create a wormhole between them. That you basically create enough light, a light channel that's strong enough between these 2 points in space, then you've essentially created a wormhole. And this was in 1935. Albert Einstein and Nathan Rosen published this paper, which demonstrated the principle of this, that the region containing the curvature singularity. And again, it's like as David mentioned in the last podcast, it's all about the geometry of that opening, that throat. It's all about the geometry of the throat. It doesn't matter what's on the mouth or the other end. It just matters how do you produce that throat and create that wormhole throat. And could it be that if you put enough coherent light between objects, that you can create a wormhole using this structure of light itself, or quantum entangled light? You have to trap light, vibrate it, and squeeze it. And if you can do that with the squeezing and the states, you might be able to get some interesting physics out of it. Of course, it's beyond me, and I think I've exhausted everything I can on. Maybe in another 10 years, but this is where I'm at with how I think they work. And what I want to try for the future is experiments that involve, setting up these super sensitive balances that can measure gravity very minutely, or these maybe some of these. I'd like to set the thing that the DoD had in that hypersensitive needle that they were using to detect gravity in that recent. I forget where that was. That was a really cool thing. But yeah, experiment like that where we could produce stuff and then test its effect on gravity. I think that if you get enough of these quantum entangled particles and that you can squeeze their locality, you can get them to maybe tunnel through space-time in a wormhole, or maybe create just a brief wormhole around the craft that you could like Alcubierre drive. And this can be done through light pumped metamaterials. Or I don't know. That's the conclusion end of my presentation of a lot of the technologies that I've studied and where I'm at right now. And I'm happy to take questions and talk to people because I'm kind of over the monologue at this point.
Well, Jeremy, you're all set. Look at that. So many slides, man. So many slides. Let me do this. I want to put this thing on. You know what, Jeremy? Let me stop your screen share, sir. Okay. Oops. Sorry about that. Sorry. Let me put this thing on gallery view. Everyone, please give an enormous applause to Mr. Jeremy Reese. Jeremy, that is a wonderful, incredibly in-depth analysis. I mean, I'm sure everyone here knows Jeremy. This is why he's famous. This analysis and synthesis, being able to go deep and go through a ton of different concepts. And Jeremy, this is just par excellence, sir. So thank you. Thank you so much.
I wish I had a little more time because some of the slides were out of order, and then some of the stuff I could have put it together a little better at the end there. I was really crunching to get this all together and try and put that whole thing in. Again, I posted the link to the PowerPoint presentation in the chat, so everyone can go and check out the links, and if they want to look up sources for anything, if I've forgotten anything, they can let me know.
Now, I'm not sure if we're going to have time to do questions because we've only got about 4 minutes until Mark Sokol is ready to come on. So that I'm not sure about. I did want to mention something. Again, today is our last conference. This is something that we may revisit in the future, right? We just want to we want to give this a rest, I guess. You know, again, this has been the Woodstock of anti-gravity. All of us together have accomplished some really, really amazing things over the last 2 years. It's been a breakthrough. You know, I mean, if I could ramble for just a moment, the thing that when Mark came to me, the thing that kind of caught me about it was this idea of it was during the pandemic, right? And we were all just getting used to using Zoom. And it was like, well, wait a minute, all of these people have Zoom. And so for the first time, we could get everyone together, right? And, you know, it took a while, you know, but I mean, it's for this community, for the alt propulsion community, this is a giant, tremendous first. And it's something a physical conference could have never done. And it's not the achievement of any one person. It's the achievement of all of us working together, right? I mean, we've had, you know, well over 100 presenters and hundreds, if not thousands, of people speaking. You know, we have 75 participants on the call today. I mean, it's been a community effort and a community victory. So, and the reason I led with that was before we go to Mark Sokol, I did want to mention a couple of things. Dr. Paul LaViolette, who presented here, passed away, I believe, last week. And so I just wanted to mention that, and maybe we could just take a moment to kind of reflect on his contributions. He wrote a number of books, a number of papers. I read those when I was a kid. I'm sure you guys all have as well. He was incredibly well known, and he spoke, you know, he spoke in the media many times. He published a lot. He spoke at lots of different conferences, as well. A few of the other folks that we've lost. Mark McCandlish, as you may recall, I believe we lost him in 2021 in the spring, if I remember correctly. Amy Eskridge, who never presented here at the conference, but Amy was close to a lot of the people here. She unfortunately passed earlier in the year. And Paul Murad, who was a dear friend and a mentor of mine, as well as many of the other people in this conference, he passed as well. So again, you know, if we could just take a moment to kind of reflect on some of the folks that we've lost, it's unfortunate, but again, this community has been in existence for 70 years, and it has people of all different age groups in it. And so that's an unfortunate reality, you know. And I guess all we can do is kind of remember them, remember what they contributed, and try and keep their dream alive and help educate others about what they learned. So on that note, let me go to Mr. Mark Sokol and see if he is ready. I will ask him to unmute. And again, Jeremy, I can't thank you enough, man.
Yes,
that presentation
Tim, I am ready. Let me turn on the volume on this laptop here. Can you hear me?
Yeah. Now, Mark, are you gonna want me to pin screens?
Yeah, so there's two screens to pin. One is Mark Sokol and the other is slow-mo camera. Those are two different views of the experiment that we have going on today. For those in the audience, this is something we only discovered recently. When Tim is pinning these views, it doesn't automatically show up on your screen. So it's all dependent on the settings you have at home, whether you're going to see both those views simultaneously.
Yeah, and Mark, if I could jump in, and this is something Mark mentioned to me, everybody here, you guys will have to do this yourselves. If you look up slow-mo camera, you can find that and pin that view. It's SLO-MO, right? There's no W in it. Or Mark Sokol, or both. And I'm recording this with both of them side by side. So you will see them pinned side by side in the recording. But if you want to see it live that way, you're going to have to view one or the other.
Perfect. Yes. Another person that passed, who I just found out about recently, hasn't presented on the conference, but her husband has. This is Susan Alzafan, David's wife, recently passed as well. And condolences to David on his loss. But it just strikes home the importance of having this conference and, you know, what we've achieved here. We got pretty much all of the big names in alt propulsion, and we put them all together. And me and Tim have been talking about whether we should end the conference on a high note or continue dredging on. And one thing that came to mind was Jerry Seinfeld and his comedy show back in the 80s and 90s. He ended it after just a couple seasons because he ran out of material, and it's been memorable ever since. End at a high note, people remember it well, and we'd rather do that than to continue on and just pull in whatever presenter is available, you know, and lose in quality. The experiments here at the Falcon Space Labs are going to continue. We are going to continue doing live streams both on YouTube with Jeremy Reese and with Bernie's channel on an ad hoc basis. We may use the email list to put out emails for when we have live experiments. But again, a live experiment is very timid. It's dependent on a lot of things. Things go wrong. It's not easy to put together live experiments. Actually, the experiment that we're working on now, we've been working on it for 7 hours right now, preparing it. So this is the latest version of the Podkleitnov gravity impulse experiment. Now, I know you guys have watched a couple of variations of this earlier, and we had leaks and stuff. So let me show you the latest updates of what we've done, what we've learned working with this experiment, and what we're doing in order to perfect it. So we have an acrylic tube and a large Helmholtz coil. It's powered by that hybrid battery, nickel metal hydride battery on the bottom. One addition that we've added is the styrofoam over here, which is going to insulate the liquid nitrogen a little bit better, hopefully. Also, the opening where the copper tube enters into the vacuum chamber. That was widened from 3/4 of an inch to 2 inches. It's only a half-inch pipe. So that gives us a 3/4 inch ring of the special epoxy that we're using to decrease the tension on the acrylic, and hopefully it won't crack in this experimental setup. Another thing that we've added, which is very important, we put a conditioning coil inside the vacuum chamber. So that means that there's an extra wire coming out over here on the end. And that coil is going to condition to quantum lock the superconductor as it's going into its superconducting state. And that was critical to the experiment. It is in the, it's set up right now in the same phase, in the same magnetic orientation as the Helmholtz. So what we're going to be doing is, as we're making the superconductor cryogenic, we're going to be powering that coil. But as soon as we're confident that it quantum locked to that state, we're going to be powering down that inner coil because it will no longer be necessary, and turning on the Helmholtz for the firing. Another reason for doing that is because the Marx gen, which is going to be impulsing that superconductor, will likely short out to the power supply for the coil, and we won't get any spark going in the right direction. So we need all that energy going through the chamber versus coming out through these wires that are powering that inner coil. The inner coil is surrounded by a little piece of insulating foam just to mount it properly. Now, as for the gas that's inside the chamber, it is kind of like a vacuum. It's not a pure, perfect vacuum. Nobody's ever achieved perfect vacuum, but based off of Tony Robertson's suggestion, we did include a little bit of helium in the chamber. So what we've done is we've pulled the vacuum off the air. We've backfilled it with an inert gas with argon. Then we pulled a fresh vacuum, backfilled it with helium, pulled a fresh vacuum again, and backfilled it with helium, and then pulled a fresh vacuum again. And that is where we're at right now. The gauge is right around negative 29.5. I guess that's millimeters of mercury. So another addition that we've added, and this is the first time we've done it. On the grounding end, there is a rod going through, a thick copper rod. So there won't be any ionizing happening on the copper end, on the grounding end, which we've seen in the past. Also, our grounding puck, I don't know if anyone has noticed this in the past, but it is made out of solid silver, and there is a piece of graphite stuck in there as well. Graphite, of course, is a material that has a very high electron drift velocity. So the idea being, add that in and see if it adds anything to the effect. On that goes to a threaded rod on the outside, which is connected to a thick grounding ribbon, which goes to ground, which is also attached to our Marx bank over there. Another thing that we've added, and this is really cool, this is something I was excited about for a while. This is a double laser. These are line lasers, and I don't know how well it shows up on the camera, but those are red lasers, lines that are going to a white piece of paper, basically. And what that will do is, if there is a deformation in space-time, we're going to see it in the high-speed camera looking at that laser light. Now, you're able to see it on the slow-mo camera view right now that I turned on that laser view. So hopefully we'll be able to see something on that. And of course, we also have the hanging lead weights that will be there in case there's any movement as well. So the next thing that we're going to have to do, I'm going to turn this off so that we don't lose the batteries. Everything on this device this time around is going to be battery powered, including the power for the switches, because every time we've had any power supply or anything attached to this thing, they blew up. We have several dead power supplies that were attached that were running a switch. All they were doing is running a switch to connect the battery to the Helmholtz, and all defunct. So we have 2 batteries on the floor for the inner coil. We're using nickel metal hydrate, and for the switch to turn on the Helmholtz, we're using a small lead acid. So the first thing we're going to do is pour some liquid nitrogen and try to get this thing going cryogenic and power up the inner coil. And Tom, you want to give me a hand with this? Yeah. Okay. Yeah. Very good. The guys at the store already know me. I'm the superconductor guy. I think I'm the only one who buys liquid nitrogen for them from for playing around with superconductors. Okay, here we go. You can bring the laptop over. You can show everyone the excitement. Oh, another thing, if anyone comes down to the lab and helps out, we're running a giveaway, free Falcon Space t-shirts. A guy showed up earlier today, a programmer was going to help us with that replication of Mike Gamble's gyroscope machine, and he got a free t-shirt. Tim, I know you want a free t-shirt. No? You look too official in the button down. I think we're ready to power up that.
Yeah, I'm, you know, Mark, I'm just excited. I'm really excited about I'm really excited that you guys were able to get the vacuum leak repaired. You're pouring it in, it looks great. Everything looks really smooth. That's wonderful, man.
Okay, we're gonna power up this inner coil right now. It is powered up. There's some ice forming on the inside there. Okay. Hope we don't lose any vacuum. That's making noise.
Cracking a little bit. Okay. It's not the acrylic. Vacuum's holding.
The vacuum's holding, okay. We are seeing some condensation buildup, but it's not as bad as it was in the previous shots.
We're putting a lot in there too.
Yeah, we might need a bit more this time because we have that coil there, which is a source of heat in a spot where we really don't want there to be heat. It's bubbling big time.
Bubbles.
We might be losing some of our foam. It seems to be holding pretty well. It didn't crack, right? The vacuum's still good.
Vacuum's good.
Okay.
Acrylic is good.
Tim was begging me to test this before. I'm like, Tim, if it breaks, we might only get one shot at it. And I don't want to do that off air. Well, if APEC's going to go out with a bang, maybe this is the bang. Crack.
No.
Just shifting a little bit.
Yeah. Vacuum's holding.
Vacuum's holding. That's what counts. There's definitely lots of liquid nitrogen in there.
Oh yeah.
So we got like a 110 turn coil. I think it's pulling around 15 amps right now, or 13 amps, 18.5 gauge. So it might start getting warm. Okay, once you put this back and go get the high-speed camera ready for firing. Tom's gonna be over on the other computer getting ready for getting set. We're gonna set it on auto trigger. Oh, sorry guys, can't see me. We're gonna set the high-speed camera on auto trigger. So you won't have to manually be there pushing buttons. Oh, wow. It's bubbling away. Okay, I powered down the small coil. Put a little bit more liquid nitrogen in there just for good luck. Now with the inner coil powered down, we're gonna have to remove the leads for it, because those leads are literally direct lines that would allow the Marks bank to short out to the wrong spot, which we don't want. Tom, are you ready yet? Yes. All right, Tom is ready, so I'm just gonna pour a tiny bit more. And don't forget the lasers. Oh, okay, damn. If I turn the lasers on, I might trigger it. No, I didn't turn the water trigger on yet. All right, but everything else is set. What do you have on the frame per second set to? What FPS are we at? We have 1,000. No, it needs to be much higher than that. Do it at 33? Sorry, 10,000, I'm sorry. Can you do it at 33 or top speed? 38 is top. 38 then. Okay, are you ready? Yeah. Okay, Tom just gave me the go ahead. We're ready. So instead of staring at me, I'm gonna point it at this. Now, what is gonna happen from past experience, when it fires, we're probably gonna lose the Wi-Fi signal. Okay, we are slowly charging up. Okay, it's gonna fire any second now. Caught it? Which sign are you on now? Oh, so then it didn't catch it. Increase the sensitivity. Sensitivity. What? I don't know, down to 5%. Ready? Yeah, I guess. Okay, charging up. Got to increase the sensitivity then. You want to trigger it manually? Yeah, go ahead, trigger manually. Come on. Are you ready? Okay. Doing it again.
I think he may be hitting the trigger button after it sparks, though.
Yeah, but it saves stuff that happened beforehand too.
Oh, okay. Okay, I got you.
Tom, where's the trigger set point? Is it after? Is it in the middle or end? Good. Okay, we're going again. That was a powerful one. Okay, let's keep on going. Okay, charging up. I just realized that Helmholtz wasn't turned on. Now it's on. Okay, we're doing one more. How many more signs do we have? Okay. So, okay. The Helmholtz was not turned on for those previous ones, so it wasn't done right. These last two are going to be correct. Okay, slowly charging up. You got that?
And Mark, Jared was asking if you could lower your arm is actually right in front of it. If you could lower your arm just a bit.
Oh, I couldn't because the first of all, if I put the laptop on top of a high voltage, it loses signal completely. Now I just had to switch the current in order to control it thing. So we got 10 shots of this thing right now, and I think what we got to do is go over to the slow-mo camera computer, and we're going to do the replay right now and see what we got. So without further ado, let's move over there.
Now, so one of the things that I should mention also, Mark, is that I have been pestering Mark. Mark has a Facebook channel. And again, I'm going to give you guys links to all of this. I'll put those in an email. I will send those out, and they'll also be on the website. He has links to all of this stuff. We're going to have this on his Twitter channel, which I've been pestering him to update regularly, as well as Facebook. And so you can follow his continuing progress here. The Falcon Space Team is doing several different projects. Pogklanoff is one of them. Alzafon, as most of you guys know, that's another project they've been working on. They have several of these, and these are going to progress over time. They're testing, building, and retesting. So I just want everybody to be aware that he is going to continue putting up information as they create it, right? And this is development over time. It's a wonderful thing.
Yeah, all of these are, works in progress. It's not like this is the end of Pogklanov, although at this point I am confident that this will withstand a lightning strike, which is what we're trying to get with the NTS experimentation. They have a lab where they have a 3 million volt Marx generator capable of like 20,000 amps or something like that. I think at this point, the setup is good enough for that. There's no leaks in it at this point. It went cryogenic. There's no leaks. I believe we got quantum locking inside the superconductor. So all is good on that front. Now, here, so we have 10 different shots to look at here. We'll start with number 10. Now, there's about 3,000 frames in each one. And hopefully we're going to find, oh, there's something there. Is that, no, that's the 60 hertz of the, hopefully we'll see something. Is there an image search change area? We need to drop that down to 1%. Search step 1. See if I can play speed and options. So basically we're playing back sine 10 right now. Hopefully we got it. This all happened within this was less than a second for each one. Do you see anything there?
No, no, no.
You very dimly see the laser light.
Should light up with the flash on.
Yep. The flash at this frame rate, 38,000 frames per second, is only going to be about just a couple of images, if it was even captured in this one. Oh, I haven't seen anything yet. Here, Tom, you want to? You can do the search for all that. On other fronts, we are going to continue the work here at the lab. I reached out to MUFON, the Mutual UFO Network, and got their field investigator manual to investigate UFO sightings in the area. And I'm going to be joining their class to become one of their UFO investigators. And I told them about the lab, and they're very interested in joining efforts, and maybe we'll have some people from MUFON affiliates who've volunteered their time to be a MUFON investigator. I think that the best kind of investigation is the kind of work we're doing here at the lab, because that's true investigation. Rather than looking at lights at the sky, we're trying to make lights in the lab. Tom, you found anything yet?
No.
Yeah, we're looking through thousands of images right now to try to pinpoint the ones that actually have the light spark through it. This is a very low energy test. It's probably on the order of less than 100 joules of total released energy coming out of that Marks bank. So that is something to note. If you click on play each image,
What is that?
right on top of FPS, up, down, down. Yeah. That'll give you actually every single image, but it takes a lot longer to watch. To rewatch all of this footage will take probably close to an hour. So we could start a Q&A while we're doing it or something, or have some sort of open discussion. And yeah, if we find something, we can.
Well, so what I'm going to do is let me allow participants to unmute themselves then. Do you want to we could just do open discussion. Mark, do you want to take open discussion? And you just.
Yeah, sure. Any questions about the current setup or recommendations or such? Open to hear it. Right now, we're Tom over here is looking over the footage, and you guys can see his screen on the slow-mo camera view, and hopefully we'll capture those few images of
it looked like it went right by on the last city that he was looking at.
Oh, you think
here?
You think you saw it?
I saw a flash, but it just went by really quick. But I was watching the slow-mo camera the whole time, and I didn't see it change at all. I mean, I didn't see what was when like it fired. I never even saw a flash on it.
Yeah, you wouldn't, because the refresh time is so slow. These at 38,000 frames per second, you probably only get one image of it firing. Most of the images you'd see are just like afterglow of the ionized air glowing from the high energy.
The trigger was at like 80 to 90%. So like right about now is where it should be showing some.
I think well, let me have everybody first. Let's give Mark, I'm not going to change the screen, but let's have everybody give Mark an enormous applause for this presentation.
Thank you very much.
Mark, you've been working on this.
And Tom too.
Well, and Tom too, but they have been working on this thing diligently for months now. It's a very professional setup. I mean, a high-speed camera, the weight setup, the Poglanov device, testing, retesting, fixing pressure leaks, getting special materials. So, Mark, it's a wonderful achievement. Even if you end up with a negative result, it's a wonderful achievement. And I believe as you guys continue to test and retest, you'll start to get results. So, and again, that's stuff that you're just going to continue to put up over time, hopefully, and people can kind of track your progress.
Thank you for that. Yeah. And again, if anyone wants to come down to the lab and help out or work on some experiment they've had, we've had many people here in this Zoom call right now who've come down here in person. Wayne Ojala flew in from Canada. I personally have flown out to many different labs to collaborate. I know Drew in sunny Florida has been asking me to come down there. Maybe we'll do that one day. But Jared is in talks. Aiden Schaefer's been here a couple of times. Charles Crawford has been here as well, helped out, and we met Michael Boyd on the road, and of course our Shirley Jeremy Reese has been down here numerous times. Jeremiah Pop, who I haven't heard from in a while, he's been down here a couple of times as well, and we've been making this a group effort of having everyone working together on these experiments and pushing things forward. See anything yet? Any other questions? You guys can unmute yourself. Oh, Brian Ritter, go ahead.
Hey guys, I've been following on and off these developments for the last 20 years. I also follow geopolitics, and I have more of a layman's question. I figure since there was an impasse, I could ask you guys, could you gauge how far along we are in the disclosure and mass acceptance of these radical technologies that would not only disrupt a lot of science, but everyday life and certainly economics when you're dealing with a petrodollar right now? Energy generation technologies like this would be extremely disruptive. So it is something that I would love to see in my lifetime, but you guys probably have a better engaged on my mind as to how it's going.
So you're asking how far away are we from public acceptance of the technology?
Yes, and out of that, eventually, all the implementations of it.
It depends who's part of this public. Some may say 70 years ago, but if you mean the world in general, I have no idea, because even if we were to make a major breakthrough tomorrow or today, until we build an actual craft can be several years.
I could just add one thing to that. If you follow along with the UAP disclosure stuff going on in the United States Congress, one of the latest developments is that they're trying really hard to give whistleblower protections so that the people who have been working not just for government agencies, but for the private corporations who have these, legally binding contracts where if they come out and disclose what their companies have been working on, like reverse engineering the crafts that they are in possession of, then these people would go to jail or be silenced somehow legally. So it looks like Congress has actually got some traction with this. And if you believe the really big names out there, it sounds like this is something that's actually going to happen in the very, very short term, if not already. Like the document's already written, the votes for it are already there. I don't know whether or not they've actually taken the vote on it yet, but it sounds like they're going to, and it's going to pass like within the next few months, if not this month. So as far as this rate of disclosure goes for the technologies, as soon as they come out and say, we've been reverse engineering downed UFOs, that should really open the floodgates with all of the people who are going to be free to come forward to say, yeah, and I was one of the engineers, and this is what was going on with it. So as far as warp drives before we die, I got really high hopes.
Well, if I might add something, I think that we're about 24 months away from the US dollar not being the leading force behind world economics. And that opens an opportunity for the petrodollar to be disbanded for switches in energy generation, for petroleum to be taken out of the major role it plays right now in that area within a window of economic opportunity where it probably wouldn't completely disrupt world economics, because it would already be disruptive anyways.
Potentially, because the Saudi princes, the Saudi government, they have so much more oil reserves under their feet that they still haven't sold yet. A lot of folks say they still have hundreds of years of oil still there, which means that's an asset that I'm sure they would love to protect, which means that they rely heavily on the petrodollar as well. And considering the US sells them weapons that are enough to take over countries, I can't imagine that the petrodollar is going to die overnight. If it does happen, the slow grind, in my mind, means there's going to be a really strong fight that would involve lots of bloodshed and war.
Guys, even if they stopped using gasoline tomorrow to move cars and trucks, the petrodollar isn't going anywhere. The companies that crack oil, the producing fuel is an annoyance to them. There's more money in plastic, so they're going to be cranking out oil for the next 100 years to make plastic, trash bags. So, if they cracked fusion tomorrow, or we get warp drive that drives, propulsion systems or whatever, it's not going to change the big boy game.
I believe plastics, though, and other commercial uses of petroleum only account for about 4% of the world's consumption. So if we had something that replaced energy generation and transportation and all that, that level of disruption of 96% removal, that I don't care if you start quadrupling your plastic production, it still is going to mean the death of many economies.
Yeah, but it's mainly natural gas in America that we're running on.
So Wayne is asking if he can, Wayne is asking if he can do his presentation on Alzaphon videos now. And that would be up to you whenever you're ready.
Sure. You know what? This is going to take a while to go through all the footage.
Okay,
so
let me go to
start, and then maybe we'll come back to this, when we get those images. And
okay, so I'm going to remove the pin there. I will remove both pins. Let me go to Wayne.
Tim, can I just jump in and give a 2-minute update? Because I'm gonna pop it off to go get some ice cream.
Sure, yeah, go for it.
I don't mean to mess up anybody's night, but we've got some pretty big things going on here in sunny Florida. I just thought I'd ping in. The biggest thing is we got funding. So we're shutting down the home lab, and we're opening up a full-blown operation commercial lab. We're going to have a research division. We're going to have an engineering division, and of course our business division. And we hope to be in the sky with our prototype satellite in 24 months. Prototype satellite's going to be something like a U3, maybe a U6, and it's going to have between 1 and 2 newtons of massless or propellantless propulsion. So we're really stoked about that here. And the vapor deposition chamber system is fully operational, and learning a lot about depositing materials. So
Awesome.
If anybody plans on visiting sunny Florida, they might want to do it sooner rather than later, because the new shop is not going to be open to the
Well, and Drew,
public.
maybe you can drop your email or drop some contact info into chat, and that way people can use that.
Okay.
Okay. So yeah.
Thanks.
Well, so let me go to Wayne now. Wayne did some Alzafon testing. Wayne, go for it, sir.
Yeah. Hi. Can you hear me?
Mm-hmm. Yeah, and if you want to do a screen share, you can do the videos that way.
Actually, I was wondering if you might be able to do that. I just don't want to. I sent you a link in WhatsApp there.
Yeah. Well, let me see. Yeah, let me find that.
Okay.
Oops. And I'm not sure. Oh, that's on YouTube. Hang on.
I just wanted to say, Jeremy's presentation, I only caught some of it, but it was great. And as soon as I turned it on, it's like he's talking about lasers. I'm like, that's exactly right. And there's actually research that's been done, published papers and stuff that have proven that light and electromagnetic energy does actually create something like a gravity field with a Cavendish type setup. And there's a few papers that go into that and prove it.
Okay, well, so Wayne, let me do this. So I've got you pinned, so it should show you. What I'm going to do now is share screen. And hey, hang on just a sec. Sorry.
Yeah. So let me just say. So this was first of all, this is a couple things. So the reason Mark and we kind of got like working together. It was around the Alzafon experiment that kind of brought us together. Just for people who don't know much about me or kind of the background. So for me going there and visiting and working on his setup was an interesting experience. And so there's actually, I had probably a couple hours of footage, and I had to sort of chop it up quite a bit, and it's a big job. So what you're loading up there is sort of an introduction, just kind of like an overview.
Yeah.
For some of the people in the audience, it might be kind of redundant, but I don't know how many newer viewers there are here today, so they might find it helpful. So it is it's like an introduction, just kind of an overview of the setup and and I just kind of like introduced the process, like of how so I tested a number of different samples, but they won't be shown in this video, like all the different samples. I'm still editing those videos and putting them up on my channel. So I've done a couple so far. So I'll continue to put them up over the next few days as I'm able to keep editing.
Okay. Do you want me to press play now, Wayne, or?
Yeah, sure. Go ahead.
Okay.
Looks like you're missing audio.
Sorry about that. Give me just a sec. Where's my window at? Sorry, my window disappeared.
Drew in sunny Florida. That sounds pretty interesting. Do you have a website, or are you new here, or have you been on APEC before?
Yeah, I've been popping on and off this thing for a while. And no, we don't have a website. No, there's nothing published. Although our patent is now issued, so you can go out there and read that. It's 87 pages of amazing. But if you get through it, let me know, because we might want to hire you, because we haven't found anybody yet that can read it aside from the guys who wrote it. So, I don't know exactly how to answer the question, but somebody asked if this is some kind of pulp of the patent.
Yeah.
Just Google my name, and it'll pop up for under patents.
Sorry guys, let me share this again, and I'm going to max out the volume there.
And this amplifier got
What kind of power?
259 hours on it right now.
What kind of power level are you putting in there right now?
Very low power. But you got to be very careful not to destroy this thing, because it can't take more than 1 watt. Plus 30 dBm. Right now we're at negative 16. We can go up in the power. Now we're pretty strong.
977, couple milligrams.
Here, these are like the fine-tune adjustments.
Frequency adjust?
No, this is magnetic field adjust. You see how the Gauss is changing over there?
Gotcha.
So what we're doing is we're testing a little aluminum pellet.
It should never go above
Pure
plus
aluminum.
30 dBm, but this is here to protect it. Hopefully it works well.
Okay.
I need to give him a ride, okay?
Small changes happening here on the milligram level. There's our frequency 9.425 gigahertz. So I'll be playing with this a little bit here and see if I can make something happen there. Trying to get it up to 3363 as per the calculated more frequency. The RF is currently off. So what I'm doing is just watching this weight here. The little aluminum pellet is inside this hole here, suspended on the fishing line. It's very pure aluminum. So I'm just looking for any weight changes from just the magnetic field, and this would be a very parallel field here, because this is an electromagnet for EPR machines, electron paramagnetic resonance machines, for doing spectroscopy. So this is the Faraday cage here that they built. And in here is the experimental machine. This is the electromagnet. It weighs a friggin' ton. And down here is this is the microwave waveguide here, and some components. This is a circulator. This is an isolator to protect the equipment. And down there you can see the hole, and the aluminum pellet is just inside there. And then this fishing line goes up to the bottom of this analytical balance up top here, and which goes into the computer. So this might be worth noting. Here. What I've done is I've located, it looks like the resonant frequency of the hole in right here, the resonant frequency right here in this hole, like where the waves tend to, I guess there must be some sort of node there, because when I put a metal object in there, there's a slight decrease in the attenuation of the signal generator. So that tells me that that's where the wave is, there must be a node there, so the power is being, it's not being lost there. So if I move this frequency a little bit, okay, I'm going to remove the little piece of aluminum out of the hole, and I think that little little dash there will meet at this line with a diamond, meaning that there's a change in the reflected power. Yeah, so I removed the little aluminum piece of aluminum out of the hole.
This is something
that
little
node there has
noted
appeared.
as being important that we find
See, I
that
took it out of the hole there.
there on the screen.
I find where this is here. If I line that up, you see how that diamond appears? So there's a change in the reflected power. 9.4233 gigahertz. So I'll also note the electromagnet. The electromagnet is off. Basically, that's pretty much off. And so this is what the situation is. Here. So what I'll do is dial up the electromagnet. I'll put the aluminum rod, the aluminum pellet back in there, and then dial up the electromagnet. And see if there's any change on this peak here. Okay, so after inserting the pellet back into the hole, this spike has now gone up higher, indicating a change in reflected power. So now we'll turn the electromagnet up, and that's speed 9.4233 gigahertz. So I'll try and find the resonant frequency. Magnetic probe is right on the surface of the electromagnet pole, so I'm just wondering if that's going to... This other meter shows about 3850, measured right by the sample there, and right on the pole. So there's a discrepancy here between what this meter is saying. The meter that's in there is saying 3355. This one is saying 38. That's a difference of 500 Gauss. So this is showing that measuring right on the pole, versus measuring right beside the sample there in the middle is approximately the same, give or take a couple of tens of Gauss. So it's pretty close. So it shows the field is quite uniform. The field is quite uniform across here. There's a little bit of variation. And I'm going to try this meter here, this Tesla meter, to see if I get something similar. About 3,900 Gauss on this meter, and the other meter is about the same, 3,800, 3,900. So I'm suspecting this Gauss meter here is way off. So this is what I've been going by. So I've been out by 500 Gauss. So that might explain why I'm so far. Maybe might explain why I'm having trouble seeing anything here. So I gotta turn this down, find the resonant frequency. 9.42 I believe is at just gotta double check my calculation. So I've been playing with these dials for a long time, trying to very carefully dial in the precise frequency and magnetic field necessary to see some kind of absorption here on this spike. So I'm using the same little pellet of aluminum in the hole there, but I'm not seeing any absorption here with magnetic field. So I think what's happening is it's just reflecting off the surface of the pellet because it is solid metal. So I might try a different sample, like a powder or a just chips, aluminum or copper or something else. I think what's happening is it's just reflecting off the surface of the pellet because it is solid metal. So I might try a different sample, like a powder or a just chips, aluminum or copper or something else. So these are the new samples I made. I made one like this with holmium, granulated holmium metal in it. And this is copper in here. I haven't tested the copper yet. All right, so back to, I made a little sample of aluminum, atomized aluminum powder. So that's in there right now, 0.9942 grams.
Hey, Tim?
Magnetic field at 3362.6. And I'm going to turn the microwave
Just
on.
for time's sake, you can probably stop it there. So the balance readings there are on the right side of the screen. So there's really not much happening here.
So that's, according to this meter, that's 3,400 Gauss, which is higher than what it should be. I'm just doing a little bit of a sweep. No significant change in the weight. It's pulsing at 83 Hertz, which is about 6 milliseconds. 6 millisecond on time. All right, I'm just going lower. Uh, 3265. No significant change on the weight. All right, 3,200 Gauss, so I've gone quite a bit lower. I'm going to go back up to the specified value. Three 362. All right, back to 3363. 2. Okay, I'm going to try a different sample. So that was aluminum powder. Ending at 0.989. We had a change of about 2 milligrams.
You can probably stop it there. I think that's.
Wonderful. Okay. Yeah, take it away, sir.
Yeah, so that's just kind of an introductory clip there. So I did try a few other samples like that, and just for thoroughness, I will put them up on my channel. But in summary, I didn't really see anything that got my attention as far as results with that. So yeah, there's a summary. So I have a few ideas on how maybe to do it differently that might get some results, and it kind of I see it relating a bit to what Jeremy was touching on there with the energy, trapped electromagnetic energy. So I think maybe putting the sample just outside the waveguide, and positioning it just in the right way would create a force, rather than putting it inside the resonant cavity there, because it's like there's symmetry, right? So the microwaves they're interacting with the sample in all different directions at the same time. So there's no asymmetry. So I don't think there'd be any force as a result. So those are my concluding thoughts, in summary on that. As far as, yeah. What?
Oh, and I was going to say, at some point, we're going to have to give you a giant applause. That video was awesome, Wayne. That was an awesome video. That was.
It seemed a little bit boring, but I'll admit that. But it's science is there's a lot of long hours staring at screens and data, and yeah, but I appreciate the sentiments there. Thanks.
Yeah, absolutely. Well, yeah. Was that everything, or did you have more? I didn't mean to interrupt you.
Well, I'm going to put more up on my channel over the next few days. So if people want to, follow up on it and stuff, they can. If they subscribe, hit the notification bell, and all that good stuff.
Yeah, and actually, Wayne, can you drop that? Just drop your channel, drop a link into chat. Yeah, and then I will put a blog up on the website too. I'll put a post up with all these channels and more information and stuff like that.
Okay, awesome. Yeah, it was like I spent actually a couple, like 2 or 3 hours there playing with dials and samples. And I have done, I've tried to do Alzophon experiments at home and stuff like that with more, I didn't have the level of equipment Mark has acquired. So that was important for me to be able to go there and play around with that and see, if there's going to be any difference, in terms of his setup and what I've played with. I will say that in my experiments, they're not technically not Alzophon experiments, but they are similar in that I'm trying to achieve I'm trying to achieve EPR, or dynamic nuclear orientation. And I did see small movements in some of the samples. And almost as if there's like a force being developed there, related to the magnetic field and the resonant frequency of based on the 28.025 gigahertz per Tesla relationship there. So I think there's something to that, but I don't think the way we had it set up there in the waveguide is gonna produce anything that we can observe. So yeah, that's about it.
Wonderful. Okay, well, Wayne, let me do this then. I want to put this in gallery mode. Everybody, please give Wayne an enormous applause. Please give Wayne an enormous applause. Thank you. And I see Gerald there in the corner. Maybe I could pester Gerald to do a demo. Gerald, do you think you're up for it today, or? Oh, you know what? Sorry.
Gerald, you gotta unmute yourself.
Oh, he doesn't have he doesn't have audio. No, he does have audio. Okay, for some reason it's not working. Okay, well, let me see. Maybe I could go back to, let me see if Mark is set, and if not, Bernie actually had something to share as well. But Bernie, let me see if Mark is. I would say Bernie, why don't you take it away?
Yeah, for Matthew Rife, Matthew, if you're ready to do a quick one there.
Yeah, 100%.
Awesome.
There we go. I don't know. Am I on screen?
You are.
Okay, awesome. Yeah, it wasn't showing up. So a lot of you guys may know of Royal Rife, who actually works with resonant frequency oscillation. And, you know, over the years, it's been known to be a pseudoscience. And, you know, so I'm Matthew Rife, and I kind of stepped out with technology, and I'm forming back to be able to bring Uncle Roy back to where he should be at. Because there's a lot of this stuff that's coming about, just like with astronauts, you know, whenever they leave the Earth, they have all kinds of sicknesses and everything whenever they come back in the 60s. And now they're using PEMF, pulse electromagnetic frequencies. So just on the aspect of just science, I'm going to start off with that because every cell has its own signature of electromagnetism field. So a movement of electrons about an atom's nucleus generates specific ionic interactions and energy emissions, thereby resulting in an ion-based electromagnetic signature pattern of an atom. The electromagnetic signature patterns of multiple atoms are compounded in molecular electromagnetic signature patterns when the multiple atoms combine to form molecules. Similarly, the electromagnetic signature patterns of multiple molecules are compounded in cellular electromagnetic signature patterns of multiple molecules to combine and form cells. We all see where this is going. This is your human body that's made up. So, you know, just standing on every bit of physics and everything else, whenever you come about this, you can see that everything that Roy was talking about was true. So he used a lot of different tools that we don't have access to this day, as in we don't have the same quality of electrical components as in, you know, vacuum tubes of that nature. I've looked for them. I've tried to recreate it. There's no way I could possibly recreate anything unless I had components like he did. So I sat down and I started designing different electromagnetic frequency wave field generators with copper coils. So that's what I have here. And these are the coils that I generate now. Let's see, where's my camera at? And so you'll notice that the coils are unlike a lot of other ones, and that's because they actually have the Fibonacci sequence that's into the winding, just like whenever Jeremy was talking about the cochlea. Now the cochlea will, you know, it'll filter out different frequencies. It makes you hear like more pure tones. This right here, whenever people listen to sound healing, that makes sense to me because then you have electrical synapses that runs through your brain after it goes into your ear and it hits the base of your skull and it goes through processing. Now, EMFs, they are not sounds. They do not have to have atmosphere to be able to travel. There's no compression, decompression, and it will travel throughout your muscle systems and through your body. Now, what I have found, like take 95 hertz, for example, you can take one of my smaller coils and you can run 95 hertz on EMF. And any woman that has like period cramps, abdominal pain of that nature, 95 hertz will oscillate this nerve that runs up your spinal column through your back, and a nerve can only feel one sensation at a time. So therefore, it's going to be stimulated through this. It's going to have an energy field running. It's actually going to have 95 hertz energy wave running through that nerve ending, and it stops the pain within the abdominal area. Now there's other hertz, everyone's a little bit different. So the abdomen area, I think there's 135 as well. And, you know, generally it's just one of those, there's three of them, I think. That works overall. 95 seems to be the most popular one. Now, I didn't stop at only one coil, and this kind of leads into a little bit of stuff from what Dave was talking about, and Jeremy, whenever we talk about, you know, anti-gravity and however you want to call it. I actually have two different coils that come with each set. And if you notice, it's a differential wire gauge. Your differential wire gauge, what it's going to do, it's going to dictate the size of the EM field that you're putting out. So the thicker wire, you're going to put out like a larger EM field, and then yep, right here. So it's throwing up different coils. Now, what this is going to do, if I know I'm getting this wrong, but it's Faraday effect, Faraday rotation, to where you got two EM fields passing by each other. You're going to create a third magnetic field. It's going to be a third the size, third the power. Now, that right there mathematically worked out within my different gauges of wire. Then it's 369 if you break it down, because it's 1, 2, 3 actually, then 369. But all of this, I don't think it's because of the differential within the wire gauge. I don't think it's actually doing Faraday rotation. I think it's doing more than that, because every field that passes by within that differential, it's creating another field. So I'm looking at things like what Dave was talking about, the connection between time and light, and how, you know, they connect and they're so sequential to each other. That electrostatic, what happens when you take electrostatic around something and you run one field one way faster than the speed of light and another field the other way, and you're creating that Faraday rotation within an electrostatic field, you're creating two EM fields that take you outside the boundary of gravity. So I think it was Weiss and some other guys, I forget their name, that just in 2017, they got the Nobel Prize for gravitational waves. And I've read through that, and there's a lot of things I completely disagree with, but there's a lot of things that I agree with too that are on par. So I'm working on stuff like that on the far end. I've worked on things like what Dave's talking about. It is very simple what he's saying, like for anybody to harness the stuff. And there's a reason that he showed the prism effect. There's a reason that my stanchion stands straight up, but a little bit inward, but not far. Because it, you know, these are wave and field generators, and they work. Like, so I've never had a bad review. I actually just opened up the doors to Rife Technology. You can find this at realrifetechnology.com. Opened up the door in July. There's been people to use this for health. Fibromyalgia has disappeared. Endometriosis has been helped out. There's been so many cases of people with cancer that I can't make any claims, but I can say it's like their cancer just got up and walked away. Now, I'm going within a couple of days to go pick up some medical stuff, medical records of this man who has had multiple heart attacks. And it's been so much that it's called myocarditis. So it's the heart and your heart, because but it's the heart attack that killed it. So 3 years, half of his heart.
Well, Matthew, I don't mean to interrupt, but these are medical claims. You're making medical
what I'm saying
claims.
is I cannot.
Is there a way that we could? I mean, this is a propulsion conference. Is there a way that we could avoid medical claims?
Yeah, we can do it.
Thank you, sir.
And, yeah, anything I find out, I'll post on my website first.
Yeah, well, and so you said that was rifetechnologies.com, right? So people can learn more about it there.
Yeah, and I have all kinds of peer-to-peer studies links that are up there to reference and everything else. So I understand. I'm sorry about that.
No worries.
But within that, I mean, we have to work within energy, and we have to work within frequency and resonant frequency. And that's one of the biggest things that I've picked up on, is that all of you are really connected to frequencies, and you're studying about energies and how these energies interact with other energies. I forget the waveform that was being spoke about earlier, but Schumann resonances. So whenever you take two Schumann resonances, then they kind of oppose each other. And yeah, that makes total sense. It's kind of like Wi-Fi in your house. If you're going to run two Wi-Fi routers and they're not in sync with each other, those signals are going to combat, and it's going to be able to create like a negative field for you to be able to pick up. So these are just a lot of different things I'm working on. I'm also working on agriculture, and it's a twist on electrostatic, to where I'm creating plasma generated, it's ionized jet propulsion kind of, but it's plasma generated fans, to where you can suck through nitrogen, and it splits a nitrogen molecule into nitrogen atoms, which is essentially fertilizer, the same way that lightning works within our atmosphere. And it's just a lot of different things that we're working on. And I have to say, it's an honor just to be invited on here to be able to talk about all this. I apologize for my lack of knowledge on a lot of things, but I've been enjoying every bit of the stream so far. And I just really like everything that I've heard so far within propulsion. I think that ionized jet propulsion is a quick and very soon coming way to be able to propel planes and everything here on Earth. I was looking at making a drone that had ionized jet propulsion, like 4 corners on it. I haven't worked it out because it is heavy. And we all know the physics of that, to where a lot of people are using the lifters out of aluminum foil and things. So, but hopefully it can come to that point. And that's about all I got. This was quick on me. I'm up here at my family's house, so I apologize for being so quick.
For sure. Thanks, Matthew. And we'll be doing another stream afterwards together, going further into the health and agricultural aspects of your technology following once APEC's done. And Gerald, did you get your microphone working there? If you want to answer quick questions, and Gerald will also be joining me and Matthew Rife on the episode afterwards.
Not sure if my mic's working. Can you hear me?
Loud and clear, brother.
Awesome. I gotta apologize to everybody. I didn't know this was the last APEC, so I didn't set up a demonstration, and for that I'm lacking. So that being said, I'll do a little show and tell of what I'm working on. I just had this. I obtained this actually just recently, and this is for a project that I'm working on for a demonstration in anti-gravitics, or alternative propulsion, as you were. I have to work on the fastening system inside this bell, but needless to say, what was shown on a previous video by another gentleman, I know this is going to be a big claim, but let's just say I'm going to be doing that with this bell. And there's a reason for that, because I want to show it in sort of a historical point of view at the same time as releasing that which I know and what I've obtained and gotten to at this point. And once that's done, which should be in the next week or two, it sucks that APEC is over. I have to say, Tim, Jeremy, Mark, everybody who put in, you guys have done an amazing job. All the interviews that you've done, this will definitely go down in history as legendary. So I apologize for not being part of that. We were trying to set up sort of a whole thing for me being on the conference, but I didn't have a computer set up at the time. And now that I'm at that point, it's just sad that APEC's over. But I do applaud every one of you that put it together, because you definitely deserve it. All of Mark's experiments, Tim's interviews, and well, Jeremy, he began this a long time ago. I've been watching Jeremy Reese since Alien Scientist back in 2012, so or 2011. But yeah, that's all I really got. I was not prepared to show much. I could show the very first coil I built and show the system that I'm operating on now, but it's basically just a show and tell. So other than that, this is me. I've been working on coils for the last 10 years, roughly. I've made over 150 different coils, from solenoids to starships to star panseas and other names that haven't even been brought out to the public, so to speak. All these different coils do different things, and they all have different purposes. Maybe in the future on Bernie's channel, I'll get to show a lot of those different aspects, like some of the experiments that I'm doing with food growth. And this again is another large claim, but it's been documented and videoed. I have been able to increase the growth in celery and in lettuce by 30%. It's 1/3 faster, and it tastes better. I can't say that it's more nutrient filled. That's something that has to be tested. But as it stands, through electromagnetics and the systems that I've built, These things work. They're for real. Growing food seems to be a little easier when you set up the system in a way that it's within the dirt. So that's all I really got for you. I just wanted to say thank you to Tim, Mark, Jeremy, everybody that put it together. And that's my little show and tell on me. Not much to show, not much to tell, but
Gerald, thank you, sir. Thank you. Look, you know what? Before we go further, let me put this thing on gallery view. Everyone, please give Mr. Matthew Reif, as well as Bernie and Gerald, a giant applause. And let me apologize to Matthew. The only reason I cut in on medical claims is YouTube, as many of you may know, YouTube is notoriously picky about that. They just flip out, and so that's something that we avoid completely, because you know they'll come back in a month or a year and you know say, oh, this violates this or that, we're taking it down.
Like
and
Jason Verbelli, they deleted his 2 accounts simply for the structured water, and he was a APEC guest before.
Yeah, it's unfortunate. It's unfortunate, and so that's just an area that we have to stay completely away from. You know, it's they do. I understand why, because I've seen stuff in the past that they've, you know, and it's like, but I think the problem is they've taken their moderation too far, you know, and so we just have to kind of work around it. But I do appreciate you bringing Matthew on, and if he's, I'm not sure if he's still here, but you know, I do want to.
He is. He's just probably dealing with his nephew and niece over at his brother's house.
And that's okay. Yeah, you know, and again, I didn't mean to cause trouble for him when he was discussing his coils. I was just trying to avoid future trouble with moderators. So.
Absolutely understandable, and thank you, Tim, for everything that you have done. I guess we're all a little shocked and heartbroken that it's ending, but it's a legendary 2 years plus that you've done this, and everything you've brought out, and the development of your Tim Ventura channel. Please tell me you are still doing that, because that is next level work that I think we all will benefit from.
Yeah, I'm still doing that right now. I'm focused mostly on catch up at work. So you know, but
fair enough.
Can we give Tim a huge hand, like the biggest hand ever, because of his awesomeness and all this?
well deserved. Well deserved.
Well, thank you. All I do is moderate. This is all APEC this is all your guys' stuff. All I do is play traffic cop. So
yeah, thanks, Tim. And I'm offering free peer-to-peer video conferencing, but there's no way we'll be able to replace you as an interviewer. But we'll do our best, I guess.
For all the Canadians in here, maybe we could start Canadian anti-gravity.
Well,
you can call it
Tim's inspiration over the years. You know,
I mean,
American,
you know, I mean, I guess if I could offer a suggestion, the place, you know, I mean, I think not every, but nearly every APEC has been streamed on Jeremy Reese channel. And then on top of that, Jeremy Reese has probably done 10 times more videos over that period of time. Some of those were interviews with people, others, were group discussions. So I would recommend everybody just stay tuned to Alien Scientists. And then I would also recommend that people just follow Falcon Space, right? And there is a Facebook chat, and I'll put links up to all of this. There's a Facebook chat. There is a Twitter that I've been getting on Mark to update. And then there's also, and this is on the APEC website in the contact page, there's a very active WhatsApp group. Mark moderates that. I think there are two of them. And anybody who has WhatsApp can join those and discuss. And so I would recommend everybody just, stay up on those. And this research is going to continue. I mean, it always has and it always will, right? But I think in terms of the conference, the biggest thing that we've run into is we've exhausted, we basically outpaced what the community is able to do. And, and so then the problem becomes, if we keep doing them over time, it will get very repetitive and the quality will drop and people will be like, what happened to this and that and the other thing. So it's better to just take a long break and then we can probably come back to things, in the future. And I'm not sure when that will be, but that's kind of the idea behind it. So.
Well, just let us know when we can buy our APEC reunion tour conference tickets, and I'm pretty sure you'll be sold.
You could always get Falcon Space t-shirts and hoodies if you come down to the lab, that is. And we do have an update now. We did have a bit of a problem with the camera before, but that problem has been fixed. And Tim, if you highlight the slow-mo, pin that computer right now, you can see we did get some images from the high-speed camera. Here's sign 1. This is it firing. This is the image after it fires. You can see sort of like a black void where that arc over happened. So also, interestingly, the arc over is happening mostly from the periphery around the superconductor. So that's where there is some, that's where the copper pipe is. So we might want to try shielding that for future experiment, just to shield the copper so that the superconductor is what's emitting the beam rather than it coming off of the copper. That's one thing that we noticed in this image. In this image, we're looking at a different frame rate, so we're getting more light coming through. Again, you're able to see the black spot where the beam used to be. I don't know if that's an aberration of the camera or if that's something that's physically there. The laser beam doesn't show any changes. I don't see any visible wiggle to the to any of these hanging lead weights. So for now, I would say Podklanov is busted. The Podklanov gravity impulse, it has not worked as of yet. We should try covering the copper pipe that's holding the superconductor, so we get the conduction directly in from the superconductor. And these kind of experiments are stuff that are ongoing in the lab. These are works in progress. So long as there's liquid nitrogen and there's interest, we're going to continue trying to get to the bottom of this and going. I definitely want to go to NTS for a high power run at this, and we have an RV with mobile internet hookup that will bring up to their facility in order to see it there. So this is sign 3, sign 4. The sign is these are the cuts out of the memory chip, high-speed memory chip that it gave us. Again, we see the high voltage is coming. It's arcing over from the copper to the silver. It's not coming directly off of the superconductor. So that may be a problem. Sign 5, we see it's slightly more powerful. When we give the Markspank more time to charge up, more joules get stored in it. It also depends on atmospheric conditions. It fires earlier at a lower voltage. We're talking about less power. That's why we're seeing differences in the spark between each firing. This one looks like a slightly weaker spark over here. And it's probably at a higher frame rate of images. You can see a little bit of an afterglow there. But here moving 12, 13, 14, 15, 16 images past the firing, and we are not seeing any visible movement. I mean, you guys are watching literally the same screen that I am. So if you see anything that I'm not commenting on, please make sure to talk about it, because you're literally seeing the same thing. Again, here's sign 1. This is the image right after it. You can see a little bit of the afterglow over there. The top glow is like an orange. That's probably more atmospheric. but then it goes into this bath of liquid nitrogen, and we're seeing a little bit more greenish color to it. That's when liquid nitrogen is getting energized. And the color inside of the chamber, this is that's the glow of helium getting charged up. And here we can go on to this one is probably at a different frame rate. So we're seeing everything much brighter. You can see what the actual setup looks like. But then again, we did not see any visible movement here. So far we're not seeing the kind of results that we would like. I do not want to call this busted as of yet until we try it at NTS with their megavolt Marks bank that can pump out megajoules of power. So yeah, that's it for now. That's what we're able to catch. And the device is still working. It did not spring a link this time, so it's solid. It's ready to go to the next stage of experimenting, and we will take it there.
I think. Oh yeah. I think if you
go ahead.
I think if you had more current going across the gap.
I agree.
And then also if you move the lead weights closer, get them as close as you can to the chamber.
He said it worked up to 10 kilometers. If I move them any closer, you'd be covering the laser image.
Okay. Yeah, because I'm just thinking that
I definitely agree with you with the current. There isn't
movement.
much current in this thing.
Sorry?
Alex Robertson, Startron, he mentioned that it was rotating superconductors. That's a different experiment, like Robert Chambers said. But if you manage to get this set up and get a rotating superconductor, oh my God, I'll definitely buy you a drink. If you can make
he might be right.
spin.
He might be right because the rotating superconductor makes a London moment, which is like a magnetic field, makes its own magnetic field. So that could help. You know.
Oh, it definitely will help if you can get it to do it. That's another thing.
It's not exactly easy though.
No, it's not easy.
That thing's glued right in there. It's not moving anywhere.
Well, no, this setup is for sure not going to do it, but you could devise a setup that can do that. Apply liquid nitrogen, high voltage, rotating, Helmholtz coil, and conditioning coil. Damn, you're good. So yep, that's it, guys. That's it, guys, with this experiment. We're gonna continue running some more experiments, and just because APEC is ending here doesn't mean it's the end of the experiments. Definitely be sending out some links and doing live streams here and there.
The experiments can never end.
Yeah.
And there will be more
I'm
even
gonna be
once
doing a lot
this
more.
shuts down.
Well,
Mr. Reif and Gerald, myself, and many more.
so on that note, guys, Mark, let me put this thing on here. Let me unpin this. And let me put this on gallery view. And everyone, please give, again, a tremendous applause to Mark Sokol. Mark, that has been a wonderful long-term project. You know, and the thing is, even if you get a negative result, it's still an experimental success, right? That's the way I look at it. You got all of the issues fixed with it. So it's like Thomas Edison with the light bulb, but at least you made the light bulb, and the light bulb is well built, right? So even if you get a negative result, which may not continue, every time you test this, you're able to do little things, and then sometime you'll hit it. So
Right, it's tweaking it each time going forward, and each one that you do, you record it so it's documented, then you tweak something, try it again, and hopefully get a new result out of it. And Mark is very excellent as well with Falcon Space at sending out notices well in advance, days in advance of when he's doing his live experiment streams, unlike myself, where I'm usually kind of spontaneous, but getting on the Friday night science streams on a regular thing.
Spontaneous, you mean by sending me a notice at 2:30 a.m. that you're going live in 10 minutes?
Right, yeah, so It's because I work with a lot of Australians and Europeans too. But yes, Mark is very good with days in advance notice, and I'm going to be working on doing that as well as not just the spontaneous midnight science stream.
Okay. Well, we can open things up for open discussion if you guys want. Do you want to do that?
Sure, let's have a long open discussion. Gerald, when are you doing a presentation? Now's your last chance.
Okay. So yeah, we're in open discussion now, guys. So
or I definitely would have done one this time. I was not set up for it. I got notice actually.
You can just go ahead.
Yeah, go for it, man. Just hook it up.
Mr. 7 hours to prep says so.
Mr. Which? Sorry.
Now or never.
I was saying, Mark said it was 7 hours for you to set up, and now you're just putting Gerald on the spot.
Totally.
Well, he doesn't have
that's okay.
Everything up, he can just talk about it.
Yeah, if I had something set up to show you, I would, but I've been moving my stuff out to a different location because I'm getting ready to build something a little larger, and I need more space in order to demonstrate it. So half of my gear is there, half of my gear is here, and that's basically where I'm at. But yeah, I work with electromagnetics on quite a different scale, I would say. It's all geometrically formed. It works on different principles like the dichotron instability and the skin effect, and there's actually quite a few different things that come into play, and they've all been mentioned here in APEC. I was putting together a presentation, but I don't have quite the language that you guys do. So I have a language barrier, I guess you would say, when it comes to explaining that which I've come across. I've been working on it for a while, but I work with coils in a sense where I don't use theory and I don't use mathematics. I'm what's the word I'm looking for?
Experimentalist.
Definitely.
Yeah.
I love to.
And that's what George Hathaway is.
An experimentalist, yeah.
Yeah, and Hutchison too. But yeah. So
I've met John Hutchinson actually in New Westminster in British Columbia just before he moved. I lent him my truck in order to do the moving. So yeah, John Hutchinson's definitely a different individual, but that's a whole other story.
Right. And sorry, I just got to interject. Both John and Nancy Hutchinson, great APEC panelists, and now we're doing a series with them on the crystal battery builds. And I've done two streams so far on my channels with them, and we've got a third one coming up next Friday with John and Nancy Hutchinson covering their crystal batteries as well as some of John's EVO stuff. And I'm also supposed to be putting together one in the next couple of weeks with Bob Greenier and John Hutchinson again, and talking about how Bob's been working with others who have been verifying the Hutchinson effect through experimentations of their own, producing EVO.
Yeah, and that's the other thing that I've been doing. I've been getting set up for making, so far there's 13 kits made that are going to be going out for people to verify my work. Because you guys have seen a video in the past and a lot of people questioned it, and I'm not going to elaborate too much on it other than when I'm ready to do a demonstration, which should be very shortly. I was kind of hoping to do it in this next coming month, but with APEC gone, Bernie's channel, whatever, it'll get out. But the kits that I'm making, I believe I need about 25 of them for the people that are interested in recreating these coils and then recreating the experiment that I'm referencing to. And I know a lot of people on APEC here know what I'm talking about. I'm not going to get into it in detail, but let's just say, yeah, I've come across something that is truly amazing. It has to be given to the world, and I want to do it openly and freely, but I've been doing it slowly because there's different aspects that these coils in geometrical form do. There's the food growth aspect of it. There's possible healing aspects, or should I say there's possible fields that are created that allow the human body to access the natural healing ability. So I'll put it that way. Can it heal things? I won't say that because it's undefinitive at this point, but these coils definitely do very interesting things. And I believe it's because they're geometrically based and bifilar. Bifilar allows these systems that I've been working with, as far as my understanding goes, to be almost superconducting. Again, that's something that has to be confirmed by others because I'm just a voice in the dark, right? But yeah, it creates a spin. I've created a null zone in the center of certain different coils. My whole goal when I began all this was to create an energy system without moving parts. And then it kind of evolved to the point of I was seeing different fields and different things happen that were definitely a phenomena that I had never heard of before, and had to get into alternative propulsion and Feynman's work, Tesla's. I worked a lot with John Bendini's stuff, and it brought me to the point where I am now. And my understanding when it comes to gravity, it's definitely geometrically based and bifilar, because you can control the flow of energy and capture that very flow as current itself, and then revamp it back into the system. So that's kind of where I'm at now. I don't have, like I said, I wish I had been ready for this. Kind of put me on the spot, guys. So yeah, that's me in a nutshell. Basically, I've been working with coils for about 11 years, roughly, give or take. And like I said previous, I've made about 150. Not have all worked. I've made some very strange coils. In fact, this one here, I don't know if you guys can see that. That's three-dimensional. I work with that one on a regular basis, and this one has had some very anomalous fields created because of it, depending on how I wire it, bifilarly in series, or my primary, my secondary separately with a piezoelectric on the other end. There's different aspects that come out in these coils when you wire them and pulse them in different ways. I could give you an example of my very first coil. Hopefully I'm not boring too many of you here, but I went from something like this, which was an absolute disaster, to something like this, which is a Starship coil. I've made Bendini coils in the past. In fact, I believe I have one right here. And then there's these coils, which are identical. They do very interesting things, which I will be putting in a video in the next few days. I don't know if anyone's been keeping up on my channel, but I've been showing how certain configurations of coils can create spin and magnets that are floating on the water. So take away the resistance, and it shows you a very good example of how you can control the spin of magnetics in that sense. So that's basically all I have for you. I apologize, it's not more. I'm almost ready to do a big presentation, and that's why I got this very specific device here, so that I can complete the work that I've been trying to show for the last 6 months. And hopefully in the next couple, or I would have to say in the next couple weeks, I'll be ready to show something definitively. And as soon as I do, I will be getting all those different kits out to individuals so they can wind the coil the way that I've wound it. They can do their own tests. I'll give them all the schematics on every circuit that I've ever used, a breakdown of the different experiments that I've done, and my conclusions in those experiments. And then I will allow everybody to come up to their own conclusion, of course. And let me know once you get the kits and figure out either I'm deluding myself, which I know I'm not, or we have something real here. And if we do, it should be distributed immediately. Let's get it to everybody. Free, get it out there. That's just where I'm at. So thank you for the time. I really do appreciate that, for giving me a few moments to speak on what it is that I'm working on. Was there any questions or?
Oh, no, well, I would just mention, so it's open discussion. So, it's guys, just unmute yourselves. But yeah, no, Gerald, I appreciate your coming and talking about your work. Your coil people have been telling me about it, and then we had a back and forth. I was like, come on,
I didn't have a laptop at the time, and the computer that I did have got hacked. And the time that I was trying to set up to be on APEC, my channel got hacked. In fact, I don't even have access to it anymore. I've been locked out of it. So I had to start a new one. And I bought a laptop to get all prepared. So now I'm finally there. I'll do proper presentations in the future.
So I just posted Gerald's new channel in the chat, the Zoom chat, and Tim, in a couple months' time, come springtime, when you're all caught up in work and Gerald's got his presentation fully together, I'll make sure to send them over to you for Tim Ventura's interviews, and I'll just about to post your YouTube channel in the Zoom as well for everybody, to make sure that if you love the classic APEC of Tim Ventura, to go over and subscribe to the Tim Ventura channel.
Yeah, I'd love to apply for an interview with you, Tim, in the future. After this big demonstration I'm going to do.
Well, and there's a lot going on this year. And again, this is why I need to put up, I'll put up links. I'll do a blog post, probably the final blog post for everybody. We'll have links to all of this because there are so many different resources online, like I know that you have a channel where you've been doing stuff. I think that probably the biggest central channel that I know of is probably Jeremy Reese. I really think so. I mean, and it has been, right? And that's, I have to applaud his work for like 15 years. And, the thing that gets me about it was if you guys think back, he really came out of nowhere. I remember, was it like 2007 or 2008? And it was just like, I remember those first few videos that he did, it was just like, who is this guy? And at the time, the thing that got me was a lot of those he was covering really complex topics that I've been studying and I've been talking to scientists too. And it was like, he's able to synthesize it and boil it down. And he would take something that somebody would explain to me for like an hour, and it would be like this 5-minute video. And I'd be like, holy crap, how did he do that? And it was just one after the other, after the other, after the other. And so it's no surprise. I mean, he's got like, 100,000, 120,000 subscribers on YouTube. That doesn't surprise me in the slightest, and he's still doing it. I mean, and when you think about the amount of work that he's done, it's just incredible. So that's the one that I keep coming back to. And then the other thing that I would mention to everybody, this is well, I guess it's open discussion. This is kind of off topic, but when Elon Musk bought Twitter, right? And I use LinkedIn a lot. I really like LinkedIn for business networking. And I saw these stories about Twitter is going to die, this, that, and the other thing. And I started to basically resurrect my Twitter account. And I thought my rationale was Jeff Bezos bought the Washington Post. And I thought, well, why would Elon Musk buy Twitter? It's because that's where the news people go, right? And so if you want to interact with news people, that's where you need to be. And so I started to get back into it. And Twitter it's smaller in some ways, but I'm having pretty good success with it now. And one of the things that I like with it is, honestly, going back and using it after years and years on Facebook and even LinkedIn, Twitter is a lot cleaner. That's just me. I know I shouldn't speak ill of Facebook, but I'm getting burned out on it. It's like every time you go to a page, there's, 6,000 different ads and plugins and this, that, and the other thing. So, yeah. And then
for some reason, Twitter kind of finds the subject you're interested in, so you have a push notification of all the stuff you're really interested in without even registering, so it's kind of amusing.
And the other big one, people have been telling me this, and if you guys are promoting your own stuff, just keep this in mind. The other big one is Instagram. And I've had some success with that, but Instagram is tricky because they don't let you put links in, right? So you can put up photos, you can put up videos, you can point people to it and build followers and all that. But then if you want to link back to real meat and potatoes, you can put the link in there, but people have to kind of copy and paste it, which is frustrating. So.
Matthew, you're back.
Yeah, I'm here. I'm just trying to be careful with my mic and camera because I just got into town to see my family. So it's a little bit noisy, so I'm just trying to keep it low.
I did hear about with Rife. I heard, this is something I heard years ago, and I heard it explained well. It was a gentleman named Mark Hugo. If you look up Mark Hugo Rife microscope, I think I filmed this and put it online. The major complaint about this was what he told me. He said the major complaint about Rife's work was Rife said you can target cells with different frequencies. You can target organelles in cells with different frequencies. And the major complaint was, they said, well, how could he know that? Because he didn't have a microscope in his time. Well, as you know, there was the Rife microscope, and there was this debate about, well, no, it couldn't possibly work. And Mark Hugo actually looked at the microscope. He's a nuclear engineer, and it had a jelly in it. And I don't remember his exact explanation, but he said that this gelatin that went in the microscope was using some kind of an interferometry effect. And so he said that mainstream science probably missed this, but he said the Rife microscope did work. It worked as advertised. And then the other thing that he had told me, if I remember correctly, was he'd said this was another thing, was that they didn't have a sensitivity booster on it. He said this is a little known fact. The human eye, if you go completely dark adapted, you can actually see a single photon. You can't see it well, but your eye can detect a single photon. And if I remember correctly, one of the things he was saying was that Royal Rife would dark adapt for like an hour before he would use the microscope, and then he could see what was going on. So I would look at that as validation. That would be, and that was how he could tell what the different frequencies were doing.
Yeah, so with the thing I do recall him talking about dark adapting for an hour or so before he would look. And the gelatin that you're speaking about, what he would do is he had two crystal quartz lenses that would kind of go together. And now they have them flipped over. Wherever I've heard this microscope is that, but he had them and they were a concave design that went together. And he would use a light and use a prismatic effect where he would shine a light through. And then when he'd look through the microscope, whatever he was targeting, he could see the light refraction off of that. And that's how he could tell the frequency of it.
Yeah. So, I mean, that would, and yeah, again, without jumping into the medical part of it, I know they're coming back to this stuff, right? It's just, it's that giant, and they're doing this in mainstream physics too. I mean, they had that in quantum mechanics. They keep going back and forth about stuff in quantum mechanics, and they just came back to the Bell theorem from the 60s. So
yeah, it seems like a lot of this technology is really, peeking its head up again, kind of like electroculture with farming and things. A lot of this stuff is coming back around to where people are being more interested in it. And like all this stuff, you know, a lot more people are getting in tune with like frequencies and just resonant frequencies all in general. I mean, just like what we're talking about with propulsion, because the Earth has a magnetic field, it resonates at a certain frequency, and everything is energy. Energy cannot be created nor destroyed. Everything has its own specific frequency.
Yeah, you know, it's interesting too, and this is just something that I've noticed. But like I don't actively. This is just me, my bent. I don't believe in suppression per se, but I do believe that things get lost. And one of the things that I saw, this was back in the 90s, and it was ancient then. This was a book from the 50s. A bunch of scientists had gone through Tesla's papers, and they found electrical conductivity for the Earth. And he was talking about there's that 8 Hertz cycle, right? And he had documented that, and they documented it later. They took his notes, they typed it up, and they were talking about lightning strikes, how you could time lightning strikes. And if you did the math, the lightning strikes proved this 8 Hertz cycle. It's not exact, but whatever it was. And the thing that got me about it was, I remember I took this book to a professor and showed it to them, and they're like, I've never seen this before, you know? And it's not that it was suppressed, it just kind of got overlooked, right? It was like nobody knew what to do with it, and so it went on a shelf and they forgot about it. And then meanwhile, it was just sitting there the whole time, you know? So
yeah, and that's what's really interesting is that with all of this stuff coming up, I really enjoy it because it's diving into history, and you get to find out a little bit about history that we don't know or we were never taught, and you get to find out about these sciences. And this was a springboard effect for me to be able to jump off of it. And also, I've studied all this growing up since I was 5, so physics and everything. Like, I'm not, you know, classically trained as an engineer of any sort. But, you know, growing up hands-on, it's helped out with my creativity to where it's not putting me in a box. Thinking outside the box, but stay inside this one. So all of these sciences, like, I'm super open to it. The electroculture, I'm excited to see what happens with it. And the same with propulsion, because, you know, if we look back in, you know, back in history that we don't even know about, all this signage and everything, and talking about who came here to Earth, who built the pyramids, maybe that's coming back around too. That's exciting to me as well, just to see it come about.
yeah, there's a lot going on. There's a lot going on, you know. And this UAP thing that's happening, that I think that's really interesting also. I think that's going to make us examine ourselves a lot more.
Yeah, so I mean, even with that, I was speaking to somebody just not too long ago. What happened to the generation of the dinosaurs? What happened to the generation of the saber-tooth? What happened to the generation of the Cro-Magnon? And so with all this cycling back around,
the Younger Dryas event, as Graham Hancock has now been proving with Randall Carlson, and you get called racist for just looking at there being a advanced civilization around the time Plato claimed Atlantis existed, apparently. But that's a discussion for another day. We will keep it on propulsion. Thank you, Tim.
Yeah, there's a lot of history. There's a lot of history, and there are a lot of new things happening too. I mean, it's not as exciting as this stuff, but one of the things I've been covering in my interviews is drones. There's a lot going on in drones right now. That's really interesting with the Ukraine war. I don't know if you guys are following that, but I mean, basically the Russians have recreated, well, the Iranians are making it for them, but they've recreated the buzz bomb. That's essentially what these, if you guys read about those Russian drones in the news, and actually if you look it up, I saw it looks like a magazine. It's like a magazine for cartridges. There was this big ladder, and it was stacked with drones. One of the drones takes off the bottom, goes to destroy its target, and then all the others ratchet down, and they all come down, and then one at the bottom fires just like a magazine for a gun, you know.
Yeah,
and
they have a the problem is going to be a problem because they're gonna have clouds of drones that are going to attack like a specific target. So you need a way to wipe them all off, you know, very, very instantly, because it's a cloud, you know. You can't just shooting one is not enough. You need to shoot 100 downs at the same time So there's going to be a problem.
Yeah, it's. I think it's going to become, from what I've seen, in terms of military drones, it's one of those things that hasn't. It's like the public is starting to become aware of it. It hasn't hit them yet. When it hits them, people are going to freak out because, you know, right now, so it's still pretty rudimentary too, right? Like but I mean, the Russians have done 330 drone strikes against Ukraine, and Ukrainians, they've got their own drones, and they're doing the same thing with the Russians. And then the other part is all of these other countries are taking note, right? So like China just announced they're going to start making these weaponized drones. And then if they do it, then we got to do it to keep up. And so now all of a sudden, you know, everybody's doing these things.
But one thing I don't understand is, I know we have the technology, but why can't we fry poutine using a laser from a satellite, something like that? I know we have the technology, so we could just end it right now, you know. But
you mentioned, did you mention poutine? You did mention poutine. That's your Canadian giveaway. Half of your audience here is like, what's he talking about? Poutine at Tim Hortons.
Yeah, exactly. Poutine is I forgot the name. There's a place in Montreal. It's very famous for that. I forgot the name.
I like, I've had real poutine once. Tim Hortons stuff is kind of, it's like hot lunch poutine, but
yeah, it's a emergency place to go if you really need one.
In case anyone's wondering what a poutine is, if that's what you want to call it, or a poutine, it's French fries with cheese curds on top and a ton of gravy so that the cheese curds melt. It's all
great Canadian thing, eh? It's not no Russian Putin. It's a great Canadian.
Yeah, it's like what would you think of it as? I would think of it as like Canadian chili cheese fries, kind of. That's
amazing analogy. You're right.
Now, if you're feeling crazy, I tried this once. It's good. The timing has to be perfect. French fries and ice cream. I know. That's all I'm going to say. You dip your French fry in ice cream. If the French fry is if it's not hot, it's disgusting. But if it's just right, it's amazing. So
nice.
Yeah. If you're feeling courageous, that takes some courage.
Geosynchronous orbitals, like satellite orbitals, like those are geosynchronized with the orbit of Earth. So they're always beaming in one spot on different levels of orbital. So really, you always have an eye in the sky, you know, just depends on the different bandwidth of, you know, where they can get locked, you know, in two different states, and then it creates an orbital. So, you know, you guys were talking about viewing this. Well, yeah, I mean, it already exists, you know.
Yeah. Well, and they'll exist more too. You know, one of the things, this is kind of like drones. It's one of those things. It's not a breakthrough per se, but when I think of satellites, I'm thinking of the old days, right? Where you think of like, okay, satellite over here, and it's doing like, you know, TV broadcasts. There's one over there, and it's relaying communications. But if you look online, and it's easy to find this on Google, you can find maps that show all of the satellites, and there are hundreds, if not thousands. How many? Let me look this up. And in fact,
it depends on how high the ones that, like, you know, supersede the ones on the lower. So the higher ones are fewer because they can connect, like 3 of them can connect, you know, everybody, encapsulate everybody. Just, you know, if you do it like, I mean, you know, as a relay.
Okay, so Lulu, there are 8,261 satellites, over 8,000 satellites in orbit. Of those, because they don't last forever, it says 4,852 are active. So not all of them are active, right? You've got about 5,000 active satellites, and then you add in all of the junk, and believe it or not, this is the part where it's like one of those, it's kind of mind blowing. in its own strange way, the Earth is starting to develop a ring, except that in our case, it's a ring of crap floating in space, basically. But
You know, like the asteroid belt is also a ring of broken stuff, you know, like, I don't know what, but,
yeah,
you know.
it's strange.
Stuff.
It's strange to think. It's strange to think, you know. And Starlink is going to make that. I mean, Starlink will make that much worse, because Starlink is deploying tons and tons and tons of little mini satellites. So.
Yeah. I don't know how many brain neurons there are there, but they're probably going to try to detect every little possible thought you could think by every measure, you know. I mean, that's the future of why would you have them? You know, it's a frequency. We're the void, and everything else is man-made, you know, other than like trees and grass, but like a world. So it measures the reflection of everything around us and writes an algorithm, complete, a digital one, of a code of our existence from every little thing that is around us, from the chair we're sitting on, the headsets that we're wearing, the, you know, because like from the microphone to this, that's a frequency. And then from there to the board, and that's another frequency.
I wouldn't worry. I wouldn't worry about being spied on by satellites, though, to be honest. You know what? If you, I mean, the number one thing for surveillance is bank records. That's what they use. It's bank records.
It's the evolution of how could we transmit a signal. It's not a local idea to Earth. It's the idea of how could you transmit a signal to something far beyond. You know, that would be the hope of such technology. It's not to use it against each other, but to see how we could all advance it further, you know, further than our internal, like, whatever, you know, disagreements. But as a science, that's what I believe we're striving for, you know, like, would our species survive elsewhere? I always ask that question, because, I mean, will it? Let's just say nothing happens to here, but will our numbers grow to the point where we actually need a place? You know, and this is, you know, on a futuristic kind of idea. It's not because of this stuff. No, it's like you want the other place, you know? Yeah. Yeah, I'm sad to see this go, because it was like my tribe, you know, like I connected well. I understood.
And it's a community that's still here. It's a community that's still here. The entire community is still here. It's spread out and it's diverse. But, you know, again, with this conference, I think that the way that it was structured and the way everything was put together and all that, I think it's just kind of reached its time. And, you know, and like Mark had said, it's kind of like Seinfeld. You know, it's better to go out when you're there instead of watching it kind of go downhill over time and saying, oh, I remember the good days, you know. So
yeah. Like Kurt Cobain was saying, he was saying that it's better to die on your hide than you know, fade away or something like that. But are you planning to have like at least a conference once a year or every 6 months? Or?
Yeah, I mean, potentially, that's, you know, that's something that we could look at is trying to come back together. You know, I mean, a lot of it depends on, you know, like the pace of the research and how things progress and all of that. But you know, I think one of the challenges is that you know, especially with presenters, right? I think everybody is a little tired, you know. And yeah, and most of our presenters who have, you know, like I'm thinking of folks like Gary Stevenson would be one, you know, where he did, I think, 3 or 4 presentations, you know, and there was Mike Gamble did. I mean, he spent most of last year like just doing presentations, you know, and so folks are just tired. And, you know, and then the other part is we've gone over a lot of the same material so many different times that it's just kind of becoming repetitive, right? So, I mean, there were lots and lots and lots of different reasons, you know, and so I think it helps to just focus for a while, you know, and then we can kind of look at things in the future and say, okay, where is this community at, you know, So part of it's that, and then the other thing is, you know, it really feels. I'm thinking of Bernie's back room there. You know, it's had kind of a Woodstock vibe to it, right? And Woodstock had a beginning and an end, you know, and it's
many reunion events, which APEC Year 3 reunion conference. If you don't make it happen, Tim, I'm going to be sending Andreas Zertis out in California to find you.
yeah. Well, because
He'll
think
make it
about it,
happen.
you know, I mean, if Woodstock was still going on today, people would be like, what happened to that? But you know, but it was one of those things where it was like it was this really special thing. And with APEC, the thing that got me about it was it was one of those things that really only could have happened during the pandemic, you know. It really was. And you know, but I think now we were able to say, look, this works, this model works. And so now people are able to do that for different things. And I see little things happening like that all the time. Like Bernie, you do group calls with what, 5-10 people on them sometimes, right?
Absolutely. And Tim, maybe an idea going forward would be to make APEC a once-a-year conference, but actually a meetup conference as well, and make it a whole weekend event somewhere going forward. Who knows? But that's a potential as well that you could evolve it into.
Yeah, and we talked about that. I just don't want to commit to anything right now, you know.
Yeah, it would be great to have a
Year 5.
Yeah, it's like my training center. They have fighting events, but at different schools, you know, they rotate the location, so it's never the same location. So that would give a chance to everybody all over the continent.
Yeah, and then in the meantime, everyone has stuff they're working on. Phil, you have finite theory, right? And do you have experiments based on that you're working on, or are you just continuing to refine your theoretical model?
No, I'm done with the theory, and I have the design. I hired somebody to make the design using a software. I forgot the name. Something works, or I forgot the name. It's a popular software. I made the design. I hired somebody last year. I have the design, but now I'm waiting. I ordered the Gal instant from China. I paid $4,000 for it, but it's pretty slow. You know, I did a wire transfer. Everything is slow right now. I'll have to 3D print the apparatus. There's a good web 3D printing service in Montreal that prints things in plastic or steel, metal, everything you need. So it's great. You just submit your design, and it prints it and mails it to you. So it's pretty cool. I'm sure that there's some service like that in Seattle or New Jersey and all that. So I'm gonna test the experiment. I'm gonna hire a physicist. I know my own boss is a physicist, so I'll hire him to double check you know, the resistance and all the electric circuits and all that. And then I'll perform the experiment. But I'm not scared at all, because I already did the a lower scale, a scaled down version of it last year. I remember. So I had positive results. I'm just scaling it up right now. I also made the calculations for the gravitomagnetic permeability. It took me some time to figure it out. It's very simple, but I can't share it, unfortunately. But it gives the amplitude of the force you'll get by spinning the liquid metal using the vortex. So yeah, by the way, I figured out that the gravitational redshift, there's a lot of information you can get out of this, a lot of it, but I can't share it. Otherwise I'll kill my own company. But there's a lot of information out of the gravitational redshift you can get. It's very interesting. So yeah, that's that's where I am. I'm also in touch with like important people in the military. So and also I'm back on my C++ superset software to hopefully I'll be able to break the ice. Get hopefully sell it at some point, but we'll see. It's another cool software I'm pretty proud of also. And yeah, that's about it on my end.
Well, that's a lot. That's a lot. And, you know, give that time, we'll be able to kind of, you know, figure out where things are going. So yeah, everyone here has projects that they're working on. Everyone here has things that they're pushing forward, right? And, you know, and for most folks, this is a long-term development process too. And there's nothing wrong with that. That's part of creative development, right? So
yeah.
Yeah.
By the way, do you do web design or something like that? I see your website is pretty amazing. Did you do the design yourself?
Yeah, I did.
That's cool. Maybe I can hire you to create a website for another company. We're gonna start on it's a real estate company.
Well, no, I appreciate it, but yeah, that's what I would strongly recommend for website stuff is you don't have to find a local designer, but find someone who does that for a living, who has that kind of structured. So because it's a lot of work.
Yeah, we have one for we're gonna redo the Fornox website in WebGL, and we have one a pretty good, amazing one in Toronto, and he's doing an awesome job, and he's very patient, and he's very good. If you need WebGL at some point, just let me know. Yeah, so you guys are lucky, man. American people are so lucky. I very envy you, all the grants that you have for deep tech projects. It's amazing. I wish I was there. I wish I was living there, but
you know, but I would say in Canada though, I mean, it doesn't seem like that there's much that's missing. You know what I mean? I mean, it seems like on the internet, the biggest challenge is the language barrier. As long as you're fluent in English, it doesn't seem like much is missing.
yeah, but they don't give grants like for deep tech, and they don't risk, you know, they don't invest in risky stuff. That's basically what it comes down to. So that's why I'm saying it's amazing. You guys should take advantage of it and be proud of what you have, because even in Europe they don't have that. So you guys are lucky for that part.
I love the States, don't get me wrong, but one big thing that I don't like about the States when it comes to inventing is that if it has military application, there's a law in place where the government can literally come in and take your invention and it's gone. They're using it for their uses and you get basically shut down. And there's nothing that you can say about it. There's no law like that standing in Canada as far as I'm aware. So that's the only downfall I gotta say. But other than that, you're right. Their grants are amazing.
Yeah,
that is actually true, guys. I'm just cutting in. I'm Alex from England, and I work with a friend called Tom Burgess in the States, and he was a relative. His family was a relative of Tesla, and he's had a lot of problems with his technology. He works on very advanced graphene technology, and literally everyone has been throwing their money at him to try and control his patent activity. So just be wary when you guys start floating or going public that they are very clever what they do. And Jeremy's lecture, a lot of that was, he may not have understood, and nor can I pretend that I understood a lot of the physics, but what he was saying about the way they hoard up and collect and do all these patents, these guys have been doing it for 100 years. So just try and think ahead and logically and calmly and be patient and try not to fight too much. Just think logically, because what my friend Tom Burgess is doing, he's literally selling something called Quantum Shine. I'm not pushing it, but it's just a little car wash. His stuff is graphene. some of his stuff. He can make diamonds. He just manufactures diamonds the size of little cherries or grapefruits. For him, he's not interested in money. And I just want to say, guys, this is my first APEC conference ever. Tim invited me by Twitter. And you guys are absolutely amazing. I'm a schizophrenic sort of whatever, and I love suppressed technology and alternative technology, and I collect and I hoard information for 20 years. And I try and reverse engineer a lot of the technology, but my lifestyle inhibits me. But I just want to say to all of you guys, I think you're amazing, and I'm very much a conference person, but normally I do mainstream science and spirituality, and this is my first alternative live conference on Zoom, and I'm so grateful that it's the last, that I've witnessed the last APEC. I know a lot of you are obviously very sad, but I just want to say to all of you, I think you all are amazing people. And I wish I could manifest what you guys are doing in person. I do weird stuff like psychic stuff, and I've got problems and military and all that. I'm used to that, it's not a problem. But I just want to send you all my love and wish you all the best. I just wanted to give you guys a big hug from England. Lots of love, guys.
Thanks. And by the way, I heard it's not a good idea to patent because it gives the government more control over your technology. So we're just going to keep it like a trade secret.
Yeah, I'm open sourcing all my stuff because, you know what, I've had devices in the past that I've gotten into business with somebody and they basically took it and ran with it. And at this point, it's, you know, at my age, I've had an awesome life and it's not about the money for me. So I'm just open sourcing everything. I completely understand people that are building businesses upon their tech. All the power to you. I think that's awesome. It's just I'm doing it a little differently. That's all. But all the power to you, my friend.
Yeah, salute, brother. So yeah, but when I'm talking about a lot more, when I was talking about the gravitational redshift, it's a lot more than anti-gravity you can get out of it. It's like it makes, I'm not sure if you saw my presentation, maybe I can post it on Zoom, but the Zoom chat, but everything I was talking about, like the tractor beams and all that, it's really a reality. It's very easy to do also, and I just can't say how, but I'm just saying there's a lot of things there's a lot of potential there.
Yeah, there's even force field potential as well.
Exactly.
If I understand correctly, yeah.
Cryonics, like time travel into the future, cryonics, perfect cryonics.
More like temporal pausation, if that's the term. Yeah.
Gerald. Hey, Gerald.
Yep.
You've probably talked about this. People bug you all the time, but I haven't really asked you or whatever. But anyway, your coils and stuff. Can you attest to the fact that there is like a matter repulsion effect? Like, yeah.
Oh,
okay.
Yeah.
Interesting.
There's actually there's a field propulsion effect that you can. What's the word I'm looking for?
Like it'll actually push away, matter, plastics, paper.
Well, I'll put it to you this way:
force, essentially.
If you have it on and you walk too close, you feel it.
Yeah.
So, I mean, there's a lot more to it than that. Don't get me wrong, but it has repulsion aspects. Sorry, Brendan?
I was wondering something. Since last APEC, we haven't gotten a chance to see it on here yet, and Jeremiah seems like he's kind of gone incognito mode. Do you think that, I mean, now or never, could you share any extra details about the thing, like wave shapes or frequencies or power levels or anything?
Well, frequencies actually, I've been they're actually kind of low. I use two separate frequencies. I use 7.83 hertz and 880 hertz. Sometimes I use 7.83 hertz and 261, depending on the effect that I'm going for. Like there's a stability that's involved. There's a couple of different factors, but like I said, I don't want to get too much into it because I want to explain everything that you guys saw and what I'm doing and the tech all at once. And you'll get it in a big package. It's just sad it wasn't on APEC, and that's my bad, and I apologize to the audience for that. And you
But you're
guys.
still gonna do it on my channel,
I'm
your
gonna
own
do it on
channel, and
Bernie's
hopefully
channel,
Tim's channel in the springtime.
And that's why I said it's all open source. Everything that, all the questions that everybody has about the video that's in question right now will all be answered. And I will make sure of it. And you can ask any question at that point and I will answer it in full detail.
Is this not anything to do with Jeremiah? I'm really concerned about him. He doesn't answer anything anymore. Like,
oh, he's doing his thing. He's heavy. He's deep in doing his work right now. Let's just say that. And
okay, so
I've had a lot of private videos, discussions with him, and where he's showing me stuff that I'm not allowed to publish yet, but it will be coming forward in the future.
Yeah, that's why I say he's in deep right now. He's sort of like incognito, but not quite. I've talked to him multiple. I talked to him yesterday, actually. So yeah, he's doing okay. He's just he's really concentrating on everything. He's pushed everything out in the outside world for the moment, as far as I understand. So I can't speak for him, but yeah, he's doing okay.
I just wish he would have said something, you know, like, hey, I'm not going to be answering any messages. I don't hate you anymore. I'm not, you know, we're still friends, but like, so it's been a little hard to wrap my brain around. So I've, you know, because I consider him a close friend and he just shut me out totally. So I don't know.
Yeah, like I said, I can't speak for that, but at the same time, I know he's okay. He's really deep into it right now. Yeah, so.
Gerald, just one follow-up on what you were saying with the two different modes that you use. Can you identify what the low one does versus the high one? What having a high one does?
So there's energy aspects to this system, and then there's propulsion aspects to this system.
So like one is you get extra energy out of it when it's in one of those pairs, and then you get propulsion when it's in the other pair.
Yeah, and grounding comes into play as well. And you could say ground pumping. That's probably not quite the right term. I'd have to look at my notes to actually go over exactly how I what's the word I'm looking for? Equated to that. So
do you know if is it emitting a RF signal downwards that gets reflected off of what's ever beneath it to create some kind of standing wave like La Violette describes?
Well, there's definitely an RF signal involved.
And that signal, Violette described it like a soliton, like a standing wave, and that the better your Q factor is, the more energy you're able to store in that standing wave beneath the craft.
Yeah, I can agree with that. Yeah. Yeah, when I do the demonstration, you'll understand, because it won't be just one aspect that I'm going to show. I'm going to show it all. I'm going to do the energy aspect of it. I'll show the video and the notes of the food growth that I'm working with. I'm working with mung beans, and they grow within 3 days, and they actually can grow in the dark. So it makes for an interesting experiment. And then go ahead.
The plant growth, I was really curious when you mentioned that you're using it for plant growth. Is that under the energy pair?
Under the energy? Yeah, actually, it's the lower one, 261 hertz. It loves that frequency for some reason. Now, I have to make this point, though. It loves that frequency with that specific geometrical shape of that coil. If I was to change, if I was to change to a different coil, it would probably be a slightly different frequency. But the one that I'm experimenting with right now, 261 and 7.83 seems to, it just loves it.
When do you think you will upload another video demonstration of a levitation one.
Sorry about that. That will come with the big presentation I'm going to do on Bernie's channel.
So probably a month or so, because you're saying you're
Okay.
setting up.
Yeah,
maybe
maybe a little
a couple
less, but
months.
yeah. See, I was looking forward to doing the APEC in February, but I'm gonna try and shave some time off that. See if I can do Bernie's at the end of the month, because there's a lot of questions that a lot of people would like answered.
You'll also, though, we're going to be extending this in a stream as soon as APEC's over with yourself and Matthew Reif. I see Mike there from Faraday. Just wanted to show something or say something quick. And Jeremy Reese is back and wanting to maybe shut it down.
Right, then I'll cut out and I'll let you guys talk. Sorry about that.
I'm here. Can you guys hear me?
Yes, sir.
Yep. This is the new carbon graphite battery I'm working on. I just got the new plates in from China. They're a square plate. They're about 10 millimeters thick, or sorry, 5 millimeters thick. I got one strip of magnesium strip on it, and it's giving me 1.6, 1.7 volts. Let's see if I can turn my camera around here. Show you guys. I don't know if I can get it all in one shot here. So the magnesium strip is negative, and the positive is I use copper strip tape, and I'm getting 1.61, sometimes a little higher. So I just added water to it. What's that?
Is that like a homemade battery?
Yep. Yep. I just got the carbon graphite plate. I put the copper tape on it as the anode, and the cathode is one strip of the magnesium, 99% magnesium, and a little bit of water on the paper towel that's in between. I'm getting 1.59, sometimes it's a little higher. Touch it. When I first fired it up, I was getting 1.8 volts. So yeah, just a quick little demo.
Nice work.
So I got 5 plates total. So I'll be making 5 cells, and I'm going to put them in parallel, multiply the voltage, and I should be able to power something pretty good with it.
Not too bad at all, Mike. Not too bad at all.
Yeah, I'm finding that the older design, they wrap the magnesium strip all the way around the rods. I'm finding you just need just a little piece of it to get the same voltage. So I guess, you know, wrapping the magnesium strip around it just adds life to the battery. Because if you see the other ones that are here, these guys here, how I have it wrapped around, spiraled with about an 1/8 of an inch gap in between them. I made these 6 months ago. I fired them up a couple of days ago. They work perfect. So as soon as the water dries, they go dormant, and you just add a little bit of water to it, boom, they spring right back to life. So these have been sitting for 6 months. The magnesium's still in pretty decent shape. They're deteriorating a little bit, but I imagine I could get a good year's worth of basically shelf life, you know, and it's very easy to rewrap them.
And Jeremiah had remade some of those, as well as I believe Michael Boyd had also made some of those original versions of those batteries.
Yeah. Yep. So I got a couple of guys working on them as well. They do work, and the one battery I made was pulling about almost a half an amp of current, average about 250 milliamps. If you do a dead short across the anode and cathode, it was averaging about 250 milliamps, 300 milliamps. That's one cell. So if you have a whole whack of them lined up, like a battery pack, you can power quite a bit. just some of the devices I'm working on. Got the RPG working on that. Made some huge grounds with that. Working on the new generation when I've bought a server case. It's a 6-view server case, and I'll be making my industrial version of the motor generator in that. And then I got a couple of leads that I should be able, I'm hoping in the next couple of months to get the system validated by a professor. So that would be good too.
So I believe Bernie is going to do a stream after this with he got Matthew Rife on a couple weeks days ago, and I think he's going to get Matthew Rife back on tonight. He's the
Yeah, Rife was on earlier, Jeremy, while you're driving to pick up your kids or whatnot there. He was part of APEC, but yes, he will be on the stream as well.
Okay, so I missed that, but he's definitely a family member of the original Royal Rife. Is that correct?
Yes.
Yeah.
Well, he also has his original notes, from what I understand. He did back in, yes, the original handwritten notes.
So I'm really looking forward to that presentation, and I think we're everyone done here. Anyone want to add anything or throw anything out before we wrap it up?
I want to add one thing. Thank you so much for your work, Jeremy, from 2008 till now. I remember being on an interview with you and a nuclear physicist back in the day before, your channel disappeared, and then back to now. Dude, amazing work. I gotta say, you deserve an applause by far, and I think everybody here should be giving you one. So thank you for that. That's all I wanted to say.
You're brilliant, buddy. You really are. You're amazing. Seriously.
Appreciate that, brothers.
Absolutely, Jeremy. If it wasn't for you, I wouldn't be here, and a lot of us, pretty much all of us, wouldn't be here. So you are a major pillar in this community, brother.
Damn straight.
Yeah. It just took some crazy asshole like me to come out and show everyone that, hey, they're not going to kill you for this, and so that everyone else could be like, oh, look, they didn't kill him. We can come out and talk about this too now. So.
I think we all have to deal with.
You can call it bravery. I just call it stupidity. Whatever you want to call it. A little of both. I don't know. But anyways, yeah, I appreciate all the help and support I've gotten from everyone here over the years, and we can't be afraid, man, because this is the only way to save humanity. We're stronger together, and there's the truth. A lie can be, a lie doesn't go anywhere. A lie, it's just lies versus the truth, man. It's so hard. It's like if you're selling a lie, everyone's lining up to buy it, but you can't possibly. It's harder. It's much harder to sell people the truth, and it's not an easy business to be in. And you do get wrong. Something's wrong some of the times, and it's.
The truth will set us all free, and the truth should always be free, right? And it's about bringing the science open source to everybody for us to all show our work and each other verify it and develop on it, essentially.
Yeah. Well, the more people that know, and the more people that are organized and talking about this and bringing disclosure forward, like real disclosure, going to, they just can't stop us now at this point. I'm just watching our numbers growing way larger. We're getting more views than their shows are getting on some of the things. And I do believe we're being suppressed on those numbers as well in some ways. I know that, YouTube still does a lot of interesting things with the algorithms to hide information. It's very difficult to locate stuff with search engines on YouTube when it comes to anything, useful or worthwhile. Seems to be just an entertainment site. But yeah, again, I'm glad. Thank you, YouTube, for giving me a platform anyway, and helping build the YouTube community back in the day, because I was pre the Google merger and all that stuff, man. It's crazy where it's gotten, and we just got to keep pushing just a little bit of effort every day, even if again, 10 years ago to 10 years to now, I look at everything we've accomplished and I say, like, wow, we can really get a lot done in the next, 5 to 10 years. And I think that a lot of these people are on the right track with the physics, man. And it's only going to be a matter of time until one of us makes a breakthrough and shares it with the others, and then they can't shut it down. So
I think the breakthroughs have already been made. They're just not sensationalized. And because they're not sensationalized and hyped up, it's not pumping the algorithm on YouTube, so millions of people are seeing it. Like I see when I see science videos and stuff, it's like PBS Space Time, and it's all these like mainstream physics channels that it's the same.
I love PBS Space Time.
It's all the same stuff about general relativity and all this, right? So they're not going to see our weird videos about our experiments. And
yeah, they're not going to show against the mainstream stuff at all. If you don't feed their agenda, they're not going to show it.
There's a couple of those big channels though, with the big science channels, and I swear they have someone who watches or someone referred them to us, because we mentioned something, and then Action Labs is doing a video on squeezed light, and showing squeezed light and doing experiments with it, and he's like, oh, like it's not a coincidence that some of these other big channels are starting to play around with some of the stuff that we're talking about. And I look forward to more of that in the future.
And what it is bringing together 1,000 different little breakthroughs that each of us are making and turning it into one giant macro breakthrough that will change it all.
The roots of grassroots.
Yeah, me personally, I'm not even scared of being captured by a UFO, because I'm not. I understand I understand everything they're doing, their technology. So if we might not have it yet, but I understand, like, tractor beams and all the trees that.
That reminds me, I got to put a page on tractor beams and those links that Jack Sarfati mentioned, all that stuff. So I can go. Come say hi. Come say hi.
I'm not worried about being captured.
Yeah, because I'm not scared. Some people panic, but I wouldn't be scared. I swear to God.
All right, I'm getting photo. I gotta go, guys. I'll see you guys over at Bernie's channel, and I'm gonna shut the stream down for tonight on my channel.
APEC is ending on the live on YouTube, and I guess if Tim wants to keep it going for a bit, or Mark or whatever, but we'll be starting up the YouTube live stream with Gerald and Matthew Rife and Mike Faraday, myself, and whoever else wants to join in about half hour's time here.
Awesome.
Love you all.
Sounds good.
Legendary.
Philip, I'll email you.
Hope it goes well. I'll try and find you.
Is it Philip or Philippe?
Yeah, that's why just call me Phil, man. Don't. Okay. When I used to live in San Diego, people would call me Felipe or Philippe or whatever. Just call me Phil.
I get it totally. I'll email you, Phil.
You're gonna stay live,
for
Bernie.
sure.
You're gonna stay live on Crypto Alchemist.
No, you can end all the Apex, and I'm gonna start a new video stream here in about a half hour. I'll create the event right away. And I'll do that actually in the next 2 minutes and post the link in the Zoom before it ends. But you can end it on YouTube. Jeremy, thank you.
Yeah, man, my kids are here and they're all riled up and definitely not going to bed anytime soon. So I got to I'm gonna go and hang out with them and spend some time with the boys. And
where do you live, Jeremy?
I live in Rhode Island.
And prayers with
Colorado.
Their mom's health recovering, Jeremy.
Yeah, yes, thank you on that. It was just the kid's mother was in the hospital over the holidays, and it was it's been I was absent for a couple of weeks there on YouTube and stuff, so I've been dealing with that. But she's home, still on medicine. But yeah, thank you for all this. And I'll see you guys. Are you going to be on Andreas's channel as well?
So yes, I'm gonna contract Andreas and make sure he's up and should have him on because I think he was sleeping all day for this. But yes, we'll see you all soon. Happy New Year. Stay blessed. APEC 3-year reunion. It's gonna be live on Alien Scientist.
Apex.
Yeah, let's start APEC 2.0 on
I
your
can just
channel.
make I gotta go through and just make little short clips of all the best of APEC because that there's a ton of stuff there that just needs to be that bears repeating, and I
Sure.
go back through and really do a best of thing and focus on all the experimental work in the next couple of months and getting some serious stuff out there and done and some stuff built because I got a lot of ideas. I talked about that symbol. I want to take a symbol and coat it with the layers, and that way we can trap light inside the layers and also mechanically vibrate it at a resonant frequency. So I got a couple of different ideas and experiments I want to build, like similar things. I want to experiment with that shape because maybe there is something to the flying saucer, but again, not all UFOs are the same. And there's also the ball lightning effect, which is definitely related to UFOs.
Actually, Jeremy, I'm going to end it on our YouTube channels, but I'm going to keep it. I'm going to launch it. Oh no, I can't put it on my Twitch because I'm on your account, not mine. Never mind. Scratch that. It's ending on YouTube, and we'll be doing it on the stream.
Shoot an email, man.
It's Crypto Alchemist and Andreas Zertis with the X. So go check out those streams, and we'll see you guys over.